Hello, everyone. Welcome to GreHack 2025. We are all glad you are here today and maybe tomorrow. So this opening speech is just a quick reminder about the 2 days of the conference. Today we have talks until about 6 p.m. with the ramps starting at 4:55. If you want to present a ramp, so it's a max duration of 5 minutes, you can send them to this email until 4:45. At 6 p.m. there will be workshops. You have the detail here. So we are, well, you can see it. We are currently in Minatec. The workshops are at Felma, but the building just next door. You will get the room number for your workshop after you arrive at Felma. And as you saw, there is a social event until 11 to 12 p.m. We are not sure yet, which will be in this building, in the same dining area that you probably saw this morning. Okay, for a few of you who were lucky enough to get a CTF ticket, the door will open at about 9:30 tomorrow, so it's in building H of the Antimag. There is a tramway stop, which is called Gabriel Fauré, just about 2 minutes, 2 minutes walk from the building, so it's quite easy to get there. And there is a Google Maps entry for the building, so it's easier. Do not forget to bring a network switch, because you will get an RJ45 uplink per team for the CTF, so you must be able to connect to networking cable. Yeah. Just a few extra informations. We have eco caps. We run them so we can reuse them every year. So you can get one, you can use it all day, but at the end of the day, you have to bring it back. And we will have another ones tomorrow. There are separated diets, so if you are not vegetarian, try not to eat only vegetarian food so that vegetarian people can eat also. We distributed at the entrance no stickers, no photo stickers, sorry. If you don't want to be taken in picture or in video, because we will have a cameraman and a photographer this year, wear this no photo sticker, sorry. And if you are taking pictures with your phone, don't take pictures or don't post pictures of people having these stickers, please. During the talks, try not to enter the amphitheater or leaving it, so as not to disturb the other people. And do not forget to visit our sponsors and friends at the dining area. So enjoy your 2 days at GreHack. I hope you will love it. We put a lot of love into this conference, so enjoy. And you have, of course, the Twitter, Discord network, so you can we have some info there, as well as the Wi-Fi network. And so to begin with the first conference, we have our invited talk of the year. It is Gunvail Cordwin. He's an ex-Google employee. He founded his own company, Arcana, and he also created PageDout, which is the goodies you received in your welcome pack. It's a cybersecurity website, and it was really great to work with them as a collaboration this year. So Gunvail will talk to you about Netgear switch exploit chain with a very limited exploit primitive. So the floor is yours.
Amazing. HDMI also. Okay. So. You can take this one. Okay. Hello, everyone. I'm just going to steal a cable before I can begin, and then we can go. Oh, good. I have it, thank you. Okay, does it work? Hey, it works. Okay, hello everyone. So, hi, I'm Gunvail. Now, I'm going to talk a little bit about myself, and this is because I want you to adjust to my weird accent when I'm speaking, because I will be speaking really fast today. And to do that, I'm going to tell you a little bit about myself, which is not really important or interesting. Perfect. So, hi, I'm Gunvail. I'm currently the managing director of Arcana and a security researcher there before I worked at Google and some other companies. I'm also the project lead behind this. So we are accepting articles for issue number 8. Please write something for us. And if you have any comments or something like a comment about an article or my article, which is there, just let me know. And I'm happy to get any feedback. Apart from that, I played in a CTF team called the Dragon Sector. If you played CTFs like, I don't know, 10, 8 years ago, you might know us. And I'm also an author of some books, a YouTuber, and I do a lot of other stuff, doesn't matter. Okay, before we begin, a couple of things. First of all, this bug, which I'm going to talk about, or rather bugs, have been long fixed, like fixed in 2021. So I'd like to thank the organizers for actually allowing me to speak about this, because I never talked about this in English in public. But yeah, just keep in mind that everything is already fixed, for better or worse. Now, also, thank you for coming, because like it's a first talk of the morning, and you actually arrived. I am impressed. Thank you. Now, I'm going to focus on the devices which are in blue here. Netgear has a lot of devices, and especially I will be talking about this device, which is here on my desk. We might even have a demo if demo gods are kind for us. Now, Netgear has a lot of other devices. I cannot comment on the quality of the firmware there, but I will comment a lot about the quality of the firmware, of the old firmware on this device. Now, if you're wondering about like these odd numbers and the letters here, I tried to decipher how exactly the Netgear versioning system works, and I have no idea. I'm sorry. Okay, so how did the story start? So the story started because I ran out of ports on my old network switch. Well, I have a home network, like everyone here probably, and I ran out of ports. So I needed a new switch. So eventually, I decided on buying this device because, well, it had 8 ports, that's quite a lot, and it also had these like small factor pluggable thingies, which I never played with. So I thought, hey, a new toy I can play with. And it's also cloud managed and smart, but thankfully these features can be disabled. So I was like, yeah, okay, let me get that one because I actually really like the design, the metal casing of the Netgear devices. Cool, so I apologize. I will be coughing a lot today because I'm still recovering from a cold. Now, I got some other tools with my Switch because I was pretty excited with it. So I got like, some fiber optics and so on I can test. I also like designed a 3D bracket so I can attach it to my tactical mount on my desk because for whatever reasons my desk has one. So as you can see, I enjoyed the Switch even before I turned it on. And when I turned it on, hey, it was actually working. So I did what any sensible security person would do. I went into maintenance. I went into troubleshooting, and there are usually options like ping and traceroute, and everyone knows that there's usually a shell injection there. So I wanted to test, hey, is this device secure? Can I actually use it without worrying too much, right? So I go to ping, I test some things, nothing. I go to traceroute, I test some things, nothing. Hey, maybe this device is secure. So I go into HTTP layer of the things, and I do a manual curl. It's really cool in Chrome tools that you can just right-click on a packet, and you can select copy as a curl command. So it was really easy to do. And I inserted like this string here. Oh, apparently this button does something interesting. Wow, it reloads my, I cannot use the laser pointer because it actually is F5 as well. Okay, good to know. So I did this like, typical command injection, and I ran another terminal, not expecting anything because the switch is secure, right? And obviously the switch connected. So I was like, this needs some testing before I can use it. Okay, so time for bug hunting. But, well, let's introduce some rules of engagement because this cannot be like any bug, right? What I want is I want a full exploit chain. I want something which, gets me from 0 privileges to actually being able to run stuff as root or be running stuff as root equivalent. What does equivalent mean in this case? Well, it means that if I can log into the web panel of the device, I can already upload any firmware because the firmware is unsigned, it doesn't have any downgrade protections and so on. So I basically assumed that, hey, if I can just log in as admin, I'm already root on the device. Now, I'm also assuming that the attacker is in the intranet, in the local area network, because, well, this is a switch, right? So switches are usually not exposed to the internet, at least they shouldn't be. So I'm assuming the attacker is already in LAN. Maybe it's a company and somebody just came to the reception area and like plugged into one of the available RJ45 slots, like pretty typical. Or the attack can be done, well, one of the options is like if we have a user which is in the LAN and the user enters our page with, you know, funny kittens and so on, right? And the browser, the page tells the browser, hey, send some packets to the local IP addresses. This also counts. So if we can do a reflected attack like that. And because, well, every vulnerability needs a name, right, and a logo, right? This is the way you do things. Well, I'm going to use a metal band name generator to name the vulnerabilities because, well, my sense of humor. OK, pro tip, because this is supposed to be a keynote, so some pro tips as well. The first thing you do when you do research is you make a new folder and you create a new document for notes, because when doing research, vulnerability research especially, you need a lot of notes. And usually I have like 20, 50, 100 pages of notes per research. If you're new to vulnerability research, make notes. This is the, I guess, the only lesson, keynote lesson from this keynote. OK, so what do we have so far? Well, excuse me, we already found this vulnerability, right? But a quick side note, what's the difference between a bug and a vulnerability, or a bug and a security bug? Well, if we have some privileges in the device, like the green circle on the left, and there are some other privileges which we do not have, so a bug, a non-security bug, is if we can trigger the bug on purpose, and the effect is within our privileges. So we could have done that anyway. But if the effect is outside of our privileges, which means we kind of gain some other privileges, then, well, that's a security vulnerability. So far what we had is this like shell injection, right? Excuse me. But, well, I had to be logged in as admin. I had to have a valid session ID to actually do this. So this isn't really a vulnerability, right? I already had to have admin. So that's a bug. That's a bug. It's a cool thing to know. It kind of tells us a story about the quality of the code, but this isn't a vulnerability. So yeah, severity, meh. So how do we get the firmware? There are actually 3 ways to get a firmware of such a device like this one. One way is to, well, just desolder the chip, put it in some programmer, and dump it. That's option 1. Option 2 is to unpack the firmware update. There are usually firmware updates on the website, so you can download, and sometimes they are encrypted, sometimes they are not. Sometimes you can just quite easily unpack them. The screenshot of entropy, by the way, is from a different device. Can you guess the architecture? Anyway, if you can, let me know. And the third option is, well, because I already had this shell injection, that means I could just copy files, right? And obviously, everything was running as root on this device because, yeah, why not? So I actually went with option 2 and option 3, both options. So I could get like a live dump of the device, and I could also get a firmware. Unpacking the firmware is like also a good question. How do you actually unpack the firmware? And, well, I use the YOLO method. The YOLO method works like this. We close our eyes, and then we run in turns binwalk and 7-zip, binwalk 7-zip, binwalk 7-zip. We open our eyes, and suddenly the firmware is unpacked. And, well, it works. And if it's stupid but it works, it's not stupid. It's one of the rules of engineering. Obviously, it doesn't work always, but hey, here it worked. OK, let's talk a little bit about this hardware and the firmware. We already know it's Linux, right? This was a Linux command injection. We can assume it's probably not OS X or Mac OS. So yeah, what is it apart from that? This is how the device looks like, by the way. It's not the same device. It's one of the devices which has the same firmwares, but it kind of looks like this. Also, that's my password. Please don't hack me. And yeah, so Linux with a kernel 3.18, not really modern kernel, was running there. It was a MIPS architecture, and it was the chipset there was RTL, so Realtek 838XM, whatever that means. So a somewhat, not super powerful device, but yeah, hey, it can run Linux, so it's a little bit more powerful than a normal dump switch. Also, it has 128 megabytes of RAM, which will actually be important a little bit later. When we look at the firmware, when we look at the firmware, it was actually the thing which was extracted into the RAMFS was the base Linux system, but apart from that, there were a RAM disk, obviously, and which is usually in /temp, as you know. And apart from there were two squash-fs images which were mounted in /sqfs and /mod sqfs. This is pretty typical, nothing out of ordinary. Like Linux, this is the important thing to remember here. I decided to reverse engineer stuff with GreHack. I didn't know GreHack back then, so this was my first project with GreHack or GreHack, however you want to call it or pronounce it. And hey, it actually worked really well, and the compiler worked with MIPS out of the box as well, so I was pretty happy with it. So it's a good tool. Now, this everything was basically written in C for the web UI. So web UI and everything else was written in C. So yeah, we can already kinda expect some memory bugs, like memory corruption bugs. I didn't have too much luck with running the firmware on my PC. I could get some stuff to run with QEMU user and QEMU system, but not everything. So yeah, I could debug some stuff, but not everything. In the end, I almost didn't do any debugging. It was mostly reading the dead listing in GreHack. Okay, so we have the firmware, and we know what kind of architecture this is, so we can start. Okay, now the method I used was basically alternating doing breadth first, so like enumerating all the attack vectors which are available, which was mostly the website, but not only. There were also other protocols on that switch, and other bugs were reported. And also going in depth in whatever I found interesting, and I did that for some time. Now, this is the quality of the code which I discovered. This is how you read a file. If you are a little bit into programming, you would expect there to say fopen /proc13 blah blah blah. But here we actually call the cat command in bash to output the content of that pseudo file. So yeah, that's not how you read a file. I have no idea until today, like, why would you use this code pattern? So let's say that the code quality was promising. Not promising as in it's secure, promising as in, hey, it's going to be a good hunt. Okay, so first bug or first thing which I found was this setup CGI bug. This will be fast because it's boring. Now, okay, quick question. Who knows what CGI is? Because that's an ancient technology. Okay, so CGI predates PHP even. Actually, PHP came to be because the author of PHP was writing some CGI scripts. So CGI is basically an interface between a web server and a normal executable. And it says that everything which goes to standard output of that executable goes to the client that connected to the web server. And what about, you know, the path and the HTTP headers and so on? Well, this goes mostly into environment variables or into standard input of the process. And the process can be in anything. It can be in Python, in Perl, in Bash, in like C. In this case, they actually had most of these executables in C. So yeah, there was a server, an HTTP server, but this was outside of the executables which I was actually analyzing. Okay, back to our show. Now you know what CGI is. So first bug I found was that when you were actually initializing the token, initializing the switch, you could actually register it, I think, and I was analyzing the part which was doing the registration. Now, it turned out that there was some token passed there, and the token was passed into a function which was called sal, sys, whatever, doesn't matter. Now, what matters is that this was then passed to sprintf, which formed a command. And there are like two vulnerabilities on this slide. One is the obvious shell injection, and the second one is, hey, that's a buffer overflow, because there's no like size given. This is not SN printf. So yeah, two vulnerabilities, but the shell injection is pretty easy to exploit. There was no escaping, but there was HTTP encoding actually, or rather URL encoding that encoded some characters, but not all characters. So I spent like 15 minutes trying to get the proper exploit, proper payload, and the proper payload was the orange thing there, which was I just passed the actual real payload in a header, and then the CGI interface made sure that it would go to an environment variable, and I just called the environment variable, which you can actually do in Bash. Another method was to do just cat there, cat with $brackets cat, which will execute whatever comes on standard input. And what comes in standard input in CGI? Well, whatever you send in the post message. So yeah, pretty simple bug. I called it the feral terror because I wasn't kidding with a metal band name generator. And as you can see, I also used a heavy metal cover generator to make sure that I have a proper, well, let's call it logo or cover for the bug. And I saw that they had a bug bounty on Bugcrowd, and I was like, hey, can I report it there? But they had this rule of disclosure. This program does not allow disclosure. Translation, this means this company can take 5 years to fix the bug, and you cannot do anything because you will be breaking the rules. So I was like, yeah, how about no? And I reported it under 90-day policy, saying that, hey, if you don't fix it in 90 days, I'm going to inform the defensive community of the problem. But they did. Like, they actually were pretty fast with communication and pretty good with communication and pretty fast with fixes. So yeah, kudos to Netgear. I had some other issues with them. Like, they didn't want to assign a CVE number because they have their own PSV numbering system, and they said, yeah, that's enough. But that's kind of weird because like almost everyone monitors the CVE database to look for vulnerabilities. I don't know what's the reason they didn't want to add it to that database, but well, I submitted it anyway, so it still went to the CVE database. That's one thing. The other thing, we kind of had disagreements about what is the actual severity of the bugs, but I will get to that later, or maybe now. They actually said that the CVSS score should be 8.8. I said, hey, it's 9.8 because we disagreed. What does it mean, an adjacent network? Yeah, whatever. Like, it's a terrible bug anyway, or rather a vulnerability. So then I went to buy some more Netgear switches because of reasons, and I did spend some time researching them, which was pretty fun, and then I went back to this switch, and I was like, yeah, they fixed all the bugs, right? So now I can look at it again. And in search of something more interesting, I decided to take a look, how does the actual login look for this device? Like, how does the authentication flow when a user logs into, how does it work? So you don't have to specify a username, that's one thing. You have to only specify the password. There's only one user, it's called admin, and that's fine. Now, if you type in the password, it actually runs this setCGI application with the parameters home, login off, which means that it goes to the right function. And then things start to get weird. Because in the post data, what's being sent, that's JSON. That's JSON formatting, right? Like, you have a curly brace at the beginning, curly brace at the end is a dictionary, but the data goes into the key of a dictionary and not in the value. And furthermore, the data in that key is actually, that's form encoding. Like, what's going on there? So that's kind of weird, but okay. So I was like, hey, they have some encryption there, right? Like, my password, which I typed in, is encrypted. That's interesting, but something is not right. You can see I use the password Ala ma kota. That in Polish means Alice has a cat. It's something like a phrase you learn in the first grade of primary school, basically. If you look there, you can actually find that password, but it's every 7th letter and it's reversed. So what kind of encryption is that? Security by obscurity, I guess? Anyway, well, it went to the server, and the server actually replied with status authenticating. And there was like an endpoint which would return whether it's authenticating, and after a couple of retries, it would say, yeah, okay, it's a good password or it's a bad password. If it's a good password, it would send you the session ID. If it's a bad password, it would just like say, yeah, no. So yeah, at some point you get, okay, end the session, which is a base 64 of session ID, which we will get to later. Now, how does this process work on the backend is absolutely fascinating as well. So we, from the browser, make this HTTP request. Then it goes to the server, and the server, there's a function called CGI util authing session create, which then sends a signal to a process which is called pull D. It's a daemon, it's a separate daemon is running in the system. And there's a function called, which is called handle pull D action, which calls system CMD, calls a command, execute another process, which is called login CGI. It's called CGI, it's not a CGI script. It's like a normal standalone application. I don't know why it has the CGI extension. And what this does, it basically sets the status to 0, which means I'm processing the request for authentication. So at the beginning it's 0, and then it puts into the, it basically replies with 1 plus session ID on correct authentication, 2 on, hey, wrong password, 3 on too many password attempts, you're trying to brute force, I'm actually banning you for a couple of minutes, and 4, I don't know, I don't think that happens actually. And when we are querying, the browser is querying this get CGI home login status, we are basically getting the translated to JSON output of this, like this translation of 1, 2, 3, or 4 from login CGI. So yeah, one bug which I immediately found here, which I named Draconian Fear, because again, heavy metal band name generator. Actually, between these two requests, there is no checking for any session. There is no session yet created. And because there is no session, anyone with the same IP address can actually come and claim the session ID. Just raise condition, call get until the administrator logs in, and then they get the session ID first. Now, hey, what's up with the same IP, right? In what cases can you actually have the same IP? Well, I apologize. This is a local area network, so there are network low-level shenanigans which allow you to have the same IP. Sometimes you maybe have an IP, outgoing IP address the same as admin for whatever reason. Maybe there are other reasons. There can be multiple reasons. Anyway, I reported it, they fixed it. Okay, here's a question, because this login CGI has to communicate the status to this get CGI, which actually returns it to the browser, an IPC mechanism has to be used, as in inter-process communication. Now, what IPC mechanism did they use? There are multiple of them available on Linux. We have pipes, we have Unix sockets, we have shared memory, we have even local TCP/IP socket connections, right? And there are other mechanisms. So obviously they have chosen the best one, which is files. If you ever done IPC, you're you don't use files for IPC, that's their problems. But they actually used a file which was called temp sys and then graphical user interface, authentication info, and PID. And this file had the following content. And this was a text file. This is text, as you see. Username, new line, password, new line, the name of the file which gets the response, the status of the response, about 1, 2, 3, 4, maybe the session ID, the IP of whoever is asking, whether they are using HTTPS or not, and what browser are they using, but this is as a number, so I think Firefox was 0, Chrome was 1, and so on. I don't remember the exact mapping. And at this point, the moment I saw this, I was like, yeah, I got them. I have them. This is a vulnerability. Why do I think so? So you see, this isn't the first time I see this pattern. A long, long time ago, when I was in high school, I actually played a game which is called Ultima Online. Anyone played it? Probably no. That's an MMORPG from back in the days. A pretty cool one. I almost didn't pass my major exam due to it because I played a little bit too much. Anyway, a good game. But I wasn't playing on official servers, I was playing on like unofficial servers, which were running this software called Penultima Online, which is a server emulator created by the community. I don't think it was open source, but at least it was free. Now, there was at some point an interesting entry in the changelog. The author said, character creation will refuse to create a character with control characters in the name. New line, for example. Why? Why is this important? Because, well, you see, this Penultima Online was using a database which was actually a set of text files, which looked like this. It's not JSON, it kind of looks like JSON with that bracket, but it's like a custom text format. So if we had created a character named Sauron, right, and we put it in the name would go into that database. But if we would create like a character named Sauron, new line, command level admin, it would also go to the database. And then when the database would be saved and the database would be reloaded because the server, I don't know, crashed or something, then, hey, we actually have an admin. So a new line injection in text formats is a problem. Back to our show. If we put the password while trying to log in as Ala Makota, then it goes here to the second line. And the third line is this file path. If we add a new line to the password which we enter, which we can do, right? We can send anything in a POST request, especially such weirdly formatted as this JSON form encoding thingy. Then suddenly we control whatever is afterwards in the line number 3, line number 4, and so on. So we control the path to where this IPC file is located, which means we can now put into that file, because we don't know the password, so we can put into that file 2 or 3. Well, probably 2, because we don't know the password, but we don't want to get, brute force it, so we get locked out. So we can use a new line. We can replace the status file name, and we can write the 0 at the beginning, and then it's overwritten with 2 to some other file. Yeah, this doesn't sound like root, right? Like writing one character to a file on a disk does not sound like getting root access, which is our goal. So I was like, yeah, great. I can write 2 anywhere on the file system because I control the path. Like, what can I do with this? It took me 5 days, well, 5 evenings actually, to figure this out. I was trying multiple things. But at the end of the day, I did actually figure it out. So, stay with me. Sessions are the key. I told you we will get back to a session. Now, here is how, well, this is already what we saw at the very, very beginning of the talk, this shell injection, which I told you was not a vulnerability, it was just a bug. But I told you that, hey, because you need to be logged in, and therefore you have a session. Now, this session is in a field which is called CSRF something. So you would think like, hey, this is just a, a cross-site request forgery protection, but no, not really. It's actually also a session ID. And the session ID apparently goes into a function which does RSA decryption, and then it's used as part of a file name. The problem is we do not know the keys. We don't know the private key, we do not know the public key. So yeah, it's generated on the backend. The backend gives you the session. The backend never shares the key with you. I don't know why they used public cryptography for that. I would just use symmetric, but okay. Okay, how does a session file look like? Well, the session file is actually another text format with numbers. Well, and also the username, but username is admin. And when whatever script is being run and it checks the session, whether it's still valid, it actually uses the fscanf as in file scan format function from C, and you pass it like basically tags which tell what kind of variable is supposed to be read and filled from the file. D means decimal, U means unsigned integer, S means string. Yes, that's a buffer overflow because that %S should also have a number there which says what is the size of the outcome buffer. But let's skip that buffer overflow, it's boring. Anyway, so, well, we can create a file which has 2 in it, right? So is that a valid session? Well, good news is that fscanf can return like how many fields did it successfully fill. Here it would fill only one field. One field. So it would return 1. In this case, it would return, how much is that? 7. It would return 7. 7 fields are successfully filled. Now, here it would return 1. So the problem is like, hey, Netgear, are you checking it? And no, thank you, Netgear, you were not checking that, what fscan returns, which means I can actually just give you a file with 2, and everything else would be filled with default values. Yes, they did initialize the variables. There were actually zeros there and an empty string for the username. So cool, hey, this could be a valid session, like as long as, yeah, but we still don't know the file name of a session, because like it goes, whatever we send in this header, in this XSRF, XID, XSID's header, goes to this RSA decrypt function, but we don't know the public key. Well, so it's a problem. But let's take a look how it actually works. Because there might be another bug there, right? Devil is always in the details. So it works like this. First, a global variable g_says ID is created and it's initialized with an empty string. Then the function to decrypt it is called, and it's RSA with padding. This is important. Why is it important? Because in cryptography, if you have a naked, let's call it a naked function which does decryption, it cannot fail. It will just map one input with the key to some output, but it cannot fail, unless there is some kind of checking. And padding is there to check if this decryption was done correctly or not, which means this RSA decryption, it can actually fail, which is good, because it will probably fail. We can make it fail pretty easily. We'll just give it some garbage, right? Okay, what happens next? Then this G-session ID actually goes to this sprintf. If we would have a public key, yes, that would be another buffer overflow, but it's boring, we don't count it. But yeah, we would control then the path of where the session file is looked for. Obviously, if it fails, Netgear did not check it, which means second point for garbage input doesn't exist, which means we just use the empty G-session ID, which is an empty string, which means that if we give garbage to that header, the file which it will look for is login http underscore and nothing more. So hey, we actually can control the file name. Well, at least we can select the file name, not really control it, but that's something, because now we can write 2 to that file. So where are we at? Well, we can create a valid session file. We can write 2 to it. All the zeros there will be just default values. They will not be in the files. So in comparison to the real session, it looks kind of boring, but hey, it's a session file, right? The problem is that these numbers there are actually the timestamps of when the session was created. Well, that's bad, because 0 means it was created a long, long time ago. But hey, these aren't Unix timestamps, right? Like Unix timestamp would have like 10 digits. This is not 10 digits, this is 8 digits. So what is it? What kind of timestamp is it? It's actually the time in milliseconds since the system was started, which means that, hey, this is a valid session just after the switch boots up, or it could be. So, okay, now we have to find another bug. How do we reboot the switch? And, well, it's an old kernel. Maybe we can DOS it. Maybe we overwrite something important with that 2 on the file system. Or maybe we send an HTTP packet so big that RAM runs out. At the end, what worked was this thing, like the least likely thing, but hey, it works. Now, here's how it works. What we do is we upload a large file to the device. Why a large file? Because, well, there is no read-write file system there which isn't a RAM device, right? It only has a RAM disk, because SquashFS, which I told you about, that's actually read-only, and the main file system root, that was also a RAM disk. So, hey, everything that is written to the disk actually should go to RAM. And maybe if it's not written to the disk, it's like just preserved in the memory of the server. Well, that's memory of the server, that's also RAM. which means we can maybe overflow this 128 megabytes of RAM which the system has, probably less, right? Because probably the system is already using some of that. Yeah, the problem was that like HTTPD, the server which was there, the HTTP server, actually saved 1 megabyte files which were more than 1 megabyte to the disk. But as I said, we only had RAM disks available. So if it's a RAM disk, it means it's TempFS, it goes to RAM. The problem was that the switch did freeze, but it did not restart. Excuse me. Now, one important thing, if you're a little bit new to HTTP protocol and how HTTP works, you might be wondering like, hey, how can you upload a file if you cannot log in as admin and go to any upload functionality? When in HTTP, you can actually upload stuff to any endpoint because usually the HTTP server, which receives the file from you, has no idea whether the endpoint accepts a file or not. So it just has to accept it and it has to preserve it before it can run the proper script, and the script can decide like, hey, I'm going to use the file or I'm going to ignore it. Which means, yeah, you can always upload a file to any endpoint. It might be just that the file will be ignored. Okay, but what do we do with this like freeze that the switch does, right? Like it freezes, it doesn't reboot. Well, the answer was funny. Because I have a bug which can write 2 into any file, I can also write it to this proc/sys/ blah 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 sudo files which are responsible for kernel configuration. Which, and a reminder, everything is running as root. So yes, I can reconfigure the kernel by just writing 2 to proper files. And I actually found files like endpoints which I can reconfigure, which is like panic on out of memory, panic, and panic on oops. And I written 2 to them, and hey, this actually works. It reconfigured the switch to reboot on out of memory condition. Okay, so the full chain looks like this. Step 1, we run the exploit 3 times to reconfigure the kernel to make sure that it will reboot at the moment we will flood it with this large file upload. Then we send a file which is too big. And it actually has to be sent pretty slowly because if it's sent too fast, then actually something breaks and it gets disconnected. But we can send it slowly. After 54 megabytes, by the way, the switch actually reboots. And then this is where we go to the demo. Because rebooting the switch takes around 10 minutes, I didn't want to demo that part, so I'm going to jump in from here and I'm going to run the switch now. I'm going to connect it to power. So let's pretend I did run the reboot and it just is going to power on now. Okay, it takes a moment to boot actually. Okay, so now we have to wait until the switch restarts. We have pinging of the switch here. We will know that it has restarted when that actually is, well, showing something. In the meantime, I'm going to, I guess, show you the exploit. That's 7 bugs stage 2. And what I need is, what it will do, it will create a new session. After creating a new session, it will call that bug, you know, the shell injection from the beginning, which was a bug. Well, now we are admin, so now we can use it to run commands because, well, we are admin because we have a valid session. So I'm going to run a command which cuts this file and it actually sends it to my server. Okay, I see the switch has restarted. So I need to create a server. What's the port there? 1234. Okay, so I'm listening on that. And hey, it's actually curl, right? So it should be a HTTP server. Now that doesn't matter. We are just going to ignore the headers. And now we can run the exploit. Now, please note that this might not work because it's unstable. So we might have to run it a couple of times. Yeah, not authenticated. And there we go. Now, why did I output this file? Because this file, for whatever reason, has the plain text admin password. Well, great, thank you. So now we have the admin password, and now we can use this password to actually go to the web UI of the switch. Yeah, not registration, skip registration, access. I have this saved, of course, but I'm going to copy paste it. And hey, we are in. Hey, a live demo worked. This is a good sign for the conference. Okay, so what happened is we created a fake session in this file, and then we just sent like garbage in that session header. And because it was decrypted as nothing, then we could control the file name for the session. And then we could use the bug, because we were already admin at that point. We had a valid session, right? Well, at least for 5 minutes. But it was valid for 5 minutes, and that's enough time to, for example, just send the password to ourselves, and we can now log in as a legal admin using, well, using the credentials and getting a proper session which has, and we can just repeat it without rebooting the switch ever again. Okay, so that worked. Obviously, the next step was naming the bug, and I called it 7th Inferno, because reasons. Again, Netgear didn't want to assign a CVE, so I had to do that myself, so we got a CVE. And we also disagreed about the severity, but yeah, whatever. Like, choose whatever version you want. It's long patched anyway, and you want to patch it probably either way if you have an old device. Now, one more note before we go to the summary. The demo almost didn't happen, because this isn't the switch which I was exploiting. This is a new switch which I bought for the conference so I can demo it. What I found out yesterday sitting in the hotel room is that, hey, you cannot downgrade the firmware below a certain value which is written into the, I think, the ROM at factory level. So if the board is like, the PCB board for the switch is created after like, I don't know, now, then you cannot downgrade below the firmware which was available at that point, which it's just a soft protection. It's not really a downgrade protection, right? It's because maybe something changed on the PCB and the older firmware doesn't support it, so they don't want you to brick your own device. And I was like, yeah, great. Now I cannot downgrade it to the firmware, which was like 4 years ago. What am I going to do? And well, I could just say, yeah, sorry, no demo. But I was like, yeah, no, I'm just going to waste 2 hours trying to figure out how does this work to bypass it. And yeah, I just bypassed it by overwriting in the firmware the version number and recalculating checksums, and that was enough. So yeah, there we are. Cool. Summary. It's an amazing firmware. I can really recommend it if you are into vulnerability research. If you are into having great switches which are secure in your network, you probably want OpenWRT or something else like that. And what I like about the bug is that it's like a truly full stack bug. Like, we had web security and HTTP protocol. We had reverse engineering of MIPS binaries. We had crypto, but RSA with padding, right? And we had OS level stuff like reconfiguring the kernel. So hey, a full stack bug, cool. And as usual, the devil is in the details. So if something does not work, the question is always, why does it not work? What exactly happens? And if you dig into it, you will actually find sometimes a way to bypass the problem. In the meantime, I found other vulnerabilities like Demon's Cries, because heavy metal band name generator. And you can read that on my blog if you're interested. So that's it. Thank you very much for your attention. And please remember to write an article for PageTout. Thank you. And also have a great lecture if you're going to read it, actually. So happy reading the Zine. I'm really happy that it actually was printed by the organizer. So thank you very much for that. And it's always great to have it made available for an event. OK, are we doing questions?
Yeah, thank you for coming and for your good presentation. Very interesting. Do anyone have a question?
We can do simple questions.
Yeah.
Why was it important for you to have it assigned a CVE number?
Sorry, could you repeat?
Why was it important to you for it to be assigned a CVE number?
Oh, why? OK, so why is it important to have a CVE number? Oh, wow, this is a great discussion, by the way. So, OK, it's like this. If you're a junior researcher, you want a CVE because you heard it's trendy and you want it and you want to put it in your CV, right? And then when you get more senior, you kind of start to understand that, hey, the CVEs are actually there as for a purpose, and they are not there because it's a trophy. The reason CVEs exist is because it's a vulnerability database. And if you run a company, what you do is you have like monitoring scripts which read through this database of vulnerabilities which were discovered, and you cross-analyze it, or you check if any software which you have in your company is actually on that list. For example, it had appeared yesterday, because that means, hey, maybe you have to look at the vulnerability and you have to decide whether you want to patch it. Okay, and that's telling me I am out of time. Anyway, so you want to put vulnerabilities which you discover into the CVE database so that the defenders, which actually care about this, are notified. This is the great way to notify the defenders. And that way they are like, yeah, hey, there's a new vulnerability, maybe we have to update the firmware, or maybe, hey, it's garbage, and we don't have to do anything. So that's a reason which is why do you get a CVE number. It's not a trophy. Okay, it's also a little bit of a trophy, but the main reason is you want to notify the defenders. Other easy questions? Or hard ones? Okay, can we do it like one question there, and see what's the stamina of the organizer?
So thanks for the talk. How do you submit a CVE, actually?
Okay, so if you never submitted a CVE, it's like this. And it was 4 years ago, so things changed. But you can just go to the mitre.org, like that's the organization which runs the CVE database. You can go to their website, and there is a form which you fill out. Now, you fill out the form, and you say like, hey, this is where the report is located, this is the version affected, this is when it was patched, this is a short description of the vulnerability. If you fill it incorrectly, it's going to be ignored, or because it's going to be probably put on the stack of like, hey, we have to fix the description, and maybe when we have time we will do it and it will go into the database. If you fill it out perfectly, it goes to the database really fast. They are just like, hey, it's filled okay, we just approve it and it goes to the database. Now, in the last 4 years, what changed is that there are more SNAs, which are the organizations, like other organizations, got to govern the CVEs for their own product. So you can, like, for example, I'm not sure if Netgear is a CNA, but there are some organizations where you go to the organization and they actually have to get the CVE. And they actually decide which vulnerabilities get a CVE. If you disagree with them, I think you can always fall back to Mitre and you can complain that, hey, this is an actual vulnerability, but the organization doesn't want to add it to the database for whatever reason. It's an interesting discussion, basically, whether it works correctly, but yeah, it's like this right now. But what I can suggest to do, if you're interested, go to the mitre.org site and read a little bit what are the options when you want to add a CVE to a database.
And the last question.
Again, thank you for the talk. So if I really understand it, there was a file with the username and password in clear text. So there is a shortcut where you can just cut the file with the password and then access the web panel and upload your firmware, and it is.
Sorry, you'll have to repeat that.
Okay. So when you was doing your exploit, your Python exploit, you said that you have cut a file with a username and password of the admin. If I understand it.
Here?
Yes, and so there is a shortcut in the exploit when you can just output the username and password and access the web panel.
You mean, sorry, do you mean about this
No,
file?
maybe I don't understand it correctly, but when you...
I think it means that as your goal with the exploit you demonstrated was to cut the SNMPD file which contains the password. As you have the current command, you could also have exfiltrated the credential that way via this first curl and yeah, bypassed the two overrides and all.
Yeah, that's also an option. So basically, honestly, what I had here originally was a reverse shell. But I didn't want to go into the whole discussion of how to compile a reverse shell into that platform because it was a little bit annoying. So what I ended up just doing for the demo purposes was basically this. And there are other ways also to do it. We can discuss it like after the talk also. Okay, thank you very much.
Thank you. celui-là. Ok. T'as quoi comme... Ah oui, ok. Ah oui, oui, ok. We have one also with the presentation. J'ai vu que tu avais mis que tu avais des vidéos, mais comme je suis pas sûr de les avoir reçues. Mais si tu les as, ça marche. Okay. L'année dernière, on avait des soucis. Okay. Can you hear me? Yeah. If you can, please have a seat so we can start the next talk. Thank you. So for this next talk, we will continue with the theme of vulnerability research with Yvan Genuet and Fabien Hague. We will present their work on SAP research. So SAP is a well-known prosumer software, and they will talk about Adobe document systems as well as, I think, Cobra snakes. So here we go.
Thank you. It's all right? Can you hear me? Yes, thank you. Okay, right. Welcome to our talk. So the title, it's Adobe and SAP, all your business documents belong to us. Or, yeah, what can go wrong? Just to, maybe the best way to show you the purpose of this talk is to show you the first demo. So this is an SAP user, a normal user. You just choose a SAP system. Let's say this is a HR end user. You just add a new employee, so you put the name, etc. So this just manage the table, and you click on print version to have basically a PDF. So it just generates a PDF like that. All right. Okay. Of course, behind the scenes, something happened. So just imagine that the user continued to work on it. For example, he just changed the city, and he click again on print version. Something happened. Oops, we have a pop-up like, hey, hello, GreHack, okay. And also, you can see there are another picture attached to the PDF. And as well, the value itself inside the PDF has changed. Now the salary, it's quite okay. So basically, this talk is what's happened behind the scene, and I hope what is also important to take care about what we will show and how to protect it. So my name is Yvan Genuer. I work on SAP since 22 years now, I guess. The last 12 years only on security on SAP. I found many vulnerabilities. I work for Onapsys as a security researcher. And today I will present also with Fabian. So please welcome Fabian also.
Hi, everyone. Thank you. So glad. Thanks. Yes, so my name is Fabian. I'm also working as a security researcher with a focus on enterprise applications and specifically SAP software systems. And yes, basically for me, this is the first time at this conference, so I'm really happy to be here today and share the stage with Ivan. Yes, so today we will take you on our journey into the world of SAP and business document creation. For those not aware or not fully aware of what or who is SAP, it's a very large software vendor producing solutions for companies to manage business critical processes. And one of such processes is also handling the creation of PDF files and documents, of course. And this is what we're going to look at today. So when we started to see what technologies are available for SAP users to generate business documents, we found those three you can see here on the slide. So basically the one on the left, SAP Script, and the one in the middle, Smart Forms, are rather old solutions that are closely tied to SAP's core platform technologies. But the subject for today, the target we had during this research, is the one on the right-hand slide. That's Adobe Document Services, or short ADS. And ADS is a joint solution by Adobe and SAP. And the version of ADS we looked at during this research is basically an on-premise extension customers can install in their SAP system landscape to manage the process of electronic documents creation, but also interactive forms, for example. And there were a few characteristics of this solution which made it really attractive for selecting it as a research target. The first one is basically what you can see here on this slide, which is a common deployment module to install that solution in your system landscape. So basically, you have a central SAP system, which is typically SAP's NetWeaver application server Java. That is a runtime environment for operating Java applications. And this is where you install ADS on top of it. And then you have all your other SAP systems in your landscape. So for example, an enterprise resource planning system, but there are also various other kinds of SAP software solutions. You have all of them connected to that central instance. So when they have the need to create a PDF, let's say, they will send this request to the central ADS solution. Now for us, this also meant when we look at this architecture, of course, ADS could also be a single point of failure, right? So again, it made it really interesting to take a look at it. So we started to see what previous research has been done. And maybe you noticed 2 slides ago, we put there that ADS is the most recent solution. And it is actually still the most recent solution, but it's also already quite old. So we found vulnerabilities dating back to 2010. But overall, we didn't really find a lot of things. And as you can see, all of the vulnerabilities were also rather old. And when we look closer into them, it was also like that most of these issues are not directly impacting ADS, but dependencies ADS is relying on. So again, we came up with, or we concluded that it might make sense to do our own analysis of this component And this is basically what Ivan will now kick off with our first finding.
Yeah, thank you. So now we, for many reasons, for what Fabian said, we decide to start on, let's say, to do some research on this ADS. So we installed the ADS in our labs, and we tried to do something. So this is where we get the first finding, and we call it the XFA breakout. So you recognize this is the same application from the opening demo. So it's the way we can use to print PDF on SAP system. So we just make a few tests, like, OK, how I can print PDF, what has pun, and we just sniff quickly the network just to let know, OK, by curiosity, if we can see something or something. And very quickly, we found something like that. So normally, so in this diagram, you can, on the top left, this is the SAP system, and on the right, this is another SAP system, but with the ADS component, okay? We will use this diagram a lot. So what we discover is if we try to print a PDF from the SAP system, so the researcher is connected to the SAP system discussed with this web services, the WSILV PDF, and then the PDF is generated. What we discover is, OK, we can communicate directly with this web services without authentication. OK, cool. So we sniff a little of what's its in size, what these services accept. And it looks like it accepts some data in XML format, and then let's say they parse this data to create what we call an XFA. And this XFA, it's how the Adobe Document Services will generate the PDF. So what is XFA? It's meant for XML form architecture, so it's come from Adobe. And it's quite old. I will not go into detail. If you want, we put the references. I think it's like 1,000 pages document. So basically, in the XFA, you can, it's an XML format, and you can precise, OK, I want this data in my PDF, I want this PDF with this format, I would like this font, et cetera, et cetera. So this is where you can specify everything in the PDF. So we read the part of the documentation, and very quickly we spot that, there are a script tag in this XFA. So we can also, in the XFA, you can execute JavaScript, also form calc script, but it's basically the same things. So the first findings, so just imagine that we are on the first day, and we find that in the data we send to the web services, we find an injection where we can inject any XFA command. So what command we add? We add a script. So, and in this case, we add a script. And what is interesting is that you can precise when or where the script is executed, on the client side or at the server. So in this case, in this injection, what we do is just we have a JavaScript when we try to get the version, the hostname, etc. If we send that, we receive a PDF with the version, the hostname, and everything right in the PDF. So from that, we try to leverage from this access. We try to do a lot of things at this time, but we never, let's say, successfully find a very good exploitation. But it was the first finding very quickly. So this is where we say, OK, now we should go a little bit deeper. And also, until now, we don't exactly understand how it works. So, OK, we are connected on the SAP system. We understand that they use a user normally to discuss with Adobe Document Services also directly. But in the middle, this is like black magic for us. So what we did, we just, of course, we are in our lab, and we try to trace everything, sniff everything. So we just issue this kind of script. The goal is, OK, to have a traces of what we do. So we launch it, And we try to print PDF, we try to inject in the XFA injection, etc., etc. So basically, we try to do some activities and then to see what we have. So we get a lot of information, and this is just to summarize. So first things, yes, it's complicated. So for us, again, it's another signal. So, oh, it is complicated. It could be a good sign for bug hunting. So we try to simplify a little. We not go into detail again. So basically, how it works. So And so the user on the SAP system communicate with the Adobe Document Services. The Adobe Document Services, when he wants to generate a PDF, he just launch XML form.exe. This is a bash script, even with this extension. And then this bash script executes this binary, the XML form. The XML form is where, for example, the JavaScript injection, this is where it's really executed. So the XML form generates the PDF itself. Then he writes somewhere in the file, in the temporary file, he writes the PDF somewhere to provide it to the services. And most interesting part, or one of the most important, is this one. Who knows what is IIOP protocol? We guess. No one knows. We discovered that it used this protocol, IIOP protocol, to communicate between the Adobe Document Services and the XML form. So no one knows what is it, even us. So we do our work and we try to understand what is it. And Fabian will help you to understand.
All right. Yes, so this protocol or that communication going on there definitely stood out because of multiple reasons, as Ivan mentioned. And it was also something unusual. And when it's something unusual, then it's probably interesting. So we try to better understand what this protocol is all about. So we searched for it, and it turns out that this is basically the TCP/IP implementation of a more abstract protocol that is defined in a standard called CORBA. And CORBA describes an architecture where distributed systems that could be possibly written in different programming languages can communicate with each other and exchange object information. So what you can see here on the right-hand side is a really basic view on this from the public specifications of the standard. And most importantly, in the middle, you have what is called the ORB, which is the Object Request Broker. And this component of the architecture takes on critical tasks like handling the communication between the client and the object interface, but also maintaining references to the registered objects. And for such an ORB to speak with another ORB, that is basically where the Internet inter-ORB protocol comes into play, so IIOP. And when we now look at our scenario here, we basically have inside SAP's Java application server a service or a binary called the ICM. And that one handles most of the task of handling all kinds of communications, both outbound and inbound. And one of the services it provides is the IIOP service. So basically, Java applications running in the Java environment can use the IIOP protocol to speak with other external services, but they can also receive IIOP requests. We then try to better understand where most parts of the CORBA standard are being implemented in SAP's application server, and these are basically the packages that we found. And then finally, of course, we had that binary, which seems specific to ADS, which was speaking through the ICM to the Java backend in both directions. So digging a little bit deeper and trying to understand how this communication is initiated, this is what we found at the very beginning. So in our traces, as we noticed that, or at the point where the XML form binary is being executed, we saw that this huge hex data was passed as an argument. And this data, what you can see here, is actually a specific data structure which is defined in the CORBA standard. So here you have a hex stamp. And that interoperable object reference, which is the name of this hex data, provides an ORB client, let's say, with sufficient information to execute an operation or access an interface of a remote object. And as you can see here, we have information like an identifier, let's say. So here we see that probably the XML form binary tries to make use of an interface that is called the COM Adobe Service Manager interface. Then we have the information where we have to direct requests to access that interface. So this is basically the ADS host name and the service port for the ICM IOP service. And then finally, we have what is called an object key. And this object key looked a bit random, and we didn't really understand how it is constructed here. So we tried to see if we can pinpoint the piece of code which generates that key. Because from the standard, we understood that we have to know this key to access a specific object. So in this case, the Corba manager object. So facing that challenge, we did a little code review, and inside the Java packages I've just pointed to. And this code snippet you see here is basically responsible for generating the key. And overall, the key consists of 3 components. So first of all, we have a server ID, which is a static component. It's always the same for that server instance for all objects. And then we have what we call the object counter, which is an incremental value. And finally, we also do have a timestamp here. It's also a timestamp in milliseconds. So here you can see a simple packet being sent from the XML form binary to that service to access a specific operation. And as you can see here highlighted with colors, that's basically the object key being used. And what else we noticed here is the fact that there isn't any other kind of logon material. There isn't any other kind of authentication mechanism in place. So we thought it could be interesting if we can somehow obtain that key. We could inject ourselves into this inter-process communication here. So the next step was to see how we can actually speak with that service and what options we have to get access to that key. And the first thing we did was creating a little test application, the one you can see here. We call it IOP Chat. And it's basically what you can find in Oracle's reference implementation to speak with what is called the name service. The name service here at the bottom is a service which is also named in the Corba standard, and that service allows access to a tree-like structure where you have all the Corba objects registered. So our idea was maybe we can just get a reference to that service and ask it for that key that we're looking for. So executing that script remotely, we faced another challenge. It just didn't work, and the communication got interrupted like immediately. And there was no option for us to access that name service. So we tried to understand what is going on here. And turns out that this was actually rooted in a patch SAP introduced to a previous vulnerability that was reported by Ivan actually several years ago, which was a server-side regress forgery in the IOP service. And to patch that vulnerability, SAP introduced a specific allow list that now restricted who can access that service. So that's was basically the root cause why the communication got interrupted. And now, of course, we wanted to see where this is actually implemented and if we can bypass it. And what you can see here is basically the very early processing of the IOP packets. And we figured out that there is a certain section inside the packets where you can define or add what is called a service context. And if there is a service context with a specific ID, in this case it's ID number 6, then we notice, okay, we will enter that method which enforces those allow lists. So in our packets that were generated by our little IOP chat testing application, we found that service context being included. Now, looking at the standard again to understand what this context is about, it turns out that this is something, without going into the details, which seems to provide a way where you can add hidden parameters that allow the receiving ORB to have more information about the data that is passed in the request. we thought, okay, maybe we just don't need that in our case, so why don't we just switch that byte? Or simply remove this service, and actually that worked. So a very simple bypass, and we got access to the service, and now we had a reference to that naming service, and we were able to execute specific standard operations to ask for object keys. But we weren't able to find that key that we were actually looking for. You remember the Corba manager object key? We weren't able to get it. So we had to look for a different way, but at least now we were able to communicate remotely. So if we cannot simply ask for that key, the next option was to see if we can brute force it.
Yeah. When we speak of a brute force, we always call me. Okay, so this is the key we would like to get. So again, quickly, so in green, this is the server ID, followed by what we call object counter in blue, and then the timestamp in yellow. First of all, the server ID. So the server ID, as Fabian mentioned very quickly, so by sending like the very first, the resolve initial name service, we receive in the response, in the packet, we have the server ID. The server ID is unique for the instances, for the host, let's say, okay? So, okay, one request, and we leak this server ID, very easy. Next. The next, it's the object counter. So, the object counter, how we can get this? Again, we try to brute force the object key of the Corba manager object, okay? So, but what we find is like, okay, we cannot resolve directly and get the key of the manager, but we can resolve in this context, for example, the Adobe services, it always exists in this system. And if we do that, we receive a packet, and inside the packet, we have an object key. This is not the good one. This is another object key, okay? This is not the one we're looking for. But we have the server ID, and just after, we have the object counter. In this case, this is 57, all right? We analyze quickly where this comes from, so okay, and it comes after the resolve, you get an exception, blah, 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 and on the top right, we have the object counter, where the object counter comes from. And the important thing is this object counter is globally managed by the application. It means if we request a new object key, the next object key will have the counter 58. And the next one, and the next one. So by sending only this simple request, we get the status of the current state, let's say the current value of the counter. How it can help us. So back to this diagram. We send this first request, and now we know, okay, the current counter is 57. This is where the XFA injection comes back. This is what we find. If we send an injection, so XFA injection, remember to generate a very big, to generate a PDF. If we inject this kind of very long process, the XML form just runs, okay, in the background. And if during this time we send a new request, hey, I would like to generate a new PDF. Okay, because the first one it's still processing, the Adobe Document Services spawn a new one, a new XML form appear in the process list. And you guess it, new XML form means a new manager object key, the key we would like to brute force. So we do quickly test, and we figure out that, okay, if we do that, like create a long, force the XML to spawn again, the object key counter, the object counter is always +3. So in this case, we just send one request to get the object counter, and we know if we force the XML force to spawn again, the object counter will be 58. We do not need to brute force it. That's very important. Okay, so we get the object counter. Now, speak about the timestamp. they use the timestamps. This is the timestamp where the XML form, when the XML form is launched, they use the timestamp to generate to put it in the key. So again, how we can brute force it? Of course, it's complicated to brute force the whole timestamps. It could be very, very long. But again, we will use the same tricks to send a very long XFA injection. So we will force the XML form to run in the background. And in the second request, instead of sending a normal one, we inject again. But this time, we ask for the date. So what's happened? A new XML form is created, a new object key is generated, and by sending that, we receive a PDF, and inside the PDF, we have the timestamp of the PDF creation. So we can compare when we launch the first request, so this is the timestamps on the top left, and between the timestamps we receive in the PDF. In this case, this is like few seconds, so 4 seconds. 4 seconds is like few thousand, 4,000 requests, so this is nothing. We can start brute force all these few thousand requests, and very quickly we guess the timestamp like that. So we have, now we have everything. So what we can do with that? This is the next part.
All right, so we finally got that key, and now, now comes actually the interesting part. What can we do with that key? And today we want to show you two kind of attacks. The first one actually brings us back to the Open a Demo video, and it's about an IOR injection. So what we did after obtaining that key was analyzing what methods that Core Manager object interface exposes. And the first interesting method we saw was called register controller. And that's basically a method being used during startup of ADS, and it's used by the XML form to register at the Java ORB side to say, hey, I'm the XML form, I'm here. If you have any requests for PDF generation, you can send it to this localhost port here in this case, or the external interface of the ADS host on that specific port. Now, since we have that key, we can make use of this method on our own and inject an IOR. So what does this mean? It basically means we can say, no, the XML form binary is not located here on your local host system. It's basically here on our attacker machine at this port. And thereby, we enter like a man in the middle position where we can now basically receive all the data that is intended for the legitimate XML form binary. And we receive that as an attacker, and we can also tamper with the data and respond with whatever we want. So this brings us back to the demo video we have seen at the very beginning. And now we have both sides. We have the attacker point of view on the right-hand side, and on the left, that's the victim. So first we have the victim using the test application in this case as usual. So just to confirm that everything works as expected. And then on the upper right terminal, we basically have the attacker executing the brute force attack we discussed. So this will be very quick in this case. So as you can see, we get the current value of the object counter, the static server ID, and then we will brute force the timestamp, and then finally we got the object key of the new Core Manager object. And on the bottom, we start our rogue XML form ORB, and we now execute the IOR injection through the register controller operation to say, here, this is our rogue ORB model, and as you can see, we receive the connection. So now what happens next if the user tries to generate a new PDF? As you see, we're going to receive the request in this case, and we respond with a tempered PDF. And of course, besides tampering with the data, as I've mentioned, the attacker can, of course, also look into the data that has been initially sent from the client to the ADS solution. So here we see all the data which is actually included in that PDF file. Oh, and yeah, and I always forgot about that slide, but yeah, of course. So what does this mean now when we look at the overall picture again? This basically means that any SAP system connected to that central ADS solution is basically affected by this issue and this exploit, because we can tamper with all the business documents that are being generated or that are about to be generated by the legitimate ADS instance.
So, okay, so what we demonstrated is with this kind of vulnerability, we can attack the client, basically, but also we find different vulnerability on ADS, and we have also something to provide, like how to attack the ADS itself. So very, very quickly, when you configure a new SAP system and you want this SAP system work with the ADS, you need to configure some credentials. So the name by default is ADS user. So it means all this SAP system use this ADS user to connect with the ADS system. So just imagine it in a scenario you already compromise one system, or you guess, or you find the user credential. It's not so complicated. So if you have this credential, we find a way to execute also, to have a remote command execution of the system. So few things. The first thing is we find a way to, instead of, when we request for generate a PDF, we find a way to, instead of receive the PDF, we can store the PDF on the server side. So that's cool. And of course, we also find another vulnerability to store on any place. So what we are able to do is to, let's say, upload any kind of PDF, only PDF file, and we can overwrite any kind of file. So what we will overwrite, it's the XML form itself. So the binary in charge to generate the PDF. So, okay, we are able to overwrite this file with a PDF file. So what we do, we craft a very particular payload, and this payload, when it goes to the XFA, to the Adobe Document Services to be generated, at the end, it will create what we call a polymorph PDF. So it is a PDF, a normal PDF, but if you execute it, it's a bash script. So this is what we call polymorph PDF. So thank you to Corcan. So now you guess it. Again, what we do, we force the first XML form, the current XML form, to run in the background with a very long injection. And when we send a second request normally, a new XML form is spawned, and of course, we override this new XML form with our polymorph PDF, so now we get remote command execution like that. Yeah. So on the top, in green, this is just a loop, a file in the XML form. So as you can see, the XML form, it's a bash script, even with the extension. On the bottom right, this is the listener. And on the bottom left, this is the attacker point of view. And on the bottom left, I just execute the exploit. First exploit, I will overwrite the file, so the file changed. Now it's a PDF. And then we send the long XML stuff, and then we force the XML form to spawn again, and we get remote command execution like that. Of course, we will provide how to protect and what it's important to know about it.
All right, so we reported all of the findings we have shown you today to the responsible development teams through SAP's product security response team. And SAP basically released a set of patches. The ones you can see here on the slide basically address all the issues we found in the web services. So we have the XFA or XML injection, but also the authenticated attacks. There are some more patches here for other issues we hadn't the time today to talk about, but those were basically the patches SAP released already last year to address these issues. And then for the brute force part, mainly for the IOP part, SAP also referred us to a specific note, the one you can see here on the slide, about the IOP SSL, because IOP SSL is like a secure version using SSL on top of the IOP protocol. And it's not enabled by default, but there is this note saying how you can basically enable IOP SSL, how you can disable the plain IOP port, and also most importantly, how you can enforce client-side certificates. Because what does this mean? So as I said, the patches protect against the findings we run against the web services. And then with client-side certificates on the IOP service, we finally have authentication. So the brute force attack we executed is basically not possible anymore. So lately, like just a couple of months ago, I think it was during the September Patch Tuesday of SAP, there were 2 new additional patches being released. The first one is about an outdated OpenSSL version. This one was not found by us, it was found by someone else. We tried to obtain the name of the researcher or the person that reported this, but we weren't able, unfortunately. So the second one is based on our submissions, and it addresses the generation of those object keys specifically. So as you can see here, now how the object key is generated has changed. Now we do have a pseudo-random number generator being used that basically replaces the timestamp and object counterpart inside those object keys. So this brings us to our final slide, our conclusion. So we hope we were able to give you some insights into what turned out to be a very critical component in SAP system landscapes. We hope we were able to show you a bit about SAP's custom implementation of the Core standard and how we were basically able to leverage a vulnerability with the XML or XFA injection that at first glance looked limited, how we were able to escalate that to a very critical chain, let's say, to get that object key and finally enter this man-in-the-middle position. When it comes to future work, so what we looked at today was the on-prem version of ADS. There is also a cloud solution, which is called SAP Forms Service by Adobe, and it runs in SAP's so-called business technology platform. We haven't looked into this. And then there is also plans for a new ADS version that is not being operated on the Java application server, but instead on what is called the HANA HANA Extended Application Services, which runs on top of SAP's HANA in-memory database. Also something, of course, we hadn't now the time or a way to look at because I think it's not even released yet. So those might be targets for the future. And then, of course, our call for action, if you run one of those things we showed you today, so basically if you operate ADS, then you should patch these findings because I hope we were able to make clear that's a very critical component. And also, you should enforce IOP SSL because it's not enabled by default. And with that being said, here are our references, and that's basically it. Thank you for your attention.
Thanks a lot, Fabian. Does anyone have a question? You are not SAP fans? Oh, yeah.
Oops, sorry.
Hey, nice talk. Thanks a lot. How long did it take for SAP to patch the vulnerability? So once you submit the issue, how long did it take to fix it?
I'm not sure, but we submitted, let's say, in March 2024, and I will say in June or July, everything was patched. We get some few discussion because there are some, not issue, but there are some issue yet to reproduce some attack or to fully understand what we do. So there are some some delay because of that. But when after they accept, it's come normal, let's say.
Thanks.
Here.
Oh, there's one as well.
It's a race.
Yes. When you do some kind of brute force, like a few thousand attempts, like you did, is it not spotted as a suspicious activity by something or a team or a software somewhere?
We do this brute force over the IIOP protocol. On the port, the default port is 5007 on SAP system. We can say it could be suspicious, but we can also like hide this few thousand because you can send like few hundred time to time. And instead of take like less than 1 minute, the brute force we can take 1 hour, maybe 2 hours, but it's still reliable in real life, more or less. So.
Okay, thank you.
How do you manage to get the product installed to do your research? I mean, it's so complex to get them and to have them running. From my memory, it was the biggest difficulties in SAP research.
Yeah, you mean how we get the Adobe Document Services components?
I mean, both the software itself and the running installation of it.
Basically, on Apsys, we are partner with SAP, and so on Apsys are able to download or I don't know if they buy some licenses with particular price, or maybe it's expensive also, probably. But for us, as a researcher, we just ask, hey, we would like to have that in our lab. It's validated somewhere, and after 1 week, we have it. So
easy.
For us, it's like easy, yeah.
Any last question? Okay, so we will have a short break, and the next talk will be at 11 a.m. So you have food if you want, drinks.
Thank
See
you.
Thank you.
please, if you could take a seat. So we will start again for the second session of this morning. Please welcome Volker for its presentation.
All right. So thank you for your attendance. This talk is titled "One Does Not Simply Walk into a Building, or Do They?" And we are going to talk about physical intrusion. I would first like to thank GreHack staff for all their work, and thanks BSecure for allowing me to present this today. So, as I said, we'll talk about physical intrusion, and this is mainly an after-action report of an engagement we did last year. So everything in this conference is based on real-world events. Beware, memes are coming. So today, we'll first talk about the context and the goal of the mission, and then go on with the initial intrusion, the access persistence, and the goal collection, which is the most fun part. And we will conclude and give you some key takeaways. First, who am I? Quickly, I'm Volker Karstein. Hello. I'm a pentester by day and jack of all trades by night. I do many things outside of cybersecurity, but I mainly work at BSecure, where I do pen tests, physical intrusion, and some red team operations. I'm specialized in social engineering, OSINT, and offensive security, of course, but I have a strong preference for Active Directory, and I'm a regular speaker at the event listed there. So, as I said, this is a physical pen test mission at BSecure we did last year. It was 1 week, 1 week time, and we were 2 auditors, Shenron, if you watch this, many kisses. The goal of the mission were to enter the building. Obviously, that's a physical intrusion. It's usually the thing that is always present. Steal confidential information, okay. Steal some equipment, IT or anything else. Steal a bicycle, yeah, why not? And if possible, attack the IT part of the company, but that was not the priority. How do we prepare a physical intrusion? Ideally, how much preparation and research is needed? Not the execution part, but the research time. Educated guess. If you thought about a week, that's usually what's recommended and what's comfortable. We had 1 day to prepare. So, yeah, this is fine. How do we prepare? We can look at satellite pictures, maps, Earth, Yandex, etc. This is the Cité des Sciences in Paris, where GreHack takes place every year. And in red, you have possible entry points. Also, the same kind of technique is to use Street View, where you can see there, if you can see my pointer, there was a possible entrance. All right. Where, in fact, there was 2 possible entrances, and you can only see that entrance with Street View. So many angles, the more the angles, the more the possibilities. You can also look for plans for tourists, for evacuation or fire safety. Usually if it's a public place, they are readily available. And you can also look at pictures of inside the building. Those are all from the same company, and I just found those on the company's website, on LinkedIn, and on the real estate agency that handles the building. Wait, there's more. You can also search for pictures of badges for potential copies, at least on the appearance side. There you can see that it's a picture of a badge from Google, and they always blur the images, but you can see the structure of the badge with the picture and with the name here. But there is better solution, there is better scenario and the context for that. You can also have the badge readily available. It's a template, basically. I just blurred out the name of the guy, but thanks, bro. Usually, to find those type of pictures, you can look with some LinkedIn docs at first day at, and usually it gives us some interesting pictures of badges. And also, while we are on LinkedIn, you can host in the employees and the external service providers for their position, their dress code, and that's really useful for social engineering. Back to our actual scenario, we had 4 entry points: the delivery access, the garage door for the parking, the emergency exit, and those windows by the street. After having done some research, you have to prepare your tools. First, obviously, adequate dress code in accordance with your research and with your pretext. Pretext is the person you are pretending to be. That's your scenario, basically, for social engineering. If you plan on do some lockpickings, you need lockpicking tools, such as door bypasses, lockpicks, bump keys, pick gun if you're not concerned about the noise, and under the door tool, just like that. That was particularly useful in our case. You can also plan to do some batch copies, and you'll need Proxmark or Super0 or anything that can do batch copy, basically. And frankly, anything that can be useful as cable, chargers, adapters, multi-tool, Swiss Army knife, subtle foreshadowing. And the only tool you must have is your authorization letter or get out of jail card that allows the intrusion in the context of a security test mandated by the client organization, which contains the identity of the auditors, their company, the mission, and basically saying that if the auditors are detected or arrested, it proves the intrusion is legal. No intrusion without this letter. I'm insisting it's crucial, and minimum 1 copy per auditor, preferably 2. Choose your own adventure. How do we get in? We can do the delivery door, the garage, the windows accessible from the street, and the emergency exit. First, the windows by the street. At night, we noticed that we can unscrew the pane, and scratching the seal and with the window suction cup, we can gain access. But that's not discrete, that's too complex, too much risk of breaking the window, so we abandoned the method. And later, we learned that the window led to the basement, from where it's complicated to access upper floors, so that was lucky that we didn't try that. Also, you have the emergency exit. The door can be lockpicked at night with an under the door tool, but a camera is pointed at the door, but we weren't detected. Maybe the guard was sleeping, I don't know. So initial intrusion, okay, and we are at ground floor, but by night only, because in the day it's not possible to enter like that. And the elevator and the doors to access the upper floors are all badged lock, so no dice. We can also do the delivery door. Every morning food is delivered to the company cafeteria, so the door is left wide open because the employee needs to move stuff in. We just enter nonchalantly, no one says a thing. We're in. Simple. And also we can enter by the garage. When a car enters, we follow it on foot. Neither the camera nor the security control react. Okay, we're in. We're at the garage, so -1, but the bicycle garage is there. So that's one of our goals. Now that we are in, how to come back without lockpicking, tailgating, on good timing, how to move around freely with the elevator and the door from the stairs that are badge lock, how to make this building our home, basically. First, the doors for the stairs can be lockpicked, and we can then access all floors, but we risk of being detected at each floor change, because each time I have to pull out my Swiss Army knife and with the CAD opera attachment, because why using a bypass door too when you can use a Swiss Army knife? Once we've reached all floor, with tailgating in the elevator, when someone goes into the elevator, you go with them and you go at the floor they stop at. Or lockpicking for stair access. We walk around the building to find badges that were left without surveillance. And we got 2 minimum to sustain our access, and we stole more in case they are revoked. And I think at the end of the mission we had 14 badges. None of them were revoked. None. So thanks. Also, bonus persistence we could have used. Among the ground floor, there was meeting rooms, and some windows of those rooms gave access to the street. We got inside the room, we opened a window that was not rigged with alarm triggers or sensors, and we blocked them with double-sided tape, so they are stuck against the frame. And we could have come back later, at night or the day after, push the window from the street and get in. So that's the bonus access persistence. Now, first goal, okay, we are in the building and we have access persistence. So now, let's steal a bicycle. Same way we did with the door to access the stair, Swiss Army knife bypass. We stole 3 bikes, and this is my collection run, leaving the garage with the bike to do a tour around the block and put the bike back. Yeah. Okay, so equipment now, because bicycle is okay, so let's be thieves. We arrive one day at 7:30 a.m. before all employees, but after the cleaning staff is gone. And we knew that there was somewhere where the IT equipment was stored. This is the IT corner equipment storage. But it's locked by key and not by badge. But yeah, we have a lockpick. We have a bump key, so let's lockpick the door because it's 7:30 in the morning, nobody's there. If it makes a bit of noise, it's okay. So we enter this room and steal many things, including multiple PCs, phone, cables, YubiKeys, many things that were just there. Also, we stole clothes branded with the client's name, t-shirt and hoodies. And this is very important because wearing them makes our presence more credible. We are legitimate employees if we have a hoodie of the company and a badge. Also, equipment we stole, there was 2 things very interesting that we got from the security control room. The door of the security control room is open all day with 1 person inside. There is an emergency number on the elevator that calls directly the security control room. We called that number, pretexted someone fainted at the top floor, and when the guard rushed out to get to the top floor to see what's going on, we entered the room, stole a walkie-talkie to be aware of guards' movement, because we could spy on their communication, and we stole surveillance camera recording. So everything we did was not seeable anymore on the camera recording because there was no camera recordings anymore. And there was it was the only backup they had, and nothing was on the cloud, so they were basically blind to our actions. The same day we arrived at 7:30 a.m. before the employees. After stealing equipment for the IT room, we roamed around the floors, and we saw a key box with a code on it, left open by the cleaning staff. Thanks, I guess. And yeah, we stole keys, including the master key of the building. So every door that was not badge lock now could be opened with the master key. And the same day, during lunch break, we saw a locksmith, just the street next to the building. And we tried to make him copy the master key, for which you're supposed to have a proprietary card to say that's your key. We didn't have that, of course. But locksmith said, I know what thieves look like. You don't look like one. Okay, I'll do it. Yeah, so we had a copy because we were not looking shady, I think. So thanks. So, entering the building, done. Stealing a bicycle, done. Stealing equipment, done. Now, let's steal some confidential information. In the building, there was 2 very important meeting rooms where investor meetings, direction meetings, etc. took place. And PCs managing the conference calls were 2 Windows PC with Zoom, and Chrome OSs were on the other smaller meeting rooms. So we dumped the hard drive to retrieve the local admin password. There was no BitLocker on the machine, so cool, easy. And the goal was to plant a backdoor to spy on the meetings to retrieve confidential information. We deactivate Defender and the Windows firewall. The PC isn't monitored, so no problem. We connected the PC to a VPN network under our control, and we activated RDP Shadow. RDP Shadow is a Windows option that allows a user to connect with RDP while another user has a session open, and you can basically spy on the session without the user knowing. So we activated that, connected in RDP during a meeting, and recorded. And now onto the best confidential information we stole. First, we had to locate the offices of the CEO, CFO, employee who manages bank transfer, basically every employee that deals with confidential information. How do we find the offices? Don't ask to us, just ask. We went to see some employees and said, where's the CEO office? Okay. So we went to those offices, no locked doors. Okay, we searched for everything. We found few documents, some car or bike keys. Okay. And the confidential bin, which is this. This is used to put a confidential document to handle waste management securely, but you will see that it's not secured because documents in there are not destroyed, they are intact, because it's the external service provider that should destroy them when they are picking up the bin. So the bin was full, so it was a long time since the company came, I think. So in an empty meeting room only in the morning, we lockpicked the bin, which is right there, and we took document from inside the bin. We had valid bank codes, credit cards, valid credit cards, blank signed check banks, and very personal employee documents. I'm talking here about health-related documents. So for social engineering attacks, it would be very successful, I think. So yeah, basically we had the bank accounts of the company. Now the IT part, because since we are on a winning streak, why not continue? Let's do some hacking. It was very trivial. Sorry to disappoint, but we had easy access to the server room because we had the master key. One PC in the room is unlocked, and the lockdown user has interesting security rights, aka admin rights on the CI/CD. We backdoored the computer to give access to remote access to two of our colleagues, and they compromised the company CI/CD. Success across the board. Thank you. Now on to some funny stories. While we were backdooring the computer with the Zoom meeting, activating RDP shadow, etc., some employees decided to throw off a pizza party. So we backdoored the computer just under their nose while they were eating pizza. I mean, it's all right. Also, when we entered the building at night with the under the door tool, we opened the door, okay, we got inside and we got outside, and we continued to scout around the building. And my colleague flashed his torch to show me something. And while the security guard didn't catch us, didn't call us during the lockpicking of the door, there the flashing light must have waking him up, and we heard on the interphone that was just next to us, what are you doing here? Man, parkour time. We ran off as fast as we could and ended the night there. Because it was the first day by night. It was a Monday, 2 a.m., I think. So yeah, avoid being caught on the first day. This is when we lockpicked the door from the exterior at night. So, as I said, security agent here was blind, or asleep, don't know. But when we were scavenging through the documents in the confidential bin, we were in an empty meeting room, early in the morning. There was no one in the building, except one security guard, which came to see us, looked around. My lockpicking kit was in display on the table, okay? Many documents, bank accounts, my lockpicking kit. I thought we're screwed. He came, looked around, don't say a thing, and left. Thanks. All right. During the intrusion, we were basically at home. So we took a little coffee on the rooftop, and we saw that there was an apple tree in a pot, and this apple tree made some little apple tree shoots. So we took one of those shoots with some soil, put it in our coffee cup, and gave it to an employee to say, yeah, take care of Groot, please. And after that, the next day, we bought a plant pot which is a new house for Groot, and we put it in next to the apple tree. I hope he's still alive. And remember the car or bike keys we found in the CEO's office? It was for his motorbike. So we could have stole the motorbike just like we stole the bicycle. We just put it on and put it off and gave the key back. But would have been nice. This is our path. In green, entry, initial entry. In orange, yellow, it's not so good. In red, it's really not good. And in black, you're screwed, basically. Now on to some more top level and more abstract things. These are the three pillar men, but three pillars to construct your physical security on. You must base yourself on people with training, awareness, company culture, etc. That's one of the most important pillars. You should rely also on processes, visitor procedure, onboarding, offboarding, and external service provider management. As you saw, the external service provider were, in fact, one of the main source of breaches in this context, in this mission. And also technology with badges, cameras, door control, physical barrier, etc. For the white team and before an engagement, to be professionals, you need to define the scope, what must be tested, what must be excluded. The rules of engagement, what's okay to use and do, what's not. Are we allowed to tailgate? Are we allowed to touch employees' personal belongings? Are we allowed to use some social engineering techniques? If so, which one? Are we allowed to break stuff? Are we allowed to disrupt the production operations of the company? And some safety considerations for auditor as well as for the audited company employees. Don't climb the seven floor building if you are not a professional climber. I think no, just don't do that. And legal and ethical consideration, the proper authorization letter. I'm insisting on that. Define points of contact that must be 24/7 reachable. And have a pre-agreed communication plan for updates, alerts, pauses, stopping the mission, etc. And also, in the ethical part, some social engineering attacks might not feel nice to use. Your mileage may vary, but it's not for everyone to manipulate people, I think. For the red team side, do your research well. Every detail can be important. Have good equipment for a large panel of possibilities. Also, rule of thumb, 2 = 1, 1 = 0. If you have only one example of a tool, you don't have it. Because if it breaks or gets lost, you're screwed. So always have a backup, basically. Take time for pictures in white team mode at the end and debriefing with the client, because the client has only your debriefing and your report to see what you did. So take time for that. Always carry your get out of jail card. And for social engineering, pretexting doesn't have to be complex to be effective. And the rule of thumb is to appear to be where you're supposed to be, like you belong there. And sometimes you also need luck. On the blue side, the company security level is the same as the level of its weakest element. Yeah, I know, big news. Corporate culture can do a lot. Badge wearing, for instance. In the mission, nobody asked us to if we had a badge or not. So that would have been difficult to enter, more difficult to enter if this culture thing would have been in place. Don't think only of securing your entrances, also secure with defense in depth, aka the badges have to be used at every floor, every time it's possible, just to make life more difficult for attackers. Beware of the service provider, as I said, security agents, catering, waste management, cleaning staff. Every one of those categories helped us in the mission to achieve our goals, so be aware of that. And always more than a single camera backup, because if it gets stolen, there is no trace of attackers. Thank you for your attention.
not have question for this talk? Or?
If we have time, we can.
Okay, so we can have one or two if you have.
Thank you for the talk. It was amazing. I have two questions actually. First, you mentioned that during the reconnaissance phase, you used street maps to see the entry points, but would you consider going yourself physically around the building, scout, or maybe entering the building that way and do reconnaissance that way? And my second question is, once I watched a talk where in the US they have some kind of universal keys for emergency services for elevators that would unlock, administrative options for elevators. Is there something similar in France that you would consider to take advantage of? Thank you.
Okay, so for the first question, yeah, we could have also scouted the building ourselves without relying on Street View, but neither Shenron nor me were living in the city the mission took place, and since we had only one day to prepare, Street View was our best option. But frankly, the first day at night where we got spotted, it was also to scout the building. Yeah, we do that. And I'm sorry, I did not understand your second question. Okay, so a security key for the elevator? Yeah, we could have do that. It was easier for us to steal badges than steal keys. We obtained keys, but later in the engagement. So yeah, we could have used that also. But frankly, I won't mess with an elevator internal working because I don't know how to properly do it. But yeah, I guess it's possible.
Another question? So, if not, oh yeah.
You can also come see me after the talk. No worries.
Do you have some time to use your out of jail card? Besides the out of jail card, a fake one would be a kind of nice bypass.
In another engagement, I had to use my get out of jail card because we were caught. And you said using a fake one?
Actually, a fake out of jail card could be also, if it's not really properly identified, someone can be on the phone and not really responsible.
I'm sorry, I have difficulty hearing you, but yeah, it would be possible to use a fake card, a fake get out of jail card, a fake get out of it later. I know some people do that in their physical intrusion, but frankly, I don't want to use it because if you are caught by police or law enforcement, I don't want to mess with that. Just, we were caught, bravo, and move on. And if I didn't answer properly to your question, okay, thanks.
So please, let's thank Volker again.
Thank you.
In the meantime that the next speaker came to prepare, just a quick reminder to submit your rump, if you have one, your slide, and make some comments in your email if you want to be recorded or not during the rump session. So we are ready. So let's welcome Kyle for the next talk.
All right, thank you for coming to my talk, Abstractions for Program Analysis. We did have a little bit of technical difficulties this morning, so there's going to be a little bit of formatting issues here. I apologize for that. But we're going to be talking a lot about programs today and abstractions. But nothing's going to be specific to any one programming language, operating system, or architecture. At points, we won't even be talking about code when we're modeling systems for analysis. But that's getting a little bit ahead. We're going to be looking at programs in a number of different ways that make it easier to answer the questions you care about. So if you're in the right place, you're some sort of engineer who works with code. Whether you write JavaScript or you're exploiting the Linux kernel day to day, I'm going to help you better understand the systems you're interfacing with. But let's make sure that we're all on the same page. Since we're going to be talking a lot about programs today and abstractions, let's start by defining those. Should be easy, right? We're all engineers. We work with programs every day. We should have a pretty good idea of what they do. So how would you define what a program does? Usually the first answer I get is more procedural than it is flexible. Something like they execute a list of instructions. But is that accurate? Is that just as apt of a description for an LLM versus a script? Aren't LLMs bad at following our commands? Don't processors execute our instructions out of order? Aren't there side effects and aren't there bugs? So I tend to prefer this definition. If they couldn't manipulate data, then the entire system would only have one state. And if they couldn't move data, we couldn't change between states. So we're only on slide 3, but we can already abstract a program to its list of commands and inputs as just moving and manipulating data. Or we can think about a program as the states it can be in and the transformations among those states, which is how fuzzers view programs, because fuzzers try to find all the states you shouldn't be able to get into in a program, not just invalid states, but invalid edges between states, which is effectively the same as tracking the data through the program, because the state of a program is just the values at different points. So, program analysis, don't lose my mic, is just the study of how data are moved and manipulated. And this holds true because early program analysis's main concern was to optimize code through removing excess calculations and trying to keep the data in one spot. But it's important to remember that program analysis is actually a field of mathematics. And those mathematics tell us that everything we want to do is generally impossible, which is often referred to as the full employment theorem for program analysts, but we shouldn't rely on that too much. Often these problems are postulated in imaginary spaces, and they often break down when applied to real systems deployed in the real world. I'm going to argue that we just need abstractions that capture the context to make those problems decidable. These systems aren't floating out in space, and actually that would be worse, because then we'd have to deal with random bit flips from gamma rays and stuff. We have to understand that these systems are working in the context of everything happening around them. Which is why this abstraction is one of my favorites these days. I jokingly call it the standard model of program analysis. When we think about how data can flow among points in a program, everything the compiler, reverse engineers, vulnerability researchers, and even you guys do when trying to understand code decomposes into 4 trivial queries. And another abstraction for you is that it fits on 2 axes in a nice little square. Those 4 questions are simply, may something happen before you, may it happen after you, or must it happen before you or after you? Now, these 4 algorithms are real, they have names, but they're not important. So let's take a look at this in context of some code. On line 9, I'd like to be able to verify that my function was initialized correctly. So we're going to be doing a forwards may analysis, since we want to know what the values may have been before line 9, and because I can see 3 paths through this function from definitions to the return site there. Now, to be able to automate this, it can be quite arduous because we're going to have to scan the text for return. We're going to need to process its arguments. We're going to need to determine if it's a constant or a variable. If it's a variable, we need to scan the text for other instances of that token. Then we need to keep track of uses and writes and order and branches. You're basically writing an entire compiler. And now, the bad news is that's unfortunately what you need to do. Hopefully, you're not writing a compiler every time you analyze a program. Hopefully, you're using a program analysis framework that provides it for you, but it needs to be done. And as long as it's being done either by you or by the program analysis framework, one little trick we can do along the way is to give numbers to each explicit assignment. And when we do that, we then encounter the problem of which version do we return? Do we return 1, 2, or 3? In fact, we need some way of representing that we can return any of them. And we do have a way to do this, but we need a little bit help. We need a little helper. So revealing feline and Fido. Their namesake comes from the Greek letter phi or phi, both are correct. And it's a function that statically merges all possible states of a variable. So at line 9 there, it's just saying result 1 can be either function 1 or function 2 or function 3. And by introducing phi, we've gotten to one of the most popular abstractions used in basically everything. This is SSA, or single static assignment form, because every variable is defined in one spot. This is really helpful for tracking data flow, and it's basically exclusively what LLVM uses. Because now it's super easy to see that the value of result 1 may be none. Algorithmically, all we're doing is we're iterating through all the variables that contribute to the definition of result 1 and ask, is this none, is this none, is this none, which is just a for loop or a call to map or an any call, whatever it is in your programming language. And with multiple exits, you just nest that loop for each return variable. And now, what I admire about this technique is the subtle brilliance in it, because it reduces a lot of the questions we care about into parallelizable Boolean queries that you can throw into some set math. And then the answers to most of the questions we care about just turn into whether none, some, or all the elements in a set are true. So actually, it's all Boolean set math. And if we're creative about how we combine these queries, all sorts of bug classes fall right out. So at variable use sites, if we may initialize a variable before, but not must, we have some uninitialized variable use on some path. At dereference sites, if we may initialize a variable before, not must, or we may be null before, we may have a null pointer dereference, but we still definitely have an uninitialized variable use on some path. And at calls to free, if we may use the variable after, you might have a use after free. By asking different questions at the same locations, we can expose different bug classes. And by asking different questions at different locations, we can find the same bug classes with different levels of precision. You can also chain queries to extract properties, and you can use them to find if unsigned subtractions are properly checked. And just for giggles, I throw in the solution to the halting problem as well, which is famously unsolvable, but there's a best abstraction for every problem you could want to solve. Depending on how you've been counting, if you've been counting, we've already seen 7 or 8, and I'm not making any of these up. Nothing here is novel. We've known about all these problems since the 70s, the 60s, and even earlier, and we know a lot of their solutions too. But the state-of-the-art program analysis frameworks are in many ways 30 years behind the state-of-the-art research. There's a lot of research out there that they just have not yet implemented. And what I've compiled here for you today are some of my greatest hits I think everyone should know about. So for the rest of this talk, we're going to be exploring more abstractions. We're going to see how they're going to be useful. But I also want you to walk away understanding the shapes that these abstractions take, how you might choose to reach for one, and what actually makes for a useful abstraction for program analysis. So what got me into this? My name is Kyle. I was one of the original interns at Vector 35. I've been able to touch just about everything in Binary Ninja over the years, which is great. Or recently I found myself on the training train, which is great because I get to think about how to distill some of the most interesting and at times some of the most chthonic looking concepts into something for engineers. I was wishing you could see this whole thing. This is the Galois connection calculus for abstract interpretation by Cousseau and Cousseau. The reference there got cut off. This is the same thing as the square from before. And I think you'd rather read it that way than through the calculus there. But this lets me help see things through new perspectives, which in turn inspires new research, new plugin ideas for Binary Ninja. And there's so many problems to solve, but we believe in engaging with the community, getting your feedback, and seeing what we actually need to implement. And I also have some hobbies. I'm fortunate enough to work in an area, work remotely in an area where I can be on the slopes of the mornings. So I work for Vector35, who makes a decompiler, disassembler, debugger, and binary analysis platform you may have heard of before. We're about 20 strong now. Roughly a third of us are remote. And the office itself is down in Central Florida, close enough to NASA to watch the rocket launches. But we were talking about definitions, and I got a little bit carried away. So let's start from the beginning again, but this time we won't stop asking questions. So what do programs do? They move and manipulate data. And what mechanism do we use in source code to describe those data? You literally define the structure of your data using types. And how do you describe how those data are allowed to interact? In some languages, you literally define your operators. But in most other programming languages, you define functions that are allowed to operate on those data. Think private and public member functions of a class. And some programming languages will only allow the same types to interact, whereas other languages will bend over backwards to let any or to not throw type errors. We're just going to let that dangle. All right, so what's a type? It's its data and an exhaustive set of rules for how those data are allowed to be transformed. If something is valid, the semantics, the meaning of that transformation must be defined somewhere. And I think that people forget this, which is why I often get that answer, that bad answer from before. Two types may have a function that allows them to, for example, add, but they also may not. And it's when the compiler runs out of transformations that it may apply in a given state when it starts to throw an error. Because it can't know what you're trying to do if you haven't defined the rules for how to do it. Which is a fancy way of saying that you need to define the semantics of your program through types as well. Since again, that allows you to constrain both the data and how it's being transformed. So, one last time, say it with me this time. What are programs? Programs are types. And this should make sense because, here we are, we have object-oriented programming languages. Since all programs do is move and manipulate data, and we describe those data with types, we describe those movements with types, we describe those manipulations with types, we can describe entire programs as types. And again, the states themselves aren't too interesting. Data by itself is rarely dangerous. It's how that data is moved and manipulated that we care about. It's the semantics of it. But the type theory here goes really deep. Types, in many ways, are the ultimate abstraction for program analysis. But we need to talk about how we get there first. So, types define the semantics, but it goes the other way around too. To be able to determine the types of things, you need to be able to understand how they're used. Their semantics, and I'm going to define semantics as the meaning of code. But so if semantics are the meaning of code, then what is the meaning of this code? A little bit of assembly there for you. We're moving 12 into AX. And now, it kind of depends on what 12 is. Is 12 a pointer? Is 12 an offset? Is 12 an amount of money? Is it a height? Is it something else? We can't know. We need more context to understand what this is trying to do. Assembly instructions by themselves are kind of meaningless. They don't have intent baked into them. And now, engineers sometimes get upset at me for saying this, because they're like, no, the semantics of that are definitely that it moves the bits of 12 into the A register. But that's only true if you're a emulator engineer. You only care about the execution characteristics of the instructions, not the semantics, not what it means. As program analyzers and reverse engineers, we care about why things are happening the way they do. We need a higher level understanding. So if we go up to C and we take a look at this, what's the meaning of this code? I'm still going to argue it's not much. C does not have that strong of a type system. We can still use this as a pointer, an offset, a height, an amount of money, any number of things. It is a little bit less than C, assembly, what it can be. But is it further constrained if I tell you that X is an integer? I'm going to say no, because you can still convert integers. What if I told you that this was happening in a loop? Then we're starting to get somewhere, because maybe we're iterating over pairs of elements. And then finally, if we keep going and we go up to Rust, Rust has a very strong type system. There we go. Since we can see that C is an integer, we know that A and B must be an integer. This is not going to be a function pointer. It can still be an offset. It can still be an amount of money. It can still be a number of other things. But it's definitely less things than C, and it's definitely way less things than assembly as well. So these are the promises our programming languages make to us with their type systems. The stronger the contracts, the stronger the meaning of the code, the better we can understand it. Now, when working with abstractions, context is king. You can try to translate ad hoc without context, but realize you very well may end up with a mess. This image is courtesy of Google Translate, which if it had realized I was trying to figure out the flavor of a candy, hopefully never would have translated the ingredient list like that. But again, we're working in the real world, and when we're analyzing systems, we need to define scope. You could model gamma rays flipping random bits, but do you need to? The most accurate model of a program might be a universe simulator, but that's not going to be easy to write, and that's not going to be easy to work with, and it distracts from the problem at hand. So instead, by looking at problems differently, by zooming in or zooming out, by throwing away or changing our base assumptions, we change the semantics of the system. A question that's impossible to answer in one semantic scope might be possible to answer in another. And we lost the image, but this is an XKCD solution to the halting problem, where he says, can halt return true? And it's funny because you shouldn't assume that a program will always exit. That's the basis of the halting problem. You cannot determine whether a program will run forever or eventually halt. But in the real world, I think it's safe to assume that someone will eventually forget to pay the power bill and the program will eventually halt. So by changing our semantics or semantic scope is exactly what we're doing when we're changing between abstractions, and it allows us to answer questions that were previously impossible. But when you're choosing the abstraction, there are some trade-offs. Do you want a very simple instruction set that abstracts all of 30 different mobs into one type of assignment? Or do you want to have an explicit instruction for every mob in x86? You would make a IL that's very easy to lift if you have one-to-one instructions from your assembly to your IL, but then it becomes hard to parse as an analyzer because you have to have thousands and thousands of cases for every different type of instruction. Now, of course, you do have some trade-offs there because if you only have one assignment type, maybe there are some types of mobs that have side effects that you can't model. You could go further. You could have maybe even a single instruction type for everything you want to do that has maybe some optional fields that aren't populated when they aren't used. Or again, you can have an explicit instruction for everything you're trying to do. There are more trade-offs though. Do you want types? Do you have type information? If you don't have type information, do you want to have to recover that type information? How do you want to represent side effects? And there are a lot of weird machines out there. So how flexible do you want to be for bizarre architectures and bizarre languages? ILs are not usually something that are looked at. They're behind the scenes. They're in the belly of the beast. So let's take a look at them. This is a list of most of the ILs used in reverse engineering for program analysis. But there is a big one missing here. You might notice it if you look closely. It's LLVM, because these are all the abstractions, sorry, that use LLVM. There's a lot of them in here. But there's even more than that, because there are flavors of ILs. You think of LLVM as this monolithic pipeline that compiles any source code language into any architecture. But actually, depending on the architecture you're targeting, the LLVM, that bitcode that Clang emits, will look very different. It has intrinsics, it will pack arguments differently. There are a lot of things that LLVM's main analysis pipeline keeps specific for the different architectures throughout the analysis. And this is true of our program analysis frameworks as well. In Ghidra, we have low P code and high P code. And even IDA has microcode that goes through several iterations of optimization before they finally emit their decompilation. Let's take a look at that. This is IDA Pro's microcode, the first step of emitting it. You can see the top 4 assembly instructions there get turned into all those microcode instructions. They only have 72 instructions, so you have to expand some of your x86 instructions, because you have thousands and thousands, into multiple instructions. But then they optimize. They fold a little bit, they fold a little bit more, and then eventually we get to something that I would never want to read and never want to write an analysis script over. I can't even tell what that's trying to do anymore. It's just too hard to read. Darn, we lost the P code slide too. But Ghidra has a similar concept. There's instructions that fold into or unfold into many more instructions, and eventually it turns into one instruction. What's nice about P code is it is actually a little bit more readable than microcode. Their final result value is better. Come see me after the talk if you want to see that slide. And then we have real as well. This is an example of a very reduced instruction set. We have a simple instruction which turns into 19 instructions there. Again, probably easy to write a program analysis script for, because you only have 17 cases you need to handle. But you're going to need to be processing a lot of nodes. So you sacrifice ease of development for, I suppose, compute time. And then this is what Valgrind and Anger uses. This is on the far opposite end of the spectrum. They have thousands of instructions. It's not RISC-like at all. And even despite that, they still have simple instructions that unfold into multiple ones. Because of that trade-off square from before, and as well as programmers wanting to be lazy, we tend to see a trend of tools using the most basic representations for code they can get away with. And there is a formalization for this. We call them normal forms. Normal forms are irreducible. Assembly is really close to normal form, which is part of the reason that compilers love normal form. But assembly instructions also can do weirder things. You have your LEA instruction, which has a multiply, a left shift, and an addition in it, all in one. But they can start from the normal forms and then sort of fold those together to get to the instructions that they want. What's nice about, well, there are rules for these forms. This one is called a normal form. There are different types of normal forms. There's also conjunctive normal form, disjunctive normal form, a whole bunch of other ones. But the ones that most of our program analysis frameworks use is going to be a normal form. And in a normal form, all arguments are a variable or a constant, and all compound statements have been simplified. And this is what it looks like. You start with a line of code that looks like on the left, and you turn it into what it is on the right there. What's nice about this is every intermediate value is named. Evaluation order becomes explicit. You no longer have to remember your order of operations. Small instructions are much easier to analyze in your scripts. You don't need to recurse through your sub-expressions there. And we can analyze these normal forms to find patterns that fall out. because we're normalizing things, we're reducing it to a fairly basic representation here, we'll see lots and lots of really useful patterns that come out of this. You can recognize structure member accesses, you can recognize array accesses just by looking at the ILs. But we can take this a step further. Once we have our normal forms, we can impose some additional rules onto them to make them even more useful for program analysis. So in SSA, all variables are read-only, and future reassignments are now new versions. And this is what it looks like. We've already taken a look at this. But wait, you need to reuse variables. What do you return here? We've seen this before too. We just need to introduce phi. We just need to be able to say result 3 will either be result 1 or result 2. But wait, you need to reuse variables. What do you do in this case? Do you have to unroll the loop? I'll give you a hint. The problem is on this line here. Oh, there we go. Right there. We know that we will need to create at least one new version, so we can throw that one in there for you to start. But we're still left with the question of what we're doing on line 2 there. We need Feline and Fido to the rescue. And what's important to remember here is that static is not the same as const. Const is a value that does not change. Static is a single definition that remains valid throughout its lifetime. So remember what I said. Phi merges all possible states. And version 2 here is defined recursively. One thing that people tend not to like when they first see this is they're like, wait, Kyle, you're using I version 3 before it's defined. But it's important to remember, these are not new variables. They are new versions of variables. The variable was defined on line 1. And on the first iteration in that loop, the phi will always resolve to I number 1. I2 will become I1, which is 0. And then I3 will become 0 plus 1. And then we'll go back, and I2 becomes I0 plus 1. These are both defined recursively, but they have a single static range of values. The values of these variables are allowed to be ranges. All right. So, in SSA, we have every variable has one definition, so this makes it really easy to build use def chains. We can simply find the definition for a variable and iterate through all of the variables that contribute to its definition. So if we look at this in code, we start with a non-SSA form of a code snippet on the left. We turn it into the SSA form in the middle there. You can see that we're returning C1. So where's the definition for C1? It's there. What is the value of C1? Well, it's B3 times A1. What is B3? What is A1? A1 is input. B3 is either B1 or B2. What are those? Those are A1 plus or minus 1. And A1 itself is the input to the program. So if we turn those into chains, we start to get what's all the way on the right here. You start with your return C1. You substitute in the variables that contribute to its definition, and then you keep going. You plug in that it can either be B1 or B2. B1 or B2 is A1 plus or minus 1, and then you can throw the input in there as well. And now we have a nice little formula for the value of this function. And we can represent that through graphs. SSA is super, super powerful because it allows us to do these forward data flow analyses. You start from all your sources, and eventually you trickle down to the one point you care about. If you start to track backwards, from the bottom to the top, you get path explosion. You can notice here that the definition of the variable we care about at the bottom there, R11 underscore 1 number 2, is actually coming from 2 function calls and the argument to this function twice as well. So then you'd need to recurse into those functions, see everywhere that this function is called, and as I said, path explosion gets crazy here, tracing backwards. So we have somewhat better representations for this. Since SSA is only tracking the definitions of variables, there's more information we can capture at use sites. SSI, which stands for Single Static Information, starts in SSA form, where the phis are merging variable definitions. But at branches, sigmas split uses. So if we start with the non-SSA form of the code on the left, we turn it into the SSA form in the middle, where we have our phi merging variable definitions. And then we can turn it into the SSI on the right, where we're inserting A2 here and A3 to represent the value of the variable at use sites. So in the first branch, we know that A1 will always be greater than 1. And in the second branch, we know that it'll always be less than or equal to 1, which is great. But then we do need to merge those variables again after the branch with phi. And again, by doing this, SSA or SSI, we can do our full forwards, backwards, may, and must analysis a little bit easier than we could on SSA alone. Now, it is worth mentioning, basically no program analysis framework out there implements SSI, but I've heard a lot of them talk about that they probably should and eventually will. All right. So, that brings me to my conclusion. I would like you guys to stop writing compilers, please. When you're trying to analyze programs, stop parsing the assembly, stop trying to figure out your operands and what's being written to and read from, and start using tools that give you adequate abstractions to answer those questions instead. Ideally, find a system that allows you to add your own abstractions in there. But more than just generate them, high-fidelity transformations among representations would be the true ideal, because there's a correct abstraction for every problem you could want to solve. More and more, I'm seeing tools with flavors of ILs, but I'm going to argue that this is an anti-pattern. If you have an IL that's in a partial state that's not fully filled out, we're not looking for one IL to rule them all. We're looking for specific abstractions, specific representations for the specific problems we want to solve. So, thank you for listening to my talk, Abstractions for Program Analysis.
We have the time for one quick question, if you had one. So,
Thank you for your talk. I just have only one question about something you said about LLVM IR. You said that it could be different between architectures. Is there a specific reason for that? Because as far as I know, its whole point is just to make it more, well, keep the representation similar between multiple architectures.
So the question is, why does LLVM have flavors of ILs, basically? The Clang is trying to pre-optimize the code. It knows the target architecture that you're trying to target, and it has heuristics built into it being like, this source code pattern is for sure absolutely most optimally compiled in this way. Don't do the analysis pipeline, just use our table of heuristics effectively.
So we can thanks again Kyle for his.
Thank you.
So we will have a last talk before midday. So please welcome Emric for his talk.
Hi everyone. So today I'm going to talk about smart chargers, and we're going to try to determine whether smart also means secure or not. I'm Emric Pallier. I work at Synactive in the reverse engineering team. And let's start by introducing a few concepts. So I'm pretty sure you've already seen smart chargers. It looks like that. Sometimes it's hidden inside a bigger box, but it's basically the same device. It allows you to charge your car faster, but it comes with a lot of smart features, like a remote access, the ability to handle billing for multiple users. And what's interesting is that it can be installed at home or in public places, such as a gas station or your workplace. Just a few diagrams to make the presentation look a bit smarter than it is. We see a lot of electric car. It's a booming market. And if we have more cars, we need more chargers to charge them. So there are already millions of them, and that's already enough to make it an interesting target for an attacker. But why would I want to compromise a charging station? Well, first, I could want to charge my car for free. It's already interesting, even though it asks a bit of technical investment in order to do that. I could also want to trap a charging station, either to steal banking information from other users or to add it to my botnet. But in my opinion, the most interesting scenario is to pivot within a local network the charger is connected to. Either it is a residential one or a corporate one. The real context of this study was to take part in Pwn2Own. It's a contest where you have to demonstrate your ability to compromise some devices, and if you succeed on stage, you have 3 attempts, you earn money. So it's very interesting. And what's even more interesting is that back in 2024, was the first edition of Pwn2Own Automotive, which is dedicated to chargers. There was a Tesla, some IVIs, etc. And generic rules about Pwn2Own is that newcomers are generally easier targets because they've almost never been audited. The agenda for this talk is the following. First, I'll describe the architecture of the chargers, how they work, how they interact with other systems. Then we'll try to identify different attack vectors and assess the security level of these devices by analyzing the different vulnerability we found for Pwn2Own and their exploits. And finally, because we're some good guys, we'll provide some recommendations for improvement. Okay, first, what's a charging station? Well, here are the models we've studied. They all basically look the same. You have a big box and a Type 2 connector that will be plugged to the car. So we have also studied those one, and finally the ubiquity one. But what's inside the box? First, on the left, there's a power board. Well, there are some impressive electrical components. I don't know much. It's not really relevant to us since it's only used to deal with the power and talk with the car. But on top of that, we have the main board. It will hold all the communication interfaces. You see first a Bluetooth module, for example, some RAM, and on the other side there are some a flash memory, RJ45 connector, and even sometimes there are some 4G. So that's a lot of connectivity, and that's pretty interesting for an attacker. You see what's in the box. It's always the first step when you want to start looking for vulnerabilities in such devices. You have to open it and find a way to obtain the firmware so that you can look for bugs. In some cases, this firmware were available online freely, and that's really useful for us, but sometimes they were not. And we had to to use a physical attack to obtain it. You see, for example, there are some test points. I don't know if you see the, well, yeah. There are some test points here, stuff like that. That's what you're looking for. And sometimes it's JTAG, sometimes it's SWD. These are protocols that will allow you to dump the content of the memory and obtain the firmware this way. So that's what we did for some. Okay, I'll introduce a few concepts that will help you understand the rest of the presentation. That's the charging port, also called the Type 2 connector. There are some basic electronical stuff. You have a neutral and line 1, 2, 3 to transmit power. You have an earth or ground. And you have also two interesting lines for us. The proximity pilot, which indicates a cable is present, and a current rating. And the most interesting one is the control pilot. It's a pulse width modulation signal, which sends basic information between the car and the charger. For example, the maximum current available, if the vehicle is present, if it's currently charging, etc. On top of this line, the PLC signal is superimposed. So those two signals are superimposed and they don't use the same frequencies. So you can have both at the same time. And this one enables smarter communication. It's actually what lies under V2G and plug-and-charge protocols. Speaking of V2G, for vehicle to grid, it's actually a stack of standards that allows interacting with the grid, which is the electrical network. That way, electric vehicles can draw energy from the grid, it's called charging, but they can also send back energy, discharging. What's interesting here is the link between the charger and the backend, which is made by the OCPP protocol. The OCPP protocol is an open communication standard to discuss between the charger and the backend, and it's generally used to remotely manage the charger. The protocol is pretty simple. You have an example payload on the right. It's basically some JSON over a WebSocket connection over internet. So it's pretty trivial, but it allows to do really interesting stuff, such as monitoring the charger, updating its firmware, starting or stopping charging sessions, etc. It supports basic security features, such as certificate authentication, TLS, and the ability to sign messages. We'll come back to it a bit later. To sum up the interconnections between the charger and different systems, I've done this simple diagram. You see there are lots of interfaces. The big gray square is the charger, and it interacts with the car to send basic information and to send power, but it also interacts with its backend. Another key concept is the strong design constraints you face when you try to design an IoT device like that. You want something cheap, so you want a cheap MCU, but the problem is that cheap MCU don't have important features such as an MMU for memory management unit. This is what allows you to isolate processes, have some memory regions with permissions, and implement basic concepts such as virtual memory. If you don't have that, you can't have important security mitigation such as ASLR, for example. And in most of the chargers, we've met MCUs belonging to the first part, the cheap one. Sometimes we found higher-end MCUs, including a memory protection unit. It's better, but it's not the best. And finally, there are some high-end SOC that we've never seen, who have a real MMU capable of running an operating system such as Linux or Android. Okay, now you know what's a charger, how it works basically. Let's see how secure it is. If you had to design a security model for your charger, here is basically what you want. First, you don't want the charger to explode once you plug it to a car, so that's safety. It seems logical. Then you want your users to be authenticated when they want to charge. You also want to protect the data they store in the charger, such as banking information. And finally, you don't want the charger to be jailbroken and run arbitrary code or Doom. Okay? So that's the basic security model. But how is it applied now? Once you have the security model, you have to study the attack surface. If I try to sum up everything we've seen, the first one is the cloud backend. It holds sensitive information, and you can also administrate the charger from the cloud. So it's pretty sensitive in terms of security. You also have sometimes a mobile application which allows you to update the firmware of the charger or to send Bluetooth commands. You'll see later it's very interesting. Often you also have some Wi-Fi or Ethernet connectivity on the charger. So that means that someone on the same network could reach some network services exposed by the charger. There are also user interfaces. On some of them, you can pay using an NFC card or authenticate. And there are also USB ports sometimes. And finally, you have the charging port, where you can discuss the car with the charger by the charging port using the CP line. Finally, there's the physical layer, but we've used it to obtain the firmware and debugging setup, but it was not allowed as a valid scenario during Pwn2Own, so we removed it. If I come back to my diagram, you see that actually most of it is an attack surface. And in the next part, I'll try to show you how we've attacked all of these surfaces, basically. Well, let's start by the USB surface for the Hotel Maxi charger. First, there was a USB port hidden behind a piece of plastic, but if you had a screwdriver, you could open it, so it's fine. It was approved by Pwn2Own organizers, so we considered it a valid scenario, and we started looking for bugs in the USB stack. You see the function is the function handling setup packets. In the USB protocol, setup packets allow to initiate a transfer, and they indicate the size of the data that come after. Here, the packet variable is completely controlled by the attacker, and you see the size, W length, is not checked, only it must be different than 0. So this function gives two strong primitives. Also, the USB setup buff is a fixed size 16 bytes, I think, heap buffer. So if you give a bigger size, you have either an out-of-bound read or an out-of-bound write, depending on the direction of the packets. The idea here is not to focus on the exploits, but just to show you the vulnerability if there were any memory protections or not. In that case, there were none. So what we did is that we wrote shellcode and patched, using only this primitive, patched a function pointer on the heap to jump on our shellcode, and that was done. Because there were no security mitigations. Otherwise, it would have been much more difficult. Let's talk Bluetooth now. Still on the hotel, but a year before. We could send Bluetooth commands of the following form. There were two fields, OP code and func code, allowing to dispatch our packet through different handlers. However, all functions require authentication. Let's see how this authentication is made. Well, actually, there are two ways to authenticate. One is good, and the other is worse. The first one uses a magic key, which is derivated with the password, etc. It's fine. But the other one, which has BD in its name, for backdoor maybe, only uses an hard-coded constructor key. So if you are able to reverse engineering this binary, you have the key. Okay, fine. Now we are authenticated. We can reach more code. And here you see the dispatcher between different commands. And we've read the code basically, and focusing on this one, charging control param. Well, the function is really trivial, but we see fixed length buffer on the stack, a memcopy in this buffer with a controlled content, no size checks, smells good. Well, that's enough. The stack is executable. There's no particular mitigations. The only problem is that we're facing a real-time operating system, so we won't be able to have a real shell. But it doesn't matter because at Point2On you only have to show that you can run code. And a way of making this is, for example, blinking the LEDs in the front panel of the charger. So we did a short wall rope chain that was jumping to a shellcode on the stack, and the shellcode was blinking the LEDs. Still no security mitigations. Another Bluetooth vulnerability on another charger, the ChargePoint on Flex. This one was even more trivial, I would say. The device broadcasts two BLE characteristics, ESSID and password. That means anyone unauthenticated could write this characteristic and change the SSID and password of the ChargePoint. Then you have two binaries. One on boardie receives the BLE packet and forwards them to WLAN app via IPC. And the second one handles the Wi-Fi configuration message. You reach this function, finally, when you write the Wi-Fi password characteristics. BLE controlled variable is actually controlled. So here you have at least a command injection. It's because you control the BLE, it's injected into the command, and the command is executed by the popen function, which is dangerous. So pretty trivial. Here is the exploit. I think we missed 2 lines, but that's it. You connect to the device, read its characteristic, write a new password injecting a Linux command. What's really useful to us is that the telnet binary is present on the system, so you have an embedded reverse shell. It's cool. And that's it. One point about mitigations, such vulnerabilities are pretty difficult to mitigate, but they are relatively easy to prevent if you simply audit the code and look for dangerous functions such as popen or system or whatever. Another attack surface we've targeted is the link between the charger and the backend. So it's using OCPP, as I've explained previously. The binary responsible for that on the ChargePoint is the CPS relay, and while browsing the file system, we found the cps.conf configuration file. It was pretty interesting because we saw some paths related with certificates, because yeah, the WebSocket connection is protected by TLS, so we need certificates. And we also saw a variable, verify hostname equal 1. Our idea here is to intercept the connection and to man in the middle. So we have to authenticate. But this variable verify hostname, well, we're like, oh, it will be difficult. But actually, this variable corresponds to a curl option that's very misleading. Because back in the older curl versions, when you set this variable to 1, it actually means, okay, the certificate must be signed by a trusted CA, but don't check the domain. So don't verify the hostname. If you want to also verify the hostname, you had to set 2. It was so misleading that it has been fixed in the recent versions of libcurl, but this one was outdated. So okay, why not? Also on the file system, we found a certificate signed by the ChargePoint CA, which is good. Not for the right name. The name actually is the charger one, and we wanted to impersonate the backend. But since we have this curl option, he doesn't care about the name. So that's fine. Using this, we can impersonate the server and man in the middle the connection. That was also protected by a client certificate, but we found it on the file system, no problem. The most difficult part was probably to configure burp suit to being able to intercept the communication, but we finally managed to do it. And then we were able to see all the OCPP commands passing between the backend and the charger to modify them and to send them. So that unlocks a new attack surface. You have an example of an OCPP command on the bottom, and you see it's just JSON, but there's a custom format here. That's a command only on the charge point. The first field, the fields are separated by bytes, and the first field is the command name, and the rest are arguments. So now we can look for vulnerabilities in the OCPP commands parsing. Well, let's take first handler randomly. Oh, there's a vulnerability. You see there's a while loop. It parses arguments for the command. And while it finds some new arguments, it copies them into a stack buffer of fixed size. Well, if you send enough arguments, you have a stack buffer overflow. There's almost no mitigations except the NX bit. It means the stack is not executable. So we had to build a simple rogue shell calling a system and our favorite binary telnet-d. And that's it. So it's a bit better, but still not perfect. A very original one, attacking the charging ports on the Tesla charger. Here is a capture of the control pilot signal. You remember this line in the Type 2 connector? And actually, on top of that, Tesla implemented a single wire protocol. A single wire CAN protocol, sorry. On top of CAN, if you know a bit, there can be UDS, which stands for Unified Diagnostic Services. It's a protocol that allows operations such as updating a firmware, for example. Often, UDS sessions are authenticated, but in that case, the authentication was only a single byte XOR on a not coded value, so not too difficult. And UDS also can be used to obtain Wi-Fi AP credentials. The final information to understand the exploit is that on another version of the Tesla charger firmware, there was a debug TCP shell reachable via Wi-Fi. Now you have all the key parts. What's the plan? We want to downgrade the charger's firmware to the older version using UDS. Then we want to obtain the AP credentials. We connect to the AP, and then we can reach the TCP debug shell. However, it was not a full shell, so we had one more step to be able to execute arbitrary command. But this shell was very old, full of vulnerabilities, so you take any command of the shell and there's a vulnerability, so it was not the most difficult part. What was really interesting about this one is that you have to fake a car to discuss with the charger. And in order to do that, my colleague David built this box, which is actually a Tesla. And I highly encourage you to read his blog post. It's very fun. There were stack cookies, but there was no anti-downgrade mechanism that would have completely killed the exploit and not the rest of the mitigations. Let's attack the local area network now on the Juicebox 40. Well, this one runs Gecko OS. Maybe you've already heard of that. It's well known and documented, but it comes with a remote terminal enabled and listening on TCP port 2000. There's no password by default, and you can't disable it. So, fine. Let's explore the documentation. There are lots of commands available. One is HTTP download, and reading the documentation, you see that it contains a documented format string vulnerability. I don't really know why, but if you send this command, it leaks some heap addresses. Okay, why not? Let's use it. But it's not enough to compromise the charger. We need to find something more. While reading more code, in this function, we found a buffer overflow. Because when you send at t, 23 bytes are copied to a fixed size stack buffers. So if you do it enough times, there will be a stack overflow. Okay, now we should be able to combine these vulnerabilities in order to get code execution on the device. First, we use the format string to leak some heap addresses where we'll be able to store our shellcode. And then we'll use the Stack Overflow to redirect the execution flow to our shellcode that we know the address. And finally, we trigger the exploit by calling HTTP download command. It was a bit more complicated, but still doable without mitigations. There's more, actually. I don't have time to talk about that today, but the one on Ubiquiti was pretty interesting because there were mitigations, but we found a logic flow that completely bypassed them, so it's a bit sad. And another participant attacked the 4G on charge point, so they decided to remove completely the surface this year, which is a good idea. Let's take a step back and analyze the results of this study. Well, we clearly see that security was not a priority while designing these EV chargers. We don't have all the main mitigations, I would say, which are more than 20 years old, and the code has not been audited clearly because you have some command injections, you have some trivial vulnerabilities. An audit would prevent that. There are a lot of connectivity, a lot of protocols, and that means a wide attack surface. Do you really need to have all these communication methods on a charger, like 4G, for example? Is it all necessary? The good point is that initiatives like Pontoon, they slowly but surely help raising the security level of this industry, because it can be seen as a semi-rigorous audit. There are multiple persons auditing all the code every year and reporting vulnerabilities. Also, the good part is that the new edition of Pontoon has just been announced. There are still EV chargers and there are newcomers, so maybe stay tuned. Finally, some areas for improvements if you ever have to design a charger. Well, first you want to harden the system. And it starts at the design stage, when you have to think what MCU will I use for this device. The cheaper won't be the best. When available, you should enable security mitigations and, of course, audit sensitive code. There are really some quick wins, such as avoiding dangerous functions, a p-open system, etc. And once everything is hardened, you can try to reduce the surface. For example, disable useless service, debug shells, etc. It's not really needed, but it's a second step. If you want to know more about this, it's detailed on Synactive blog post, also other resources that were very interesting. And I'd like to thank, of course, my colleagues who worked with me on this project, and it was really always fun to work on such targets. And that's it for me, if you have questions.
We have time for 1 or 2 questions.
Hello, I have a question. What was the attack pattern that you used in order to dump the different firmwares of the different chargers that you had to attack? Because as you said, the most security measures were about hiding the firmware. So what was your strategy in order to dump them? Thank you.
So I'm not sure I've heard all the question, but you ask how did we obtain the firmwares, basically, yeah. So in some cases, they were available online or in a public SDK, so that was easy. And on some cases, in the hardware part, I'll try to come back to it. It's a bit. There were some JTAG connectors or SWD connectors on the board, and we, yeah, for example, yeah, here. Here, it's I think SWD connector. You can plug to it and dump the content of the memory. So it contains the firmware. And sometimes use other protocols such as JTAG, etc. But there are ways to dump the firmware when you have a physical access. This can be protected also. There are protections such as the RDP, etc., but it can also be bypassed in certain cases. Advanced people, and I'm not one of them, you could also desolder the flash and read its content, but it's getting a bit too sophisticated for me.
We have time.
Hello. Yes, I wanted to know, you mentioned that one of the firmware was encrypted, but was it signed, and how many of the EV charger had the secure boot mechanism?
No, none of the chargers had secure boot implemented. The encrypted one was downloaded by the companion app and uploaded to the firmware, which was able to decrypt it. We were a bit lucky on this one. We used some cryptography skills to guess the encryption method. It was a bit difficult, but we using solvers such as Z3 and really some beanwalk and some it was I have another presentation about that. It was a bit difficult, but we managed to recover the plain text firmware without only guessing the crypto.
Thank you.
Okay, let's thank our speaker again. So now it's time to lunch. So you can find the lunch in the area downstairs. Next station is at 2 p.m. And there is a medical bags that have been found. So if you are the owner, please come to us to retrieve it. And don't hesitate to submit RUMPs. Tu gardes mon sac le temps que je...
Comme il a plein de trucs électriques, les voitures, je pense qu'il va venir te brancher. Tu le verras pendant cette heure. Non, je pense pas. Mais peut-être ce soir, on va la journée. Bonjour, ça va?
enough for presenting myself.
Okay, we're going to be resuming. I might ask some of you guys to maybe try to avoid empty seat in the middle of the row. That will allow late people to join and to sit more comfortably. And we will start this afternoon session with Alberto, and I will let him introduce himself.
Hello to everyone. Thank you for being here. I know that it's not the best slot for the talk after the lunch. So a quick who am I? My name is Alberto, as he mentioned. I'm also known as Bubu in the security community and CTF. I'm mostly interested in web security and privacy, also on browser internals. I'm a CTF player for a couple of teams. Maybe the team that you might know is the Hackers Crew. I'm also invited expert of the W3C Security Interest Group. So this is just a slide for a sort out for root me and the Threads community. So this is like a part of how I started. So just a sort out for them. So I'll be talking about browser permissions. Just a bit of disclaimer, I'm not going to talk about Android. Mostly it's only browser in the desktop. So as you might know, there are a couple of permissions in the browser, like geolocation, camera, microphone, display capture, USB, clipboard, and a lot of people use these kind of services daily, even our mom or parents or friends, and they are not really into computer security. So how this works? There are around 80 permissions, more than 80 permissions. There is no up-to-date list. Some of them are like really popular, like camera, display capture, but there are also others like local network access. That is a permission in which the website can access the local network if you don't allow it. So this is an open source tool that I developed, and is like open source tool and also the website, and it's a list of the different permissions that are supported by the different browsers. So you have like all the Chromium-based browser, also Firefox. So maybe this is the most up-to-date list. There are two main characteristics on permissions. The first one is if it's powerful. If it's powerful, only means that there will appear a pop-up to the user, like the usual camera that appears a pop-up, and the user needs to explicitly grant or deny the permission. And the other one is if it's policy control. In the case that if it's policy control, it will have a default allow list. That only means that, for example, on self, only the top level document will be allowed for using the permission if there is no delegation. So not every policy control feature, not every policy control permission is powerful, and not all the powerful permissions are policy control. Most of them, they are both of them, they are policy control and powerful, or only policy control. Apart from these two main characteristics, there are individual specs for each of the features. For example, for camera and microphone, there is this media capture and streams. And on this specification, apart from declaring a lot of stuff, they usually have two sections. One is talking about if they are powerful, and the other one is if they are policy control. These screenshots are from the media capture and stream, and you can see that there are a definition of two permissions, camera and microphone. And for the policy control section, there is also the default allow list. At this point, how a developer can restrict access to the permission. Like, for example, my website is not using any of the permission. How I say to the browser that my website doesn't use permission, and not iframes and not third-party scripts can try to trick the user. There is a header that is an HTTP response header that was formerly known as feature policy, but got rebranded in 2021. Also, the syntax changed. And in the case of permissions policy header, it's really simple. It's like on the example, maybe it's a bit small, but is camera equal to empty parentheses, and that means that on your website you are not going to use, and the scripts can ask for the camera. So just to be on the same page, I have like a couple of examples. Let's say that there is a permissions policy header that, as I mentioned, is for restricting the permission. And then on the right, there is an allowed tag. Allowed tag, HTML allowed tag, is for doing the delegation to other contexts. So on the header, we have camera to empty parentheses, clipboard read to self, and clipboard read to self and iframe.org. The website includes an iframe with a source iframe.org and the delegation. So in this case, the camera won't be allowed in any of the context. Clipboard read will only be allowed because of the permissions policy header on the website, on the top level document. And the clipboard write will be allowed in both, on the website and also on the iframe. If we change the iframe source to second iframe.org, this won't be allowed to use or ask for any of them because of the permissions policy header. The website that I saw before, also has like a part on it in which you can create your own permissions policy header, because in a research that we did, that we'll talk about later, that for developers, even that it looks simple, for developers it's also hard for declaring this header. Like we saw like thousands of websites using like ending the permissions policy header with a comma, and that is a misplaced comma, and for the browser will be the same as not declaring the header. We also saw that some websites declare contradictory directives like self and wildcard. So this tool that is also open source allows developers to declare their own header. Now we are getting to the funny part, or the hacking part. There are a couple misconceptions in the community. The first one is controlling delegation versus same origin policy. So in the moment that the permission is delegated to a context that you don't control, that you lose the control of that permission. So in the example on the right, there is foo.bar that has not iframe.org and iframe.org. In the moment that the permission is delegated to iframe.org, iframe.org can delegate the permission to not iframe.org, even that you have on your permissions policy header, only iframe.org can access or try to access the permission. These misconceptions are going to be important for the rest of the talk. The second one is the misleading prompt. So you visit like foo.bar, and foo.bar has a widget that is from the origin meetexample.org. And if meetexample.org tries to access these permissions, on the pop-up that will appear to the user, it will only mention the visited website. In this case, foo.bar. This can trick like the user clicking or granting the access. The last one is that there is no reprompt. In the moment that you grant the permission to the website, and let's say that later an iframe is included, that iframe can access the permission without a reprompt. So with this like permission model, I'm going to explain two thread model that can happen on this permission model. The first one, in which I found vulnerabilities in two big popular software. So on this first one, the idea is to hack embedded documents that have permission delegation. In the example of the slide, there is BubuChat that is included in different couple of websites like news, weather, a bank, and so on. And it's a really popular widget that always has a delegation of 3 important features, like camera, microphone, and display capture. So the idea here is to, instead of hacking each of the websites, to hack BubuChat in order to do this second delegation to do a permission hijacking. So the idea is to insert this second iframe just by hacking BubuChat. how I found like potential candidates, or how I found that this theoretical attack could be like real. This research was part of an academic research that was published this year at IMC 25. On this research, we did a measurement of how websites use the permissions, how they delegate the permission, even how developers declare the permissions policy header. And we found that there are some of them, some iframes, that they always delegate permission, but they don't always use this permission. And from this kind of iframes, we found that there is one category that is customer support widgets or chat widgets that they usually are included with camera, microphone, and display capture. So that's how I found like these candidates. So customer support widgets usually appear in the corner with an icon. And if you click it, it will open a chat in which you can talk with the worker of the company for asking questions, and the worker will reply. These chats are really common, are really widespread, even in banks, so it's not like some edgy case. And for the companies, it's like a really good solution for having all the questions from the customers in just one place, for knowing also some information from the customer, like sometimes the location, the email, and so on. So it's like a good software solution for the companies. In the first case that I found a vulnerability for doing this second delegation and for doing permission hijacking was glasses. Glasses, depending on the statistics, it is included in 100 websites, but if you take like whole internet, it can go to almost 2,000. On this one, as an attacker, I just tried using the software. I sent like a couple of messages, and usually in this kind of software is useful for having like an attachment, like documents that you can send to the worker, like for example, proof of a payment that you did, or a screenshot or something. And I found that there was a type field on these attachments. As an attacker, I just tried changing this type, and I found that you can insert more things than what they would expect. So you can set like audio, video, and there was one of them that was including like a website inside the chat, like an iframe with the type 8. So you could insert like this document, and the worker would load this website. Don't know if you know, but there are local scheme documents. I'm going to talk a lot about local scheme documents, so they will be important for the rest of the talk also. These are headerless documents, so there is like no request out and no response. There are no headers. And it's called local scheme documents that they are running in the same origin in which they are embedded. So I use like this for inserting my JavaScript, but for the case of glasses, they were using CSP, Content Security Policy. Don't know how many of you know CSP. CSP, or Content Security Policy, is a response header for like an allow list of resources that the browser can load. So if your script is not in this allow list, it won't execute, so you won't have the cross-site scripting. But as you can see, this one was really big. And there are many community tools to find if there is some of these endpoints that you can use for your cross-site scripting. So I just use one community tool that is called CSP Bypass. And the idea was to include one script that is allowed, like the one from reCAPTCHA. And this one will take a custom event that in a normal HTML browser won't execute, like ng on error, but loading this script will allow bypassing the policy. So at this point, I have like a cross-site scripting on the side of the worker. So just by sending a message, I can do a cross-site scripting on the other end. Assuming, because my idea wasn't like to be an expert of this specific software of glasses, I just assume that the person that was reviewing the chat had also some admin privileges to change their own widget. So as I said, at this point, just sending a message, I can have cross-site scripting on the other end. So let's move on to the second part, that is including our code into their chat widget of the company. So I just went directly to customizing the chat widget. Usually this kind of widget have some fields that you can change, the color, the icon, the photos, and so on. But for this case, there was a specific field that was embedded apps, in which you could insert like your own website inside the iframe that they have. So as you might think, I also use local schemes for doing this second delegation. So with this second delegation, we have like the complete exploit, like for doing this second delegation and doing permission hijacking. So a small recap, just collecting all the companies that use glasses, you send them this payload with the type 8 using the local scheme. And with this, for the cases in which the person who is reviewing the chat has also access for these embedded apps, you could insert your iframe in their company iframe, doing this second delegation. And with this, you can, from your document, ask for the permissions of camera, display capture, clipboard read, and so on. And because of the misconception that I explained in the beginning, the user can trick granting the access to this permission. So I just did a small proof of context that this was working. I used the first part of the payload, and I got a ping back. This is not an IP from Spain. So it just was for knowing that it was working. I reported on May, a couple of days, one day later the reply, and 2 days later they applied a fix. Let's move on to this one, to live chat. That is one of the most common chat widgets that there is out there. Depending on the statistics, it can go from 38,000 websites, but if you check like in the whole internet in Buildwidth, it can go, it is embedded in almost 500,000 pages. This one, as you might think, it was a bit harder. So just a bit of technical information before starting. Live chat uses 2 iframes. The first one, that there is no source, so it's same origin as the website. When it's minimized, and when you click it, like it does the delegation, and it also allows the source to live chat. So on this one was a bit harder. I tried like the same approach, digging into the chat. There wasn't anything useful, and then like I moved to the admin panel, and on the admin panel I saw that there was an iframe of the marketplace. Usually this kind of software has this marketplace for adding like more stuff, more functionality into your widgets. And at the beginning was like, okay, they are doing an iframe of the marketplace, and I started like checking the marketplace. They can add like plugins from WhatsApp, Telegram, and so on. I saw that there was a comment section, like in any kind of marketplace, but this one was a bit special. They were using like Markdown in the comment section. Why would you want to use like Markdown in the comment section? So at that moment, I thought that this is like my entry point. I checked which library they were using. They were using one that is called Markdown to JX, and I saw that there were a couple of issues in all versions. Also, on the README, there was no mention to security, so it was like a good starting point. I found that using content editable, this is the first thing that I found, that using content editable, you can break the website. This one wasn't because of the library, it was how they include the library. A second one was a meta redirect, so you could redirect any of the plugin websites to your own website. The third one, it was an style injection. You can like change the color of your name or the color of the page and so on. So just by creating an account, you could do all this stuff, like doing the redirection, maybe for phishing. You could make like the marketplace inaccessible. Let's say that you develop some plugin and you want to be like the best plugin in the marketplace. Or the third one, you can change the style of the page because there wasn't like anything useful on that page. But finally, I found one way of doing the cross-site scripting. It was a one-click cross-site scripting using button for action. But this is even worse when you can also change the style of the page. So you could make like the button all over the screen like invisible, or you could put the button in the same place as the installation button. So it's one click, but there are ways of being like easy for the admin to click it. At that point, I thought maybe they are using a different token for the marketplace, because remember that we are on an iframe, or that is a different origin. And maybe they are using like a token that can only install and remove plugins, but this one wasn't the case. So the same access token that they had on the marketplace is the one that you use in the dashboard. So you have like the same privileges. So here, like we just need to create an account, and we can comment in all the plugins on the marketplace. And when an admin like loads this page from iframe or just visiting the marketplace, it will appear like this invisible button or the button in the top, in which if the admin clicks, it will be an account takeover, or what are we trying to do the permission hijacking. So let's move on to the second part. Same as before, the first thing that I checked was the chat widget customization. All parameters were sanitized, like changing the color, the position, and so on. All parameters were sanitized except one. And for us as an attacker, we only care about having one entry point. So just a recap, this is like the full chain. You just need to create an account, comment in all the plugins, and wait to admin person visiting the marketplace and clicking somewhere. At that point, you have like the same permission as that person, and you have an injection. And the thing here is that the injection wasn't on the different origin iframe. It was on the same origin iframe, that is when it's minimized. So you have like a cross-site scripting or an HTML injection on the website of the company. So I reported this last year. A couple of days later, they replied, and 10 days later, they applied a fix. Now we are moving to the second part. For this one, I don't have like any vulnerability, and it's for the websites that use a permission for the service, like for example Meet or Zoom, or for example the websites that allows you to change the configuration of your keyboard. So for these cases, if they don't declare the permissions policy header, maybe you can do an HTML injection for delegating the permission to your domain. So let's say that you are on a meeting and you granted like the camera, the microphone, display capture. In these cases, it's even worse because you can have granted the permission, but you turn it off with some button on the website, but the permission is still granted. So you can still delegate the permission and do the permission hijacking. So for these cases, even if they have like a really CSP that you can convert this into cross-site scripting, you could, with an HTML injection, if you find some HTML injection on this kind of websites that use the permission, you could delegate these permissions to your domain. And for this one, it's not even important the misconception, because you will be allowed to use the permissions without doing any reprom. So the only solution that they have is like declaring a strong permissions policy header to a directive cells, like for example, for Meet using camera self. It's true that most of the websites, they don't declare permissions policy header, but the idea will be that if they declare permissions policy header, they will be like safe. But this is not true. Local schemes like attack again, strike again. If there is a website that has a policy of camera self and there is like a delegation to a local scheme, if there is a delegation from this local scheme to to attacker, the idea will be that this local scheme, because they are headerless, they have to inherit the policies from the father, from the document in which they are embedded. Like for example, it happens with CSP. But this is not really true right now. It's a bug that I found last year, and it still works in all the Chromium-based browsers, in Chromium, in Chrome, and all of them. So even if there is a camera self header, you could use a local scheme to avoid this policy. And this is all. I have like 3 words. The first one on the left is like the academic paper in which we did like the top 1 million measurement. The second one is a blog post of how all this stuff works, because I can explain it in 20 minutes. So I recommend reading it. It's short. And also this one, it also appeared on the page out scene. So I think all of you got one printed version, so you can read it there. And the last one, maybe like for a warm-up for tomorrow's CTF, I designed a challenge for the CreCTF that was this year. It was a 48 hours, and only 15 found the solution. So if you want to try it, there it is. And that's all from my side.
Thank you, Alberto. We have time for one question. No one? Everyone is trying his digestion mode? Okay, so we're going to be, thank you, Alberto, again, and we're going to be having welcoming our next speaker. I'm not sure I understood everything. Actually, I received a lot of notifications. Aurélien, salut. J'ai juste un truc à regarder.
push. J'ai 30 minutes, on est d'accord?
Okay, we're ready now to listen to Aurélien, who's going to be a long and short dive into MySQL. And I'll let you introduce yourself, Aurélien.
Yeah, all right. So my name is Aurélien Chalot. You probably know me as Deft on the internet. You don't know me, it doesn't matter. The thing is, I'm a hacker and sysadmin and security researcher at Orange Cyber Defense. And as you can see, today I'm going to talk to you about MS SQL databases and Active Directories and a lot of stuff about the Windows Microsoft world. The thing is, I initially created that presentation thinking it would be a 40 minutes long one. It ends up being a 30-minute long one, so I will have to rush a bit, but don't worry, hopefully you won't be lost. So yeah, basically, how did I end up working on that subject? You may know NetExec and InPacket. If you've been doing Active Directory assessment, you know what these tools are. The thing is, I am one of the maintainers of NetExec. I work with the development team. And one day, I had the following issues, which basically says, well, I would like to have the channel binding check implemented on NetExec MS SQL, the same way we have in SMB LDAP. Don't worry, I will explain everything it is and how it works later. But the thing is, I have an issue. I have someone that wants me to implement something, and so I wanted to take a look at how it will be, how easy it will be. Looking at what already exists, because when you're developing tools or techniques, the thing you should do at the beginning is to make sure that nobody already did that. If you don't do that, you will lose sometimes. So I strongly suggest you do the research first. Looking at what existed already, I saw the following PR on LDAP3, which is a Python library that is used to request the LDAP server on Windows. And this PR already adds what the guy was looking for. And I mean the channel binding token thing. So my logic was pretty basic. I have some guy that needs something. We have already done that. I'm just going to copy paste the code, and hopefully it will work. So you will see during the conference that I will go through different moods. At the beginning, I'm okay. I'm quite confident. It should be okay. I just have to copy paste some code, and we should be good. So the first thing we need to do if you want to work on Microsoft Active Directory and MS SQL is to first create an Active Directory lab, obviously, and you will have to install a database. The thing is, well, Microsoft is not known for bringing free stuff, but you can have multiple versions of the SQL Server. The three of them requires a license. The last one is the Express one, which you can install on your domain. And so when you have this, you will have a new panel that will allow you to configure the SQL Server. This is the following one on the upper of the slide. It gives you access to a few configurations, and the most important one, if you're doing blue team and sysadmin stuff, is the account that is running the database. So as you can see, I'm running the SQL Server with the administrator account of the domain. For clear reasons, you should never ever do that, because if the server was to be compromised, you would be able to execute commands as the administrator, which means you can compromise the domain. So this is a lab, we don't care, but just keep in mind never to do that. And then what we're going to do is we're going to use NetExec to see if he's first able to communicate with the database. Hopefully it is, so you can see that I am able to connect as the administrator account. We have the pwned label, which means that I am administrator on the database. And now what we're going to do is, and I will explain you again why later, we are going to enable TLS. The thing you need to know is that when you install a database, a MySQL database, first it's not using encryption at all. So you, or at least it doesn't enforce encryption. This means that there is a high probability that if you never touch that configuration panel, you will have a database talking in clear text on the network. And so you will have credentials going through it, and so, well, not a good thing. At this point, we're going to force the encryption. And if we launch netexec a new time, well, hanging. We have nothing. Netexec is not able to communicate with the database. And so that's me 1 hour into the project, feeling like, I thought it would be easy, but I'm realizing that if the basic tool do not work, I might end up being in trouble. So let's go back to defaults. The reason why MS SQL databases are vulnerable, well, the reason why we need to integrate channel binding token is because by default, MS SQL database is vulnerable to what is called NTLM relay authentication attack. If you're not that much into the Windows world, you may not know, but there are mostly two protocols that you can use to authenticate on an Active Directory. The first one is called the NTLM. This is the one we're going to take a look at. And the second one is called Kerberos. This is the most secured one, but it's not enforced. You're not forced to use Kerberos. You can use NTLM to authenticate in most environments. And if we take a look at what NTLM authentication looks like, we can see that it's basically 3 messages. The first one is called the NTLM SSP negotiate. It's basically, hey, server, I'm Deft, I want to authenticate to you. The server receives the packets. It will give you an answer, which is called the NTLM SSP challenge. And basically it says, okay, Deft, you can try, but first I want you to encrypt a specific string. So it's a random string. I want you to encrypt that string with your password. And so you, as a client, you will then send the NTLM SSP authentication packet, which basically says one more time, so here is the encrypted string with my password. You can see that I am Deft, so please authenticate me. This is very basic, and for that reason, it is vulnerable to the NTLM relay attack, which basically looks like this. The overall idea is that there is nothing in the NTLM authentication protocol that prevents an attacker from being in the man-in-the-middle position, forwarding every packet, and in the end, gaining access to the server you first wanted to authenticate as yourself. And so in the end, you end up having a shell on the target server while the legitimate user does not. And there are multiple ways you can get a man-in-the-middle position situation. Maybe you are aware of the LLMNR poisoning, this kind of stuff. RPS poisoning, well, basically any protocol that you can poison. So, sorry. I have a little live demo that mostly it will allow you to see what the problem is. On the upper left, you have the domain controller, which is the masterpiece of the domain. You have on the upper right the SQL database server that I installed, and on the lower part you have me as an attacker in man in the middle that is going to exploit the NTLM relay attack. So this is just a lab, but the idea is that I'm creating a listener waiting for authentication, and at the moment I get one, as you can see here, it will relay that authentication to the SQL server. And as you can see here, I get an access as the administrator account on the MS SQL database. Keep in mind that this exploit does not require any credential. That means that if you are able to set yourself as a man-in-the-middle position on a local domain, if someone talks to you, tries to authenticate to you, you will be able to grab the authentication and relay it everywhere on the domain, gaining access to a lot of services. As you may understand, this is really a critical thing. Most companies fall during internal assessment because of that vulnerability. So most of the time, what we do is ask them to disable NTLM. So the idea is that if there is no NTLM, they will authenticate via Kerberos, but it's much more harder to do than to say. And so Microsoft had no choice than to propose a solution, and that solution is called, well, actually there are two solutions. The first one is called packet signing. The idea is that when the legitimate user sends a packet to a target server, it generates a signature for that packet, saying, okay, this is the hash of the packet. If you do not receive the same hash, there is something going wrong, there is an attacker. And the second way to prevent the relay is to enable what is going to be interesting to us, the channel binding token. And as you can see, in order to set the channel binding token, we need two things in the configuration. The first thing is we need to force encryption, because you will see that channel binding token does not work on non-encrypted communications. It only works on TLS. And the second one is to activate the extended protection to set it to required. And so if you're looking for more information about channel binding token, you can take a look at what EPA is, so extended protection for authentication. Now, if we do the exploit one more time, you will see that at this time you get administrator failed. So the authentication that we relayed failed. And if we take a look at the logs of the MS SQL server, you will have the following error. So sorry, my server was in French at the time, but well, basically it says that the binding token for that client is missing or does not match the established TLS link. It is possible that the MS SQL service is under attack or that the client does not support extended protection. Closing the connection, the SSPI binding token sent by the client does not match. Well, of course, the client we are using, actually, the script we are using to relay the authentication does not support channel binding. And even if it did, considering there is a channel binding token, the authentication relay will not work. And I will explain you how in a few slides. There are a few information I need to give you before we go deep down into the project, the subject. This information relate to, well, all about TDS and Start TLS. You may expect a SQL service to talk in pure TCP packet, meaning that, well, it is going to send the data in a TCP packet. You receive the TCP packet, you read the packet, you send one, and so on and so on. But that's not actually how it looks. The MS SQL service, well, Microsoft, used what is called the TDS protocol. And basically, at the beginning of any communication to a MS SQL server, you will have what we call a TDS prelogin packet. This is what it looks like. So this is straight from InPacket. And if you take a look at the fields we have actually two that are interesting. The first one is the client version, basically what version of TDS I'm using, and if I support encryption, which is that field. Then, when the MS SQL server receives the response, it will answer with what is called the TDS packet, which is defined as the following. And as you can see, we have a few fields as well, but the most important one is the data, in which the actual data is fulfilled. And at this point, we did the pre-login. What we're going to do is to send the actual login. And that is what the structure looks like. So I'm sorry, it's a little bit small, but the idea is that we have much more information in it. For example, you can see that we have the username, the password, the server name, the database you want to connect to, and we have the SSPI, which is where the authentication material is going to be stored. If you take a look at the code of InPacket, of the client, of the MS SQL client from InPacket, you will see that the following login function is used, and we can see actually the packets we were talking about. So if you take a look at this, we can see that indeed there is a pre-login function that is called. And then, depending of whether the MS SQL service supports encryption, we have the if-else statement that is below. If you look at the code, you will realize that basically this code just creates a TLS context. It then allows any type of ciphers, and in the followings, it does a TLS uncheck and starts sending some data. This is odd because if you've never taken a look at what start TLS is, you may not know that behavior. But basically, what we're looking at is the start TLS protocol that you may have encountered if you are working on LDAP or SMTPs, for example. And basically, it allows a raw connection in clear text to switch to a more secured context using the start TLS and the TLS engine that is created in the following lines. So if you want to sum up, what's actually going on when authenticating and why it didn't work in the first place is because NetExec was not able to use that start TLS extension. And if we take a look, if you want to take a deeper look at how it works, you can see that first the client authenticates via a classic raw connection. Then the client and the server look if they both support start TLS. If so, they will create a TLS engine that will allow them ciphering and encrypting and decrypting data. And at the moment they agree with that TLS engine, they will be able to compute some data, send it to the TLS engine so that it encrypts it, send the data to the server decrypts it, digests the data, and the other way around. All right, so the reason why I'm explaining all of this about TLS, start TLS, is because channel binding is a security that cannot work on anything else, on anything that is not going through a TLS tunnel. Actually, when I did the first research, I didn't quite understand what it was, what the binding token was. So I did a small Brave lookup, and we have the following response, which says that a channel binding token is a security mechanism used to bind the authentication process to a specific secure communication channel. This is why we need TLS, because it doesn't work otherwise. And so basically, we understand that at some point, the channel binding token is used when you create a TLS tunnel with a server, and then you try to authenticate, in that case with NTLM, the NTLM authentication, but it could be with the Kerberos one. Still, we don't know how this token is computed, and we don't know in what reason it is able to protect you from relay attacks and anything else. So if you want to go deeper, you can take a look at the actual code of the pair I mentioned in the first place. This is where the token is created, and if we take a look at it, you can see a few things, among which we have the following. And so we deduce that the actual channel binding token is computed from the TLS peer certificate, so the certificate of the TLS of the LDAP server. This certificate is read, digested into a SHA-265 hash. Then we have what is called a channel binding structure, which is composed of 8 bytes of initiator address, 8 bytes of acceptor address, a raw byte string called TLS server endpoint, and the actual SHA-265 hash of the certificate of the server you want to connect to. Then the entire structure is digested into a MD5 hash, and we have the channel binding token. So I copy-pasted that code. I said, okay, if it works for LDAP, if computing the channel binding token for LDAP works, there is no reason it wouldn't work for my database, my SQL database, but it didn't work. So that's me 5 hours into the project, crying out loud because I thought it would take me like 5 hours to work, to make that work, but it does not. And the worst is, at this point, I have no reason, I don't know why the authentication I created does not work. And I cannot know because since I'm working on an encrypted channel, well, in Wireshark, there is nothing I can read. And I can tell you for sure that when you're working on network protocols, on in-packet and that kind of stuff, the best thing the thing you really want to have is to have a clear text communications that you can compile both authentication from a legitimate tool and the one you're writing code on. So that's me 10 hours into the project, realizing that it doesn't work how I suppose it would, and most of all, I cannot understand the reason why it doesn't work. So you may have guessed it, but the first thing we are going to need to do to keep working on that project is to downgrade the TLS security of the server we are working on. And there are two things we need to do. First, we need to get a certificate for that. We need to get a certificate, and it's private key. So that's quite easy. You can request a certificate using the ADCS service. And then you will be able to configure the SQL server to rely on it, to use it. And why do we do that? Because, well, we need to have the private key of that certificate to be able to decrypt what's going through the tunnels and be able to see where our authentication failed. And then, well, as I told you, I'm exporting the private key and then feeding it to Wireshark, which means that as of now, it will be able to decrypt TLS communication, which will allow me saying what's going wrong. But there is another thing we need to take care of, and that's a general tip I can give you if you're working on Windows. Basically, Windows, well, basically TLS, there are multiple versions of TLS, TLS 1.1, 1.2, 1.3, and TLS 1.3 doesn't support RSA. The thing is, this is the one we need because RSA really uses that private key to encrypt and decrypt things. Well, both the private and public key, but it relies on the keys to encrypt and decrypt stuff, and TLS 1.3 doesn't work like that. TLS 1.3 relies on elliptic curves, which means that you need both the private keys and you also need the nonces that are used to encrypt and decrypt stuff. And we don't want that. What we want is the simple private public key encryption and decryption. How you can do that? Well, you can go to the local group policy editor of the server you're working on, and you can say, okay, well, if you want to talk in TLS 1.3, what I'm going to do is tell you to only work with these SSL ciphers, and these SSL ciphers are only RSA based. So you will be able to force your computer or your server communicating with that encryption. And finally, at some point, you are able to have a clear text communication of your authentication. So as you can see, we do have the NTLM SSP thing that I mentioned before, and we can see multiple things such as the domain name of the person who is authenticating, the username, and there are also a few information such as the place to which I am authenticating. So that's me 1 week into the project, having a little bit more faith in me, thinking, okay, now I can take a look at what's going wrong, so it should be easier. And now comes the part where we need to implement the actual channel binding thing. And keep in mind, I still did not clearly explain how it works, so you may not know already, but I'm going to, don't worry. The thing we need to know, to begin with, is what the NTLM authentication looks like actually. And well, as you can see on Wireshark, this is just an hexadecimal string, sorry. And if it is an hexadecimal string, you can extract it and feed it to a parser. And this is what I did. Here, you can see all the fields that are used in NTLM authentication message 3, so the NTLM authenticate. And we can see a lot of things. First of all, we can see, as I told you, the domain name, the domain on which the user authenticates, the username, the computer from where he authenticates, and we also have a few challenges, as well as what is called the AV peers. And looking closer, we can see 2 things. First, there is the MS AV target name that points to the database we want to communicate, to connect to, MS SQL SVC. So it's called IDCS, but that's the actual MS SQL server. And we have the almighty AV channel binding, which is what, as I told you, MD5 hash. So, to sum up a little bit, when it comes to channel binding, the overall idea, at least on LDAPs, you will see later that it's not always the case. When you authenticate to LDAP, the first thing you need to do is to create a TLS tunnel. When we have created that tunnel, we're going to say, hey man, I want to authenticate to you, and I'm deft. The server then says, okay, you can try to authenticate. So first you need to encrypt a specific string with your password. And if you can do that, I'll give you access. And at that moment, your client will encrypt the string with your password, but it will also include the hash of the certificate of the server you want to connect to. And if you do so, you will have at some point a signature that cannot be removed by any attacker, and so the NTLM relay attack cannot work. Because at the moment you are embedding the hash of the server, of the certificate of the server you want to authenticate to, if you modify that value in the packet and try to relay to any other target, it will fail. Because the server will say, oh, okay, that's really you, but if I take a look at the channel binding token, I can see that this does not look like my certificate. And so mostly you're trying to fuck with me, you know? And so, I told you that it works like that on LDAPs. The thing is, if you parse 2 different authentication with the tool I just showed you, you will realize that we have first time that value for the channel binding thing, And at that moment, another time, you have another value. So the SQL server is, there are two things or three things. Either I'm dumb, which is actually the case. Either there is something I don't understand, which is also the case, or the SQL server is, oh, well, fucking with me again. The thing is, there are not just one type, one method you can compute a channel binding thing, a channel binding token, sorry. There are actually three ways you can compute it. The first way is the one which just saw with LDAP-S. You take the certificate of the server, you hash the structure, you embed that hash into the NTLM authenticate response. That's the easiest one, the one you will see most of the time. Then there is the TLS unique, and I'm going to spoil you. This is the one that is used to protect MS SQL databases. This one is not based on the certificate of the server you want to authenticate to. It is based on a particular field that is called the finished field, which is the last piece of data that is created during the TLS handshake between the client and the server. And so we understand now why the reason why, sorry, we have two different values. This is because we are not hashing the same certificate. We are hashing different values at the same. So that explains why we didn't have the same values at this, all the time. And the last one is called TLS exporter. So I actually had to take a look at what it is on internet. I fed that into Brave. It gave me the following answer, which talks about PRF, so pseudo-random functions. He told things about hashkdf. To be honest, I didn't quite understand what it is. So that's me. And the thing is, MS SQL does not support it. At the moment, there are only a few protocols that support it, so let's say we didn't see that. Maybe one day I'll come back at GreHack to tell you what this is, but for the moment, let's say we don't care. And so here is the final computing. Before I showed you the code that I copy-pasted, if you take a look at this one, which is the actual working code, it's pretty much the same thing. We have a channel binding structure, which starts with 8 null bytes, which is the initiator address, then followed by 8 null bytes of acceptor address. We have the byte string, which is not TLS server endpoint now, but TLS unique. And we have the computed value, which is the finished, based on the finished message of the TLS handshake. And if you want to take a look at what the channel binding structure actually looks like before being hashed into MD5, that looks like this. But in the end, what you will get is still MD5 hash. And now, we should expect that everything is okay, but before showing you the actual proof of concept of it working, there is another thing I need to tell you about, which is that we saw that MS SQL supports start TLS. And so we need to extend clients so that they both support start TLS and also unencrypted communications. This was most of the work that I had to do, because the thing is, we need to create like a function that is able to detect whether we are talking in TLS encrypted or in plain text. And depending of that, we need to create the TLS engine that is going to be used to encrypt and decrypt. And we'll have to send the data the correct way. So I created, if you want to take a look at the code, you just have to go to Impacket, you look for tds.py, and you will see the exact same functions. If you want to send data to a MS SQL database, you will have to compute the data, send it to the sendTDS function, which is going to send it to the socket sendAll function. Based on whether we're talking in TLS or not, it will dispatch the function so that it is encrypted or not. Then the data is sent to the MS SQL server. The server computes the response, sends it to you. It arrives in the socket regv function, which is going to dispatch it depending on whether we need to decrypt or not the data. And you will actually receive the TDS packet. And finally, as you can see, I enabled the channel binding token option here. I also added some debug messages, and you can see that we computed the TLS unique channel binding token, as well as the MIC, which is another protection. And via the MS SQL client, we actually do have access as the administrator account on the database. So that's me 3 weeks into the project, and Now, I don't know for what reason, I published the blog post and then I moved on to another subject of research, forgetting that my initial goal was to answer to an issue on the NetExec project. And so I came back an hour, no, a week later, realizing that I did not match that work into the framework itself. So I did it. And as of now, so the PR is still being tested, but it's working on my NetExec version, which is going to be merged at some point. And so you will be able, using that tool, to connect to even the most secured hardened, MS SQL databases during your internal assessments. And that's me a month into the project. A little bit happier, but it was really a pain. So to sum up, so that you just keep the most important information. By default, MS SQL databases are vulnerable to what is called NTLM relay attack. To prevent that, Microsoft, well, I'm talking about MS SQL, but other protocols are also vulnerable to that. SMB, LDAP, SMTPs, basically all the protocols. To prevent that, Microsoft developed not just one, but two techniques. The first one is communication signing, and the second one is the channel binding token that is used to bind an authentication to a TNS tunnel. To work, a TNS tunnel is then mandatory. CBT cannot work on an unencrypted tunnel since we need something that is computed inside the TLS engine to make sure we're not trying to attack the database. Channel binding token are built using three methods. The first one is the TLS server endpoint, which is used by the LDAPS service on Windows. This one is computed via the SHA-265 hash of the certificate. Then we have the TLS unique value, which is computed via the the SHA-265 of the TLS finished message. And then we have the TLS exporter. I told you we will take a look at it another year. Computing the value, the CBT value, and adding it to the last authentication message of the NTLM authentication, we can get an access to the database and to even the most hardened MS SQL database. So, first of all, I hope you learned a few things. It made the channel binding thing and extended protection a little bit clearer. These are subjects that are not well known, so yeah, I hope it enlightened you. I just wanted to have a, well, I'm a little bit late, but I just wanted to say that the reason I wanted to present that subject is because I wanted to give you a feedback of the journey of what it is to collaborate on open source projects. As I told you, I'm working on NetExec, I'm working on Impacket. These are tools that are used on a daily basis during internal assessments. And it's important to me to contribute to them to make the cyber community and the offensive community a little bit, to give them more tooling and stuff. But this is really time consuming. To give you an example, just computing this thing took me about a month of work, but still, I believe it's important to take a look at it. And if you are ever interested in doing research or development of tooling on public projects, you shouldn't hesitate. Just give it a try. You will see that the community is really wholesome. And even if you do mistakes, I can tell you a story of me, fake news. I fake news 29,000 people on Twitter sending false information 6 months ago. Nobody cares anymore. Mistake is human, you know. So yeah, basically, if you're interested in doing research or development on public projects, just give it a try. Do it, build things, and you realize it's a pretty cool experience, even though sometimes it can be a nightmare and take you a month of your life. If you have questions, let me know. If you want to talk about it later, you can send me a mail, you can DM me on Twitter, on Discord. The blog post that explains this entire thing is already available. The slides will be as well. And if you want to, yeah, just talk in the conference, don't hesitate.
Merci. Thank you, Aurélien. We have time for one question.
Just wanted to know, are you sure, like in your first step, you said that you tried the MS SQL Express because it was like the free one,
Yeah.
but maybe in the other MS SQL like proposition, maybe there is other security systems that you couldn't use because you didn't have these tools.
No. All SQL, all services from Microsoft do have the same security because they are aware of people not respecting licenses. Let's be honest, we all have this in our internal networks. So they provide the same securities. What I've shown you, the chain binding thing, is one you will have on both licensed versions and unlicensed one. What matters is whether or not you're activating it. Keep in mind also that if you want to activate that option on your systems, on your local, well, on your enterprise domain, it could be not, there is a probability that the clients will not be able to support that, and if it does not support that, you will not be able to connect to the server anymore. So you will have to do it progressively, just enable it on one server, then a second one, and third one, and so on. But you have the same securities independent of the license.
Okay, thank you again, Aurélien.
Ça c'est pour toi.
Oui, je tremble beaucoup de base. Pas le stress. Ça s'appelle des tremblements essentiels. Voilà, c'est bon.
Okay, so there's going to be last talk of the session with Hugo, who is going to be giving us another dive, but into the CI/CD world.
Okay, perfect. Do you hear me? Yeah. Okay, good. So first, welcome to this presentation from YAML to root, CI/CD pipelines, attack and countermeasures. My name is Hugo, or Spirits. I'm a senior pen tester in Deloitte, France, private teacher in C++ for more than 8 years now. Also, I do DevOps programming, pen tests. I'm also the one maintaining and deploying the pen testing and retrieving infrastructure that we use during our tests. More than 6 years in cybersecurity. Here, as you can see, there is another person, Luc Marie. He's not here today, but I would like to give him a special thanks because he helped me do the presentation. So thank you, Luc Marie. Before we start, let's give just a small context, a small presentation of what is pipelines and what is the DevOps, DevSecOps, etc. So DevOps, I think you all know what it is, and DevSecOps is the same thing with integrated cybersecurity inside all the steps. So first, in terms of DevOps, you know, it's everywhere. Every industries will have DevOps team in order to deploy software, infrastructures in their enterprise or in their networks, and it will rely on a set of tools combining codes and specific infrastructure. Here we'll have the first difference between DevOps and the pipelines, where the DevOps will give you the culture for collaboration, so how you will work with your teammates, with all the developers, all the testers, etc. How do you manage your plan? And sometimes what you will need is something in order to deploy your code or do a specific action just by using one click, or if you are developing a new software, having the possibility by one click to deploy all your code to infrastructure or to a new artifact in order to share the new version of the software. So the idea is, that's why they created the CI/CD pipelines to make all the integration, testing, and deployment actions automatic. At the beginning, when those pipelines were created, they were only available for developers or administrators, but with time and currently, those are open to a lot more people. So for instance, there are a lot of companies that will give access to specific repositories to their commercial or marketing team in order to deploy easily a website. For instance, you just have to type the name of the website and it will automatically deploy it. You will also have, for instance, for HR, if they want to create a new user account, they will just have to put the name, the address mail, etc., and it will automatically do a lot of actions using those pipelines in order to deploy the new user into the industry. And so we begin with developers and administrators with a specific knowledge, some expertise on development, on cybersecurity, on those pipelines, on cloud. And then those pipelines are now open to a lot more people with different level of maturity on the subject. So it will open your network and your infrastructure, your cloud infrastructure, to a lot more people with different level of knowledge on the security. And that's why I decided to present this subject, where what we will see here is the scenarios, the most viewed scenarios as we saw during our audits on the CI/CD pipelines. And what we will look is on the pipelines used from the code to execution. For instance, the infrastructure as code, when you have Terraform. First, just to give you a little bit more information about the pipelines, here is a classical workflow for Azure DevOps. So Azure DevOps is by Microsoft. It's something a little bit like a GitHub. And what you have here is a classic workflow where you begin with the board in order to define the plan, the developers that will create the code, and then you put it in the repository, exactly like GitHub. And you will have the first type of pipeline, the CI pipeline, where you will have the code tested, published, and also if you want to deploy new artifacts, for instance, if you are developing softwares, the creation of artifacts. Then you will have the CD pipeline, responsible for the deployment, so they will take the code, or they will take the artifacts, and they will deploy it inside your network, inside the infrastructure, and all the environments. There are two kinds of pipelines in the CI/CD platforms. The first one are the platform-hosted pipelines. So those one, like Microsoft hosted pipeline, GitHub Actions, are agents that are given by the platform. Usually you will have like 16 hours free or a few days free in order to use it, even if you are a company. And those one are not hosted inside your infrastructure, but you can use them as you want. You don't have to maintain it. You just have to use it and to deploy your code. But you have to open your infrastructure to an external source. The second one is self-hosted pipelines. Those one are directly hosted inside your network, inside your infrastructure. So you have to maintain it, to add all the new versions, to configure it. And the good thing here will be that they are already inside your network. So in terms of network accesses, you don't have to open your network to the outside, but it's a little bit more costly. And usually what we'll have is for cost optimization, the companies will use one runner, so one server with a pipeline inside for multiple environments and multiple projects. In this case, if someone is able to pawn, for instance, one project in dev environments, he will be able to access the production environment of another projects or another subnets. And also, as we saw, that usually those pipelines, so the configuration and the security of those pipelines are managed by different teams that's the one doing the projects. So in this case, the one doing the project don't have a view on the cybersecurity and the security maturity in order to use those ones. Now, before starting with the offensive parts, I will just give you some information. What you will see is, so there are real-world attack scenarios that we encountered during our audits. We will use Azure DevOps as a primary example, but all those attacks and attack scenarios are applicable to other platforms, so GitHub, Bitbucket, AWS if you use Code Catalyst, for instance. Only the last scenario will only be for Azure DevOps, but all of them works everywhere. Also, in terms of access, we will assume that we have a classic contributor access. So the idea is they give you the repository, and you are able to modify the repository and to launch a pipeline. But we'll see it a little bit in detail after. And in terms of scenario, what we will have is a focus on weaknesses in the YAML configuration file. So the YAML configuration file is the file that is used in order to describe the steps that the pipeline must go through. And also Terraform files. So I don't know if you know Terraform. It's a script language that will allow you to define an infrastructure like a VM, a subnet, etc., and it will deploy it. And for each of those scenarios, we'll have different contexts, different prerequisites, and also different security restrictions that will be put in place. Lastly, the last terminology for those that are not used to Terraform, we'll need it a little bit after. Some keywords. The first one, providers. Providers are like packages in Python, and that some libraries that you will use in order to connect to specific infrastructure, external sources. For instance, if you want to create a VM on Azure, you will need Azure RM provider. There is one for AWS, for F5 BigIP, for instance. The second one, resources. Resources are the assets that you want to create. So a VM, a virtual network, a subnet, a network security rule, etc. Data sources are a function that will allow you to retrieve data about existing resources. For instance, you know the name of a subnet and you want to know the IP ranges. So you can use a data source, give the name, and it will retrieve the IP ranges. Provisioners are actions that you will use on existing resource or when you create a resource. So you will create a VM and you want, when the VM will be deployed, you want a specific code to run inside this VM. You will use provisioners. And finally, modules. Modules are just a package in Python. If you want to, let's say you have a piece of code that you like, you want to reuse it, you will create a module. And like this, you can recall it every time. Now, the scenario. For each scenario, what you will have is using which file, so YAML configuration in this case, and also what kind of attack scenario we'll use, and also you will have here what you need. So all the user rights that you see here are, even the one in red, are the ones that you have by default if you have a contributor access on Azure DevOps or on GitHub. But just for all the scenarios, I will put in green only the ones that you need for this attack. So here, in order to perform a RCE with YAML configuration file using the script tags, you will need write access to the repository, write access to the YAML file, the possibility to modify the build configuration, we'll see it a little bit after, and the ability to trigger a pipeline automatically or by clicking on the pipeline. So what we have here is, let's imagine we have a classic project with a YAML file and Terraform file that will deploy a VM, the classic schema that you can find. We go on the pipeline, we launch it, and we can see it deploys a VM. Perfect. Now, let's say there is no security on this pipeline. You can do what you want. You just have to add here, you will have a wget in order to obtain Nabu. Nabu is exactly like Nmap. And you have also a code that will deploy a reverse shell. So you use a remote server. Just wait a little bit. Let's move on a little bit. Sorry. And now, just launch, and now you have access to the pipeline, and you have a reverse shell on the pipeline, just by using like 4 lines of code. This one, you may think that it's quite easy. We saw it a lot in companies, but this one is a less secure example where you have access to the YAML file and there is no restrictions, but it happens. Also, something important here, we use the wget in order to access something on internet, and we use bash in order to access also to use a reverse shell. Because we are using Microsoft hosted pipeline here, so we have access to internet. This is by default on the Microsoft hosted pipelines. If you don't have access to internet, you can still do echo or cat of etc shadow. You can do all the actions, so run code without using internet, it works also. But if you have outbound access, you can do your reverse shell. Second case here is, let's say we had a new security, so we will add a blacklist of all dangerous tags. There are lots, there are scripts, there is another one called bash, and another one called command, there are a lot of them. What we can do, we can still work with this, what we can do is we will use official task. So here you will have Azure CLI. Azure CLI, it's an official task, like a function that is provided by Microsoft. There are a lot of them, like one for GitHub, for AWS also. And this task will use the service connection. So the service connection in Azure is when you are on the Azure cloud and you want to create a service principal, so a service account for your pipeline, you will take the service account and you will put it inside a service connection. And this service connection will hold the credentials of the service account for the pipeline. So the pipeline will use the service connection in order to connect. So you just need the name of the service connection. This is not a secret. This is just the name of the service. And once you have it, you can deploy directly your code inside. This is a built-in task. So here what we have is an echo. Here what we have is, because we are using the service connection, we have access to the cloud infrastructure behind. So using this task, you have the same rights as the pipeline. So here we will create a new service principal on Azure, and here we will display it. So using official task, you are able to deploy code on the pipeline, but using this one, you are also able to directly access Azure behind. Now, let's change and let's say, okay, now we don't have access to YAML anymore. We only have access to Terraform. On this one, there are a lot of things to do also. So here you can say, don't have access to YAML. What we will do this time is we will use what we saw, so the providers and also the provisioners. So providers, we go on provider.tf and we add external, which is an official provider. We can then go to the main.tf file where you define all your infrastructure. And here, what we'll have is, sorry, it's a little bit blurry, but you will have a data source called external, which is provided by the provider external. And this data source allows you to run code directly on the pipeline. So we will use it. And also below what we have is local exec, which is a provisioner. And we use, I don't know if you can see, but we use a resource called null resource. This one is an empty resource just in order to use a provisioner in it, but it will do nothing on the infrastructure. And on this one, you just have, oh, sorry. We just had those two lines. Why don't I have the video on this one? Okay, perfect. So, yeah. With only those, we can run it. And then at the end, you can see we're able to execute the code on the local provisioner, so local exec, and also we're able to execute the code on the pipeline using external. Now, let's add a new security again. Let's say we blacklist all dangerous providers. So there is external, there is another one called local. Local will allow you to use a function called local file. Local file allows you to create files and read files inside your pipeline. So let's say it's blacklisted. And also we'll blacklist all provisioners. So there are two local execs that we saw earlier. And another one, remote exec. And remote exec will ask for credentials. So usually we will use local exec. But let's say we will blacklist all of them. So now what we can do is create our custom provider. It's quite easy. The idea is you go inside the Terraform registry, the HashiCorp Terraform registry, which is official. You go inside, you just create an account, and there is a very good documentation saying, okay, if you want to create your custom provider and make it official, you can. So that's what I did. What I did is I made a fork of the external provider because it's on GitHub. And I modified it a little bit by saying, okay, no, your name will be tests. And also I want you to execute some codes if I put the keyword command. And then you just have to deploy it. Again, you just have to read the documentation inside HashiCorp registry. It's pretty complete, pretty easy. So what I did at the end is add a new provider called test from Spirit 91 test and use it as a data source test, command, who am I, and ID, and it works also. So like this, you're able to execute the pipeline even if the providers are blacklisted, because most of those restrictions are based on the string of the name of the function. So if external is blacklist, you can use another keywords as you want. I put test, but you can use every keyword and it will work. Just for your information, this provider, so Spirit 91 test, is still existing. So if you want to use it, do not hesitate. You just have to add it like this and to run the command like this. Finally, last scenario, let's say that you don't have root access to the repository, you don't have root access to the YAML file, to the Terraform file. You have the possibility to modify the build configuration, which is by default on a contributor access. And you have the possibility to create a service connection, again, by default on the contributor access, because the contributor account on Azure DevOps and on GitHub is member of endpoint creators by default, and endpoint creators have the right to create service connections. And finally, the ability to trigger a pipeline. So what we will do here is we can see that we don't have access to any files, which just can launch a pipeline. We go inside the pipeline, we try to edit it, and they will say, you don't have access to the YAML file, so you cannot modify it. However, in Azure DevOps, there is something called the classic editor, which is enabled by default and cannot be disabled. So what we will do is go inside the classic editor, say, okay, I don't want you to take the code from Azure DevOps this time. I want you to change and to take it from GitHub. So we switch, we go on GitHub, you create a public repo just with a main file, a few lines of code to do the reverse shell. You create your token. This is a view once token, remember it for the next parts. And you put the token, you just refresh the page. Because you can create a service connection, it will automatically create one using GitHub. So you save. And then you just have to launch the pipeline again. Here is our remote server. And now you have access to the pipeline without modifying any files inside the repository, just by using the configurations and the possibility that by default you can create a service connection. So PWD to see where you are, LS to see who you are, ID to see who you are. So this one will work. So here we saw a lot of attack scenarios that you can use in Ansible or in Terraform, the YAML file in Terraform. There are also a lot of other ways, a lot of other attacks, also using Ansible. But so we have the possibility to do a remote code execution. What can we do next? So first, what we can do is try to exfiltrate some secrets. So you have access to the pipeline. You will look at the pipeline to see if there are some secrets in the environment variables or in some files, and you will try to send it by using a curl to your remote server or to echo it. Issue on all the platforms, when you try to echo or to cut a password or a secret, it will mask it with stars. So the idea here is that base 64 of a secret for the CI/CD platform is not a secret. So one tip, if you encode a secret on base 64, you can display it. It will not be masked. So you can display it, you can send it, you can display it directly on the console and copy it and then decode it. Second one, you can use the privileges of the pipeline in order to access other repositories. As we said, sometimes those pipelines are shared between multiple environments or multiple projects. Or you can try to expand it and go inside the cloud resources, as we saw with the Azure CLI task that will allow you to go directly on Azure. And finally, you can also try some lateral movement. So as we saw, we tried to wget Nabu, which is the same thing as Nmap. You can use it in order to do some network scan using the pipeline, or try to access other projects or other clients like a competitor that are reachable from the same runners. In terms of exfiltration of secrets, I told you, try to remember the GitHub token, which is a view once token. The view once token are the secrets that we'll create. It will be displayed only once, and you can copy it. And then once you copy it, even the administrators cannot retrieve it after. So you have GitHub, when you try to generate a token, that will be only displayed once. You will have also, if you create a service principal on Azure, they will display the password only one time. You copy it, and then you cannot retrieve it. But we found a way in order to access it, so it's not really a view one secret. We'll saw it a little bit after. Something that we saw also, that because those secrets are normally accessible only once, available only once, teams and security teams used to put too much trust into them and into the integrated functionalities of the CI/CD platform. So, as I mentioned, the service connection in Azure DevOps, you will put the credentials of the service principal, and then you just have to use the name of this service connection. So we'll say, okay, it's secure because it's directly inside the backbone of Azure. I don't have to use it. Perfect. Unfortunately, it's not really. So because a lot of people think they are really secure, they will tend to give a little bit too much permissions on those pipelines. And then if someone is able to access those secrets, they can reuse it and directly access the infrastructure behind. So that's what I did here is, sorry. I saw that for this task, it was using AZ login. And by doing some research, I thought that AZ login was a node. It was coded in Node. So it's, you can find the documentation on GitHub. And what I did is, OK, so it's coded in Node, perfect. But all those secrets are injected inside the pipeline because it's only viewed once. You can store it, but how those Azure DevOps or GitHub retrieve those secrets after? Or are they able to inject it inside the task? Because in the Azure CLI, we only put the name of the subscription. So how are they able from the name to retrieve the secrets? So what I did is a wrapper of AZ login saying, OK, if you type AZ, you will go inside my AZ. You will display everything that you have every time you use login. So you will display all the flags. You will send it to me and put it as base 64. And then you will run the original AZ login. So that's what I did. Let's do a little bit quicker on this one. So I run the pipeline with the task AZ login also, Azure CLI also. And here we can see I'm able to retrieve here. So minus U, this is a username, minus password. I have the password here of the service account, which is normally viewed only once and which is not accessible even for administrators. Like this, I can retrieve it and reuse it after. It works also for federated identities. So if you want to create specific token and not use password, it will work. So what I did after is put it in base 64 in order to retrieve it. What I did after is, OK, so we have access to Azure login. It works. So I think it will work on AWS login if you use this task. But are we able to retrieve all the credentials every time? The answer is yes. What I saw is every time you are using a task, so on Azure DevOps, on GitHub, on AWS Code Catalyst, it will also it will inject the environment variables inside this task in order to initiate the task, and then it will clean it before giving access to the user in order to use this task. So the idea here is we try to find which version of Node is used and what is this path, the path of the node. What I saw is that for all the platforms, they are not using a built-in version in /user/bin. What they are using is a cache version that they will download and put in the same folder as the task when we ask for a task. So what I did is try to find this this node version and override it. So I overrided the node version to do exactly the same thing. Okay, display me the environment variables and send it to me. Oops, sorry. Okay. So you just have to launch it. And then you have your small code that will decode the base 64. And what you have here is all the environment variable decoded. And here, the service principal key, which is an variable sent. And here also. And this one will work for Azure DevOps, for GitHub, for AWS, etc. It works for all of them. In terms of network, we tried also to see what can we reach using Microsoft hosted pipeline. Is there some limitations, some restrictions? So Microsoft is publishing every week a JSON file with all the public IPs that they are using. So inside, every time you are in Azure and you will ask for a public IP, your public IP will also be inside the IP ranges on this file. So those are all the public IPs that Azure have and can provide to the users. Also, here you have the public IPs of all the Azure assets from the backend infrastructure. What we did is run SSH and WinRM, so two protocols that are used on Ansible, on all those IPs that are allocated to public. And we did it using Nabu on AWS VM. So you have the results here. On Azure VM with also an IP assigned by Azure, and on Microsoft Hosted Pipeline. What we saw from these results is that we have almost 300,000 IPs that are open to the network and accessible from an Azure VM or Microsoft Hosted pipelines. And inside the whole, I think there are 47 million IPs. So between them, there are 300,000 SSH open. And we see that for AWS, only 68,000. The idea is, by this research, we think that the reason is, by default, you will have some trust relationship between the, so let's say the clients that are using these IP addresses and their infrastructure, and they will open it to everything in Azure, because one issue is every time you are using Microsoft Hosted Pipeline, you don't know exactly which IP they will use. And from the documentation, they will say, okay, we are using either one specific IP from a range called Azure DevOps, or one IP from the region of the Azure DevOps. So you don't have any way to know from where your Microsoft Hosted pipelines will take its IP. So usually companies, what they will do is they will open their network to everything in Azure, saying, okay, by default it's secure. But if you use an IP, if you ask an IP to Azure on a VM, or if you use Microsoft Hosted Pipeline, which are free, again, you can access it and you can SSH it or WinRM it. And you can see also that between those 47 million IPs, 70,000 are open to the full network, because here we are on AWS. So either they are open to full network, or either they are allowing only AWS. We don't know, but yeah. I tried also with GCP, but after 1 hour, I was banned, saying, oh, you are trying to scan third parties, and it's not allowed. They told me I can call them in order to have access to my organization back, but I say no. Quickly also, sorry for the time. Here, I said that I scan using Azure VMs and Microsoft Hosted Pipelines. The thing is, by default, Microsoft Hosted Pipeline doesn't authorize scans. You will be blocked. So here we have two projects. One that will deploy Nabu and launch it like this on the pipeline. And also one that will do a reverse shell and deploy Nabu in the same thing and launch it. And the last one we'll see. So first, we tried Nabu on the pipeline. We have a timeout because you don't have the access. There are restrictions on the user shell. Next, we'll do the same thing, but this time we'll create the reverse shell. We launch a pipeline. We launch Nabu again. We wait a little bit. Timeout again, because you are still in the user shell. The idea is, here what you will do is, because the console in Azure DevOps, GitHub are not interactive, you cannot do a sudo-su. So you put the PTY in order to do interactive console, you launch it, and now you're able to do sudo-su to become root and to access the root shell. And from this, you bypass all the network restrictions from Microsoft and from the Microsoft Hosted Pipeline, and you can launch your Nabu, so you can scan anything and it will work. Finally, in terms of the defensive part, as you can see, there are a lot of things you can do in order to block this. So from the access is a secret, isolation of the network, hardening, etc. The thing is, it's impossible to put all of them because it will really depend on how you use your pipelines and how you use your infrastructures. So the idea is every time you will deploy a pipeline, you will need to, let's say, audit it, do an audit and find which security you can put without affecting the accesses, without affecting all the actions that you want to do. Usually what you will try is avoid root accesses, of course. And one good thing is to use short-lived pipelines. So pipelines that would run on Docker like this, even if someone is able to access it, it will be destroyed after a few times. And also in terms of audits, if an auditor comes to you and say, okay, I will audit your pipeline, and they have checklists, not a good auditor, because again, you cannot put all of them inside your pipeline. You can, but it will be very restricted, and in terms of user experience, in terms of administration, maintenance, it will be hell. So usually, even for the audits and for the hardening, there is no universal solution. It's more based on how you will work, but those are all the things you can do. Finally, the key takeaways. Currently, during our tests on the CI/CD pipelines, we have 100% success rate, and usually we are able to achieve it in 1 to 5 days. It's not to say we are the best at all, it's just to say that currently, they are not mature. So it's pretty easy, as you saw the one where I just put a few lines of code, the first scenario, I saw it a lot of time. So in terms of CI/CD, usually companies are not mature at all. Second, most of the agents run as administrator or root. Here we saw example with Linux pipelines, but it works also with Microsoft. And most of them run as root, so once you are able to launch code, and it's easy, you have access to the pipeline and you can do what you want. Good thing is the rise of Docker, so now more and more we can see that they are using Docker every time they are launching a pipeline, so even if you have access to you are able to launch code, you will be restricted to a specific container, so at least that's a good thing. In terms of segmentation also, it's often poorly implemented. For instance, I was able during audits to find that I had access to a pipeline, and from the pipeline, I run Nabu on the same network of the pipeline, and I was able to access a domain controller using this, because the pipeline was in the same subnet as the domain controller of all the company, the 2 domain controllers of the company. So put them in a specific network segmentation like this. If someone is able to access it, they cannot lateralize to something else. And finally, the lack of effective monitoring. Usually when you are able to execute code on the pipeline, you are able to do what you want because there is no monitoring or a very few monitoring actions. So all your attack will go undetected. For instance, the best that I saw in a company on this was on HashiCorp. So in order to, a little bit like Azure DevOps. And on HashiCorp, the security was, you will have a pop-up saying, okay, on your code you are trying to run, it was external with the command, who am I? It's dangerous, do you want to execute it? Yes, and it worked. So it was, the only security was just a pop-up saying, it's dangerous, do you want to do it? Yes, okay. And there was no log after, just a warning. And here are all the references that I used for this presentation. And thank you very much. And if you have any questions.
Merci Hugo, thank you. Time for one question, then we'll make a break. That might not be the best incentive for question, saying that, but okay, so thank you again, Hugo. We're going to make a break and we'll be resuming at 4:20. There is still slot available if you want to submit a ramp. send your slides deck at grehack.fr. So we resume at 4:20.
Qui est-ce qui les reçoit, les rôles? Oui, je laisse sur... Alec Knight. Arthur, il est dehors, il doit être en train de les récupérer. Pourquoi?
Hello, everyone. Thank you for being here. Today, I'll present Sharker, a tool I created during this short talk. But first, let me introduce myself. I am Pierre Milioni. I'm a pen tester at Synactive since 2020, and I am now focused mostly on red team engagements. Speaking of which, we've made an observation. Basically, we often ended up with really large packet captures during these type of assessments, and we only had a short amount of time to analyze them, so we often ended up missing valuable data from these captures. So we had to figure out a way to avoid this issue. But first, how do we actually get network captures? As Aurélien said in another presentation, it's quite likely that you can end up in a man-in-the-middle position, either through physical intrusion, as we saw this morning, I think, where you manage to plant a malicious device between the internal network and a workstation. That way, you are able to sniff the traffic going to the internal network. You can also abuse protocols such as ARP, HSRP, or DHCP, pretending to be the router, and so on. That way, you retrieve a lot of traffic. Then you can abuse name resolution protocols, especially in the Windows environments where they often rely on broadcast packets. So that way you can usurp the identity of a specific server, thus retrieving some traffic. And then, less likely to happen, but still, you can create a fake Wi-Fi network. And if you manage to actually make a user connect to that Wi-Fi, you can provide them with a gateway, and then you can sniff the traffic. Other possible scenario, you manage to compromise a network equipment. So during your intrusion, you end up on a router, either through features of this router or because you have a shell on the machine, you can start sniffing traffic. Or that happened if you browse the file system of a server of administrator workstation, you may end up on pickup captures. So all these things may lead to the compromise of sensitive data. So yeah, why? Why would we find sensitive data? Because everything should be encrypted, right? Well, not really. There are several protocols widely used that remain insecure. In internal network, especially, we find lots of legacy protocols still in use. Quick example, NTLM and Kerberos, especially NTLM, and Kerberos when there isn't Kerberos armoring enforced, could lead to the compromise of credentials. You can also identify authenticated HTTP proxies that could lead to the compromise of credentials. You can also find files transiting through an encrypted SMB. So these things can be retrieved by a simple packet capture. And then you can improve your knowledge about the internal network through the discoveries protocols such as ARP, DHCP, and DNS. So now the tool, Sharker. The idea behind this tool is to have something simple, reliable, and reasonably fast to parse these PCAPs. And we did not find these three things in the already existing ecosystem. Basically, some example, pcreds, probably the most widely known, is quite difficult to extend since it relies on SCAPI and manual parsing of packets. It's quite tedious to actually implement new filters. There is CredSlayer, which is quite similar to Sharker, as we'll see. However, it remains slow on larger pickups, so not really usable in that case. And then there are other tools, such as Network Miner. However, it's designed to run on Windows, so it's quite complex to use it on Linux. And there are multiple others that are either too complex, provide lots of features that we don't really need, or are shipped with lots of dependencies, things that we don't really want when we are treating sensitive data. Now, the design of Sharker. Basically, we used the T-Shark tool So T-Shark is the CLI of Wireshark for packet parsing. Why T-Shark? Well, Wireshark was released in July 1998, so I was basically 1 year old at that point. So I figured they would have done the parsing way better than I would ever do. So let's just reuse their work. And they already made tons of dissectors. Basically, if you go on their GitHub page in the dissectors part, there are more than 1,000 files, so you cannot even display all the files there. So yeah, let's just reuse them, their work. So Sharker, as we've seen in another presentation, I was like, okay, it's going to take me an hour or two and I'll be done. This will be a simple tool. So it started as a simple bash script. And then I started to run T-Shark once to retrieve the user agents, and then run it a second time to retrieve the Kerberos hashes. But I cannot compute the hashes directly with T-Shark, so I have to do some sed shenanigans to end up with a proper hash, and so on and so on. And in the end, it was really complex doing it that way, and super slow, since we had to parse the capture each time for each thing that we want to extract. So I started again, switched to Python. Why Python? Because it's easy to understand, easy to develop. I wanted people to just understand the code if they read it. That way, we run T-Shark only once, so we do only a single pass. So it starts to complexify a little bit because we have to select the packets correctly. And we leverage the JSON output of T-Shark. So the dash T JSON that yields JSON representation of all the packets that matches our selection. In particular, the dash capital Y allows us to filter the packets that will be generated in JSON afterwards. So this allows to really early on discard packets that are not valuable, which allows us to gain a lot of time during the parsing operations. So this is an example of an SMB2 exchange and within an NTLM authentication. So it's really easy to retrieve all the different values, and the keys are self-explanatory. So still design, I wanted it to go really fast, so I started with a multiprocess app because I knew that threading would cause problem in Python. However, it remained complex and not that fast actually, because I was sharing the object, lots of objects through all the processes, which took time because of the serialization, deserialization, and so on. So it was not that smart actually. So I switched to a multi-threaded app. I really wanted to go fast, so I needed more threads. However, it remains still complex due to the different queues, and not that fast, probably due to the global interpreter lock. So yeah, I finally switched to a solution I should have started with, meaning a single process and almost single-threaded app. It yielded the best results among all the solutions, simply because all the hard work is done by T-Shark. It's T-Shark that parses the raw packets and transforms them in JSON. We only are doing quick computation on keys in a JSON, so it goes fast. It's not really CPU bound. So I should have started with that and kept it simple. Now, when we get the JSON representation of a packet, what could we do? Well, Sharker implements filters as Python classes. So this is a simple case. We want to extract the DNS requests performed in the capture. So this is the complete example that does that. Basically, you create a new Python module. You implement a new class, you create a new class, give it a name, a description, some categories so that the users will be able to filter on later. The heavy keywords prevents Sharker running the filter by default. So this can, as we'll see later, affect the parsing time a lot. And then you specify a pickup filter attribute. So this is the attribute that allows T-Shark. so the one generating JSON output of packet, to early discard unwanted packets. So this is where you define the filter that defines valuable packets. And then you have the mandatory selectors that just allows Sharker to select what keys you want to export or display in the console. That's automatic. Now, a more complex example. If you want to extract the NTLM authentication hashes, you need something that stays along the whole parsing of the capture to save the NTLM challenges that are in the second NTLM authentication message. And then you implement a parser function. And in that parser function, you will check whether it is the second or third NTLM message. If it's the second, you'll store the challenge in the object variable defined in the init function. And if it's the third message, you just start generating the hash, select the proper challenge from the variable, and then you call the output function. Sharker will automatically either display it in the console or write it to file, or both, actually. Now, on to limitations. Basically, Sharker highly relies on T-Shark. So if T-Shark cannot parse a packet, Sharker won't be able to do anything about it. It's definitely not built for exhaustive analysis, meaning that if you really want to dig deep in a capture, you're better off using Wireshark manually. And if everything is encrypted, or like you're seeing only VPN traffic, obviously you won't be able to do anything about it. Quick example of what it looks like. So you just call Sharker. The -C option allows you to filter on categories what you want, what you don't want. -U to have unique output, and then specify the output, and you get all the hashes there. So obviously these values are placeholders. Now, some comparisons with the other tools. So 4 different captures taken from 4 different engagements. As you can see, for Sharker, pcreds, and credSlayer, the timings are for the whole parsing and analysis, while for T-Shark, it's only for the generation of the JSON output. So we compare pretty well to the others. And as you may notice, there is a huge gap between the 1 gigabyte capture and the 700 megabytes capture. 700 megabytes capture being that needs way longer time to parse. This is due to the fact that the 1 gigabyte capture only contains, contains lots of packets that are not useful, so we can discard them really, really early on and gain a lot of time. So that's why on the 1 gigabyte capture, we are really fast compared to the others. Yeah. Now, quickly, what do you do from there? Well, you can start brute forcing offline hashes that was generated. You can start relaying authentication, especially on MS SQL Server, unless there is a channel binding. Then you can start abusing protocols that you identified. You can improve your knowledge about the network. It's really up to your imagination at that point. Now, from the defensive point of view, what could we do about it? Well, it's quite complicated. Once the attackers are already in the LAN, try to eliminate legacy protocols as much as possible, enforce encryption when possible. Definitely use strong passwords that resist offline brute force attacks or directory wordless attacks, and try to move towards zero trust models in a way that you don't really have a LAN anymore. So yeah, it's quite complicated. Well, thank you very much. If you have any question, I'm here. The QR code and the link both leads to the tool that has been released yesterday, actually.
forget it.
Will you be attempting another multi-threaded version now that the global interpreter lock is gone from modern Python versions?
Can you repeat the question?
Yeah,
please?
sure. So will you be attempting another multi-threaded version now that the global interpreter lock is gone from modern Python versions?
For now, not really, since it's working well that way. However, if we start to have lots of filters that do more computing, more computation, maybe we'll switch back to something like this to speed up things. But for now, it's working quite well, so not really needed.
All right, thank you.
Well, more time than I thought. Basically, there were several iterations before I reached the final version. I believe we're talking about, I don't know, 10, 20 hours, something like that. So it's still a small tool in a way, but I kept refining it just to find the sweet spot where it's still simple enough so that you can tweak it, but fast and usable enough so that you can run it during engagements. So, and I wanted it to be able to run on live interfaces and on weak machines like Raspberry Pi, because specifically during physical intrusion, you may end up needing such a feature. So yeah. Yeah, for now there are the basic filters that are implemented in the other tools. We have several ideas in mind. Specifically, we want to do some passive reconnaissance a bit more. So like from the packet capture, you are able to know if a server is enforcing signing, SMB signing, for instance, and we want to be able to display that to the user as well. So we have ideas. If you have ideas, do not hesitate to create issues on the GitHub repo, or even better, to contribute to the tool. Everything will be looked at.
Will you do a pull request on Wireshark to integrate your stuff directly?
No, because this is really an independent tool. So we are running T-Shark, the Wireshark CLI, but it's really independent. We are just retrieving the output of this and parsing it. So there is no point in integrating it directly in Wireshark. Sure.
C'est qui après? Do you all hear me? I do think so. First of all, I'm just going to use this thing right here. Simple disclaimer, I will talk about radio hacking. Radio hacking, if you transmit radio waves, be sure to be in a controlled environment because it's illegal. I do think it's illegal everywhere in the world, so just be careful. My name is Bibo, but you can call me Noé Flatreau. I do work in information security. I am a researcher. I do formation, teaching. I talk about cryptography and reverse engineering. I also break stuff for fun and profit. The context of this presentation is just about learning an introduction about information, radio waves, how it works, and how to exploit it. For example, you can exploit many things, including a lot of networks, like information, like Internet of Things, satellites, cars, anything. And there's a lot of dependencies that works with radio, so we can exploit it. And there's a lot of cyber defense challenges because it's far away and mostly autonomous. So it's a lot more difficult to modify. It's a little bit clunky. The basics of radio waves and how we can transmit and receive data is just about sending signals. Signals is just a little information sent into the air about I don't know, a little bit of frequency. You do modulate the signal using a frequency modulator. You do encode it, and you send it with an amplified signal. It's sent into the air, and then received, re-amplified, filtered, decoded, demodulated, and then used for whatever you want. Before, we just used basic math to do this. I will not bother you with that. Just knowing that you just embed a signal into a carrier signal, and then you just send it. Before we did that with analog signals. Analog is a bit clunky, very expensive. It varies between the protocols and the frequencies. It's also very expensive. There's a lot of newly manufactured methods, and you have to change hardware because of it, and also it's very expensive. So we use digital radios. Digital radio is just about the same thing, but everything is processed inside a computer. So you don't have to demodulate it, decode it, process it, filter it. You do it digitally. So basically, it's just a computer with some signals in it. You just have to use a software that you can update. You don't have to change the hardware. And it does cost a lot less, a very lot less, like 10 or 100 times less. Same thing, but you just have an antenna, transmitter, receiver, and something to encode and decode it about analogically and digitally. Do you have seen those? This little dongle and this one? Whoop. Sorry. You can see those sorry. You can see those when you're using your car, for example, with the key fobs. You can use it with TNT radio, like TNT channels. Sorry, just. Ouais, mais ça casse un peu les couilles parce que. Ouais, pardon. Alors, attendez. Chut, on n'a rien dit, on n'a rien entendu. Working? Yes, 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 yes. Receiver, encoding, decoding. You can process it, send it, and then done. You do have this Ah, fucker. It's radio waves. Very efficient. I will not use the laser. Okay, so we do have little dongles and much more expensive stuff. You can use it for radio frequencies with a little bandwidth, for example, from megahertz to 2000 megahertz, 2 gigahertz, just before Wi-Fi. Or you can use the Akeref one, for example, that has a lot more bandwidth, so you can use 1 megahertz to 6 gigahertz. There's a lot of bandwidth that you can have. For example, the HF, the very well-known HF, shortwave radio for audio signals, like radio waves. You can use VHF for FM radio, and you can use UHF, television, satellites with SHF, and then you have the radio for astronomy and things like this, very, very, very high frequency. All those bandwidth are, for some, free to use, for some, very limited, and for some, illegal to use if you don't have the accreditations. In Europe, for example, you do have free frequencies, like around the 433 megahertz, the ETWIN 33. You also do have more bandwidth, like 203. It's around the same thing with Japan and Canada or US. You do have some bandwidth that are unrestricted, because not used, but I strongly not recommend you do this. And you do have some signals like those. Those are commercially used signals, for example, stereo FM, VHF. Have you seen those signals somewhere, SDR? Those signals are used for audio receiving, and also for data for the radio signals, the radio post in your car. You can see the audio signal in the first, when you demodulate it, and at the end, the data signal. You may also have used POXAG, the little beepers, you know. Those are a digital signal, so it's binary, modulated in FSK, frequency shift keying, so it's quadratic key. And you do have some very interesting, I will just show you. Do we have audio in this? I hope so. I don't think so. Very interesting signal, because you can hear data and you can decode it just using the sound. The bandwidth is only 9 kilohertz. You do have a narrow FM band, so it's very narrow FM. You do have a frequency modulation of 25 to around 932 megahertz. There's a lot of channels that are used for many services, like, I don't know, hospice or firefighters, I think. Sorry. FM. Maybe if I do this. Am I the only one? I just will use my keyboard. You also do have military systems, like Thales, that has some voice channels and scrambled voice channels, if you know about it, with frequencies that are not allowed to use or transmit in it. It's a different mode, USB mode, and you do have a more bandwidth that you can see. And sometimes, if you can see it, you can also see the scrambled thing, which is the same, but just you scramble it with a key. You do have the satellite, NOAA, for example, which is a geostationary satellite that is used for imaging, like meteorologically and things like this, which is just a simple binary system. It's also analog AM, so analog amplitude modulation. And it has very low amplitude when it's received. So you have to amplify it, filter it, and use it as is. So you do have a very bad image, but you can see some things. And you do have some strange signals that we don't very know how it's used, nor why, but we do have it. Is it fun? Yes. And how can we exploit it? You do have some replay attacks, just like man in the middle in using network. You can reuse key fobs signals to replay the attacks. I will show you the video if you want. I don't think it should work or not. But the signal is used with the key and the car. The key just sends a signal. Sometimes it's random signals. It's then captured using AKRF, for example, replayed and reused for the car. The replay attack is very effective on static keys for old, very old cars, or used in a very similar attack, which is roll jam. In French, it's brouillage et rejeu de clés. Roll jam is an attack for key fobs and keys, which are used for rolling codes in the key fobs. The keys are sending messages that are changing every time, so it's a sequence. And then the car just verify it using the same sequence. The sequence can desync at the time, but you can just jam some part of the car, the receiving part of the car, receive the signal from the key, just receive it, save it, and sometimes later, for example, just reuse the signal that were saved, reusing, and unlocking the car. I don't think I do have a video for this, but this is very fun to use. This is thanks to jamming. I do think that you know it. It's just white noise in a very wide bandwidth, and then reused for hijacking. Hijacking is just shouting louder than your neighbor. So you do have, for example, a receiver, GNSS receiver. You do have some very reliable satellites, and you just shout louder than him. And then the receiver, the one that wants your GNSS connection, just use you instead of all the other one. So you can spoof the GPS communications. And then you can hijack, for example, AM or FM radio for hijacking radio stations like, I don't know, in France, Urban, and just say bad things, which they already do. Radio waves are very efficient when you can split the channels. If you can see there, you can jam just one part of the channel that the car is receiving, and then reuse the part that is just after this. So you can jam someday or somewhere. The car will not see all the other frequencies. Just reuse the frequency and resend it later. And sometimes you can use EM. EM are, do you know about Van Heck freaking, which is a tempest attack? It's an attack that reuse HDMI emissions in the cables, where you can receive some emissions, filter it, amplify it, reuse it, decode it, and just see the screen. You can do it, for example, you have a screen there, a few meters away, send it, receive it, and reuse the screen, and just see what's going on. there's a lot of tools that can be used and coupled with AI, like convolutional networks, that can rebuild the image. Do you have questions for this? I think I was very fast, but I'm very happy to respond to the questions because I do have a lot of things to say also after. If I do have this after and after this. Do you have any questions about this? I'm better with responding. Thanks. Thanks. No, you don't need to. You don't need to. You don't need. Yeah. Fahrenheit freaking, yeah. Resolution? Repeat, just a question.
Enough to be put somewhere near a conference room.
It's it's passive listening. So you just have the little dongle there. Because EM are very frequent, you can have a lot of signals. You can just mean it, reuse it, and you can have a little station that you can see and check to get the signal. So it's very portable.
Thank you for your talk. My question was about what's the use case of jamming the key of the car? Because if you are jamming and preventing the car from receiving the signal, for example, if the user tries to open it or to close it, it won't close and he will try again. Or if you try it again, you will close it instead of him. So what's the use case?
In the use case of the car?
Yes.
Jamming is about unallowing the car to be using the key and the signal sync. So the car cannot see the signal that the key is using, but you can see it. So the car is listening on a wide band. The key is sending in a short band, just a simple signal. There. The car is receiving a wide band. You can just jam a shorter band, and when you mean it, the car just sees nothing, white noise. But the key is already sending, so you can receive it, and then when you stop it, you just reuse it, and it's always already working. If the car is desynced with the key, just you cannot unlock the car with the key, but you can reuse the signals.
Okay, thank you.
Thank you for the talk. I have a question also about the car.
Yeah.
So for a roll jam attack, we have a number n. That's the number of signals we can do.
Yeah.
How high is that number? Like, is it? Can you actually brute force the opening a car with such attack?
This is depending on the car manufacturer. Sometimes it's just a PRNG, like LFSR, just using this. Sometimes it's an obscure algorithm, but sometimes it's just like 4 or 8 bits. So you can brute force it. But if you brute force it, you desync the car. If you desync the car, just break it.
Okay, thanks. So ramp sessions now. Everyone who has to present something, just come on. Tu vas te filmer? Non. Alors du coup, tu passeras à la fin. On va faire d'abord tous les filmer. Puis au pire, vas-y, comme tu veux. Premier film, je m'en fous. T'as préparé ta rame du coup dans la journée? Est-ce que si vous voulez pas être filmé, vous allez passer après. On filme d'abord tout, ensuite on arrête. Voilà, j'ai laissé le nom du book. Ok. Donc tu veux être filmé? Oui, je m'en fais. Ok, d'accord, très bien. Donc toi, tu as dit filmer.
Je vais leur dire pour le micro. For the mic? Yes. C'est ici que ça choque. Soit tu pars comme ça, soit tu pars comme ça. Okay. Tu ne mets pas trop vers le menton, comme tu as un petit peu de barbe, ça va faire scratch-scratch. Okay. Je fais pas comme ça, parce qu'en fait,
Rump aussi ou pas du tout?
comme ça parle.
Oui, c'est le rump. Ouais, à pas être filmé. Parfait. Ouais, nickel.
Ok, d'accord, parce que moi je t'avais bien filmé, donc... T'avais pas précisé... c'est...
Quoi?
On peut commencer avec lui déjà.
Et il a accès aux slides ou pas?
Hein?
Elles sont où les slides?
Elles sont là-bas, il a dû les mettre.
J'ai aucune idée où elles sont.
Je sais pas lequel, hein. Après, je connais pas ce truc. Après, attends qu'il y ait le burst qui...
Let's go.
Test. So we've got exciting ramps for you. So each one has 3-4 minutes to present it. So let's start.
So hello. Maybe my slide will be showed up. Yes. Signal? Ah, no signal. Okay. I don't understand French.
That would be better if you...
Ah. You set up for me, man. Let's go. So a quick ramp about setup and tune an OTSOC for home labbing and professional setup. Sorry for the grammar misspell. I do it quickly. So who am I? I'm Aaron Cordier, aka BRL Corridor. I'm a freelance for industrial control safety and cyber physical system auditor and pen tester. So here my view on the OTSOC. You have multiple issues. The first one is that you have proprietary protocol that is not really integrated in the modern CM. So the idea is to standardize some specific behavior about this protocol. So you have a raw packet with custom protocol. You can make detection if you can write some specific alert to it. When you standardize the alert, like with Suricata, you can put it directly in a schema. So the objective here is to standardize the custom protocol, and after that you can put it in your SOC. So the CISA, for a long time now, made a project that is called ICS NPP for Industrial Control System Network Protocol Path that is written in ZIC, and the objective is exactly that. With that, they have put together a bundle of tools that is called altogether Malcolm ICS. The objective here is to take pickup data from industrial power plant with custom protocol. You can put Suricata rule on that, and with the custom protocol parser with ZIC, you can directly define behavior. FileBit will give some more context to it, and we'll put them in an open search. With that, an analyst can query data from the network industrial protocol, and you can put some custom protocol directly in it. You can scale up. Here you can have an example of how we can set up a big infrastructure with Malcolm. They have the HedgeDog sensor. That is the idea to dissect the protocol, add custom data, and directly with Logstash and FileBit, put them in the open search that is stored in Malcolm. You have here an example of Malcolm deployed in solar power plant in several places in the US. So it's a good example how to scale up Malcolm without using a proprietary protocol. The objective behind that is because the request from the private and public sector in the US is very big, and even the private sector can even follow up with the demand. So here's the dashboard with OpenSearch. It's a custom, it's a standard OpenSearch dashboard. In the bottom left, you can see ICS OT protocol, and this is the implementation of custom protocol from the ZigBee sector. We're going to take an example. There is several Nmap NSO scripts that can request directly with this custom protocol on the PLC, on the automat for doing industrial power plant stuff. You have that, and you have also Nuclei for detection purpose with those protocols. So you can't really have detection purpose on standard CM or NDR detection because they don't handle that. So some few can do, but majority do not. So after that, the Suricata rule that you can put on your custom will show on your OpenSearch dashboard, and with that you can query some custom behavior. After that, you can bundle behavior to define the overview of the detector rule and the log type and the correlation behavior directly on OpenSearch. So for example, if I'm a bad actor, I recon the PLC and I record this with some proprietary protocol. You can bundle Suricata rules directly to CME, and that's pretty cool. And after that, you can the FileBit and the Logstash can directly be put with other CM. This is open source because it's open source, but you can do it on Splunk and other CM. This is my test bed when I test my equipment. You have PLC on the left with a network tap for network duplication, because this is very important to not touch on the network data and not disrupt the power plant or the production plan. You can see HedgeDog connected with Malcolm sensor, and after that you can see directly the production and the IT part. If you want a deep dive, I have made a 6-part series on how to set up that. I really encourage you to read that one. Thank you for this one. And 5. The HD Michael Bellison. Yes, of course. How do I put the... Oh, we don't know. Okay, wow, let's go. It's kind of punk. This is rock. This is rock. So reading Serbian in JS at 3 AM. That me like 2 days ago because I want to have another talk at GreHack and I just remember that. So simple stuff. I search for a PLC and a router LTE or 4G on the internet, and I see this Serbian company that called GeneCo. Okay, GeneCo, M2M, GPS, ECR system, and go and more. This can be fun. So I take the Favico, the fav of my ICO. I take the MD5 hash, and after that I can say query in Shodan. Okay. So this is a pretty funny stuff because I was searching a provider and a constructor that put the same Favico on their website than on their router and stuff. This is quite fun because you need only to take the Favico of the constructor and it will duplicate it in every product. So it's kind you can pivot with that. Okay, I see some kind of 600, so it's kind a lot, and a lot of friends, so pretty funny in Europe, main Europe. Okay, so this is not my scan. This is a scan I found on the internet. And this is not the SSH access. This is the SSH access that my friend does. So I read the doc, and you can see the port 32571. This is no information about this port on the internet, or even in the documentation. The only country that do not have this allowed is a country in the Middle East. We can buy European stuff. I will not name it. Okay, so this is a port that is not really documented that connect to SSH to old Dropbeer version 214 and 2019. And you need to duplicate the SSH private key, or you need to add in SSHD SSH-RSA because the default SSH conf will not connect to it. Okay, smell good. Okay, so burp suite connection with login tentative. The login was stopped, though no request was sent to the backend. So we can see kind of thing resemble. Okay, we have a Unix timestamp, some by 64, B64. So cyberchef me that, and this is. I see ATOR $123. This is kind of resemble a password because the password that I just sent was administrator 123. Okay, this is a bit funny because on one endpoint there is a JS script with 1500 line, donc a very big line, a very big file. Maybe there is some function on it. Okay, send username password. This is very cool. So we can see how the password is sent. And you have a function that called encode URI component, and we can see that is used for the password and for the username. It will be cool to know how the password is encoding. So this is the encoding stuff that I take from the JS, and you can see administrator 123. Vive l'Algérie, je sais pas. So you can just take the JS on the front web server and just DH it. I don't know why, but there's here. Okay, this is the funny stuff because dash main is donnez-moi, give me. So I want to give me that. So there is only one function that we can request without authentication, and this is this one. So this is an information disclosure. You can see all the stuff that is enable or disable. So the activate OpenVPN SSH is enable. This is accessible. So you have all the information about what is activate, enable or not on the GeneCo router. And this is for all the GeneCo configuration of equipment and for all the IPs that you have seen. This is not really important, but quite funny. And you have a header of a GWT token. I don't know because I never see a reference to a GWT token on the big JS file. So we don't know. And after another stuff, all the static website is present directly on the front. So you just need to request the endpoint, and you can just extract all the static configuration page of the GeneCo, and you can make an honeypot with it because it requests just function from the big file. So you can make an honeypot from GeneCo if you want. Conclusion, I have no conclusion for that, and if you want a freelance, I am it.
faut en plein écran, lui. Comment je le mets en plein écran, lui? On va essayer toutes les touches. Non.
Function F5.
Ah, c'est en fonction. Okay. Thank you everyone for. Okay. Thank you everyone for being here. Sorry for those who were at Black Hats last week. It's the same ramp. So I needed help how not to inject a dependency. So I'm Valentin Pical, also known as Calcium, usually on Discord. I do pentests for a living, but I also like reverse engineering, and that's what I'm going to talk to you about. So, long story short, I wanted to read some Java classes from an Android application. Obviously, it was heavily obfuscated, and I wanted to have an execution of code in memory in order to dump the decrypted Java classes. So for that, I had to inject the dependency inside of the packer. So it is, to stay short, some compiled code that you have inside your APK that is launched and that will unwrap the Java classes in memory. The issue here is that it didn't work for skill issue, but fast forward a few months later, so I found out that Nozomi Networks did it, and using the exact same approach that I tried. So, ego alert, I had to understand what I missed. So, quick theory, in order to inject an ELF file, you have first to, it's heavily simplified, but you have to find the string table, add the name of your dependency in the string table, find the dynamic table, and add a DT needed type of entry which says, hey, I need a dependency to work, which points to an index in the string table. You don't have to actually know that, but because you have Leaf, which is an amazing tool that does it for you, and it's very easy and simple to use. But when I wanted to read, first of all, the dependencies of the packer that I wanted to inject, I couldn't even resolve the string table, and the dynamic table is very short. Usually they are much longer than that. So something is missing, something is odd, and what I should do now is try to reverse and understand what went wrong. But because life is too short, I will inject it and see what happens. So after using Leaf, the dynamic table would have my injected lib name. Then all of the lib dependencies would be resolved, which is surprising, and there are even more entries in the dynamic table, which is not standard behavior for Leaf. So what went wrong? And because it's a ramp and I don't have time for that, here is the plot twist. There were actually two dynamic tables, but when I would parse the file using Leaf, it would have this a different behavior than readelf, hence the difference in the results. So here is what the binary looks like in memory and on disk. And what you have in red is the big hidden dynamic table with all the real dependencies and the actually executable dynamic table. But you can see that below there is a smaller one that is not loaded in memory. And readelf will only parse the smaller one, which is a kind of fake one. Actually, it's not true, but I don't have time. But Leaf is smarter than that. It will compute the virtual address of the big real one dynamic table, and then when writing the updated dynamic table, it would write it at the position of the fake dynamic table. Hence the difference in the results before and after parsing. So you have a sort of representation of what it kind of look like before and after representation. And the final plot twist of why I could not inject this packer, well, it's not on why I could, more on how I could have done it better. It's that I tried to hijack an obfuscated library, but in any APK you have tens of other dynamic libraries that were not obfuscated, and I could have just injected them instead and have saved myself a few weeks. I highly invite you to read my blog and send me some messages if you want. And I wish you a nice evening.
And here, what's the full screen menu again? Present the slideshow. Yeah. All right, everybody hears me? Yeah, great. All right, so let me put my timer here and let's go. All right, so I'm Argi Janaki. I work at Cartesian Lab as a digital forensics investigator, and today I want to talk to you about how private VeraCrypt is on Windows systems, because we don't have time for much more. If you don't know what VeraCrypt is, I don't have time to explain, so go look online. So is it safe? Well, on the crypto side, as far as we know, it's quite solid. What about the traces of the application activity on the system? Well, if you check the box, then you're fine. Which box? This box, never save history. So, are you fine though? Well, from a VeraCrypt perspective, you are fine, but the actual issue is not VeraCrypt itself, because when you check the box, there's no history, that's okay. The problem is Microsoft Windows, of course. So, from a digital forensics perspective, what can we look for to rebuild user activity? A few examples here. Typically, some prefetch files are used to improve performance of programs by retrieving data and such. It's quite useful because it also stores the last 10 times a program has been run. The event logs, among other things, keep history of mounting file systems. The shell bags are the registry keys used by Windows to remember the folder display preferences, and there they stay in the registry even if the folders you accessed are deleted. And the jump list, another example, they keep shortcuts of recently opened files and folders, and these too stay on the system even if the files and folders are deleted from the file system. So what does it look like? For example, here we have a prefetch file of VeraCrypt format.exe. We see that there's been 3 calls on 3 specific dates, a few minutes from each other. VeraCrypt.exe, it runs on this toy example. Oh yeah, by the way, this is just a toy example, not an actual investigation, okay? And here it's the system events, where VeraCrypt is quite nice because it names its volume VeraCrypt volume, and we even have the volume that it's been mounted on. And when we look in the shell bags or in the jump lists, we see what folders were accessed inside this mounted point. But my container, it's still encrypted, so it's safe, right? Even though there's traces, what can I do? Well, not so much, because if you look at, with any decent digital forensics tool, you see that the encrypted files have a very high entropy, so it's not legit. Plus, if you look at the hex headers of the files, you see that it's not an actual zip file, so of course it's easy to identify that it's probably a VeraCrypt container. Moreover, if you look at the calls from VeraCrypt format in this example, you see that the run dates of the VeraCrypt format, are quite similar to the access time and the modified time of the zip file, so you can correlate these events to identify containers. All right, so let's summarize what I said so far. Windows OS keeps data structures and logs for improved user-friendliness, performance, traceability, etc. But during an investigation, all these are very useful to rebuild user activity quite easily. It's easy to identify also the files that may be a VeraCrypt container, but if your container password is strong, you're fine, as far as nobody can pressure you or threaten you to retrieve your password. So let's be careful about that. This talk could have been called How Private is User Activity on Windows, but I only have 5 minutes, so it's just a 2 example of VeraCrypt. What can we do then about this? It really depends on the threat sources you're considering, actually. A company needs these OS logs, data structures, to be able to investigate security incidents. But any private individual, an activist, a hacktivist, a journalist, any person really with high confidentiality and data privacy constraints will have to delete these items regularly. There are tools to do that. You can also consider not using such VeraCrypt things, but use virtual desktop hosted elsewhere, but this requires internet access, so it has some constraints. I hear somewhere people saying, oh, don't use Windows at all, but don't fool yourselves. Other systems keep similar traces just in other structures anyway. So the actual way to protect yourself is to do a proper risk assessment of your context, adjust the privacy measures you take and the tools you use to be protected from external attackers. Thanks.
Hi everyone. Okay. Hi everyone. Today talking about the new Grenoble hackerspace. So already in Grenoble we have a nice hacking community with SecuriMag that does weekly talks about security. It's the association that is doing GreHack, shout out. But it's good to learn, but we want to exercise, to do real hardware stuff. We need a place where we can do real hacking, like oscilloscope, talking oscilloscope, GTag Explorer, Bus Pirate. So there are already, of course, Fab Labs in Grenoble existing, but we want really something oriented cybersecurity. So not only 3D printer, we want to do cybersecurity. So we started it only 2 months ago. Okay. And we have already our office, so it's already 150 meters square. We have already a great place with a lot of stuff already, so we have things for computer, we have some place where we can just sit and relax, somewhere where we can really do some hardware stuff. And so some projects are already starting. For example, here we are doing analysis of routers. Just last weekend I went there. There were people that were repairing radio player, cassette tape player, and others that are thinking about doing hiding messages in MIDI keyboards messages. So really fun. And that really, maybe you saw our stand or previous talk yesterday, but here are some pictures. And also, what's important when we start a project is trying to federate other people. So that's why we started the ZIN, that is Inter-Hackerspace in France. So first number is here on our website. It's 9,600. With already 6 articles, I think, and we try to do it every 3 months. So the idea is to try to federate the hackerspaces. But so why I talk about this? Of course, it's for the people in Grenoble to know that it exists and it's open, that they're welcome. But also, so the thing is, it's really a personal project. So it's a Bimo, the guy that did the radio talk just before, that that is doing hardware hacking as an independent, and he worked from his home, and now he wanted to have a lab and share it. So shout out to him. And people just gather all the stuff and put it in the hackerspace. So it's growing well. But the problem is that we do it as a personal initiative, so completely without funds or sponsors. That's great, we are independent. But having 150 meters of lab, it's difficult to pay the rent. So we have some plans to pay. So for example, trying to find some sponsors. Hello. Hello, guys from Synactive, another, I don't know, wrote me. Nice to meet you. Also, we plan, of course, to do stuff like organizing some CTF workshop. The idea is to grow the community, maybe try to do some events that would be clever with other companies and everything to do this. Maybe some smaller events like helping repairing stuff or doing some IT helps for the community. And the idea is also to have memberships. And it's not expensive, so it's there is a price that you can put that is pretty small fee. And you can take a membership, even if you're not in Grenoble, maybe you want to help, or you can offer one to people you know in Grenoble, offer it for Christmas, for example. And so what you can do, you have only two solutions. On your left, you don't have much money, but you want to help the community grow, so you can join our Discord. And on the right, you are rich and you want to help people, help hackers. So you go on HelloAsso and see for a membership. And that's all the choice you have. Only this one or this one, and you have to join the community of the hackerspace. Thank you.
Hi everyone. Today I'm gonna tell you how did I seduce my girlfriend using the FCSC. The FCSC is a French CTF. So back to 2023, this challenge called Sensor Watch was about reversing a custom firmware of a Casio. It's just for the context. Then back to 2023, but a little bit later, a message from my girlfriend, which tells that she loves Casio. So the recon is finished at this point. Plan execution, 2024. The birthday isn't coming. 20 years old, so we have to be good. So the mind connection is made. It was not difficult. I ordered a brand new Casio, this one. I ordered the Sensor Watch PCB. I git cloned the Sensor Watch projects. And let's work. Here in the green you have the original PCB and red the Sensor Watch one. To flash a new firmware, it's easy. USB. You compile and everything is done for you. The only thing you need to do is to unsolder the little stick that you can see is the buzzer. So you have to take the initial one from the Casio and just unsolder and resolder on the new PCB. We assemble everything and we have a custom watch where you can basically do whatever you want. So now we need to find features. We don't have to forget the plan. First of all, random, kind word. Every day, random. Second feature, applied music on common. In this PCB, we can control the notes, the music notes of the browser. So this is the music I just played for her. Obviously, I'm not gonna give the name of the music. Mission success. A month and a half late. But the watch was packed in the original package, so double surprise. What we want is the comments from Demoiselle. It's the best gift I ever had. So the mission is accomplished. Thank you.
So now we saw all the ramps. You can vote for the favorite ramp that happened. So you can flash the QR code and the link should be available on Discord. So you have around 5-10 minutes to vote and we will announce the winner at the end of the closing speech. Thank you.
Hello everyone. I will take 5 more minutes of your time. I have it all organizer to come on the scene. So here we are for the closing speech. I promise this is the last talk or whatever of this day, and next they will go, our workshop or whatever. First of all, thank you all of us for coming. Thank you for trusting us years again. Thank you for being there, and I would like to thank some kind of person. First of all, I would like to thank the program committee, who are person who read and judge all papers, and who made the list of conference during the day. I hope you enjoyed all conferences. Also, a huge thanks for all people who submit a paper, even if they are not here today. We got a huge list of fabulous talks, so thank you for all. Thank you for all workshopper and speakers for today for being here, because without you, GreHack cannot be GreHack. And I would like to thank in advance workshopper for give a workshop now on 3 minutes ago. And thank you all speakers for being there. A huge thanks to the organization committee. There is some member of the organization committee who are from Security Mag, French and Grenoble Association, who stand here. Thank you also to volunteers. They are not people from the organization committee, but they are here to help us today, and thank you for their engagement. Also, a huge thanks, special shout out to Yul for the design, who made design during all the year long. By the way, she's in freelance if you need some cool design. A huge thanks also to Cooper at the backstage for the streaming video and audio. And thank you, everyone. There is some question about the budget, how cost a conference like this, so I will answer it fast. The budget is around 70,000 euro to our total conference, so thanks to a sponsor. And most of the budget is on food and goodies for welcome pack and event facilities like location of the place, of rental of the place. Thanks to sponsor, we can do cheap ticket for students, especially because for us, a cost of a person here is 200 euro around. Thanks to sponsor, obviously. Thanks to 16byte sponsor. Thanks also to 8byte sponsor, because there are many this year. We got some new sponsor to join the GreHack crew. So thank you all sponsor. Also, thank you for our friends. There are some old friends here, and especially Akonit was here today with their stand with old hardware. So thank you to friends also. For tomorrow, for those who have a ticket for the CTF, it was an option, so verify on the ticket if you got the CTF. Tomorrow it's not here, it's at NCMAG on the building H. It's from 10 a.m. to 8 a.m. And thank you for coming this year. See you next year, obviously, on the 13th November. And thank you again. For those who got the workshop, speed up, go, and there is some wrong place number. Yeah, ramp winner. Oh yeah, for those who don't have a workshop, after your workshop, you can go to the social event with at the same place of the break, just to drink and food and eat. And the winner of the best ramp is Kevin Mizu with the Trouble Bounty, who won a place for the next year.